trends is from the top cloud initiatives. If you see the top three are migrating more workloads onto cloud, moving some on-premises solutions to SaaS versions of the software applications, and then controlling what we deploy on the cloud. That's something that is happening today. The heavy usage there is around migrating more workloads and progressing on cloud first strategy. So a lot of industries are now pivoting their on-prem footprint into a cloud footprint, whether it's a cloud first strategy, cloud value strategy, or it is optimizing the cloud after adopting it as a strategy. On the right hand side, you see different PaaS services that are being used. And this is where some of my next 20, 25 minutes will be focused on. So when we talk about these industries and the fundamental shift that we have seen in the last couple of years is that from organizations and enterprises first thinking that my data needs to be in on-prem and my applications can sit in cloud, or let me use the cloud for a disaster recovery, they've started pivoting their thought process to now using services that are data oriented. It can cover data warehouses, it can cover the typical database services, relational services, and then they have application tiers, in containers as services, taking AKS as an example. So the PaaS service usage in the last few years has increased in these areas as well. This clearly notifies that the trend now is not just if when you're migrating the applications or workloads onto the cloud, the ideas that the center of excellences in different organizations, the different industries are thinking is that we need to not just move the application onto cloud, but we want to make sure that we leverage the best of the cloud. We leverage the intelligence that the cloud provides. And when it comes to intelligence in the cloud, there's a typical way that we can approach in Azure. So underlying all the intelligence is the data. Now you can consider there are operational databases. We have spoken about that in multiple bootcamps in the past as well. Operational databases like Azure SQL, that was probably one of the very early ones that Azure had. Then we have Cosmos DB that allows you to have unstructured data. We have MySQL, Postgre, Dataverse, MariaDB, all the open source technologies now available on Azure as operational databases. So think of it that if you have an application for which you now need to move into cloud, you have options of having operational databases move as is if required from your on-prem data onto the cloud. But that's where the journey just starts. The next step into this is around unified analytics platform, which Synapse offers. So when you try to bring data onto cloud, you start thinking, is my data clean? Does it need some analysis? Can I drive some intelligence out of it? Do I need to now take it to the next step where I define a mechanism where all my applications can access this intelligence, this common data that is now residing in an operational database and provide some kind of services to the applications? But as soon as you look at big data, as soon as you look at different services, data across multiple applications, you have scale at your hand. It's also important now to look at data and define what is the governance around this data. How does the change management happen across the data? And that is Azure Preview comes into picture. So along with these operational databases, analytics platform, and governance platform, together this becomes the data platform that Azure provides you when you move your applications or data into cloud. On top of it is powering through the AI. There are three different segments in this when we talk about AI. There are some contextual or situation or scenario specific services like the bot service, cognitive service, form recognizer, video indexers. These are services that provide AI capabilities for specific scenarios. You want to implement an enterprise search. You'd rather go with cognitive search. You have paper forms, and you want to make sure that you are now able to use AI and store the data onto Azure. You use a concept called form recognizer. You take the pictures of PDF files, transform and extract the text out of them, and store the data into operational databases. Similarly, Video Indexer helps you analyze the videos. Bot Service allows you to have a conversational AI with the end users. On the other hand, there are services which are a bit generic, but allow you to innovate, think, and incorporate them into an existing business scenario. Those are the cognitive services. So imagine understanding the text that the users are typing for your search, not just searching for it, but understanding the text and giving semantic answers, or looking through the video and finding out what the demographics of the users are. All those things will now be encapsulated are under the cognitive services. So these give you the flexibility of introducing AI into your applications, leveraging the data that comes to your application and then storing it into underlying data platform. And then you can move on to advanced machine learning, whereby you're actually looking at this data, big data, finding out trends, analyzing them, and then taking predictive or reactive analytics on top of it. But this all forms the data and AI component of it, which is where the data track 2 is today focused on. On top of it are the two different platforms, Power Platform and Azure App Platform, that allows you to democratize this data and then surface it through your applications to the end users. Talk of Power BI. Whatever data you have collected, you want drill down reports, going into any depth, you can use Power BI to do that. Your Power Apps, low code platform, just makes it very quick to roll out applications for MVPs and pilots. And then you can also roll out applications within your enterprises at the production scale. You have virtual agents that allow you to use SaaS-based models if you don't want to have a PaaS-based chatbot to have conversational AI. On the Azure front, you have functions, scale of serverless, Kubernetes container instances that allow scalability and serverlessness in the containers. You have logic apps and API management that allow you to expose your data and make an economic model around that. With this stack, industries are now looking at reversionalizing their applications when they migrate these applications, their existing applications, onto Azure. A little bit double click on Purview. Azure Purview, just like I said, sits on top of your on-prem multi-cloud. We recently announced this to make it as a Microsoft Purview that allows unified data governance across the clouds. So imagine this tool doing discovery in an on-prem multi-cloud or a SaaS sources across any of your data sources. This can create a data map for you automatically, help you then create a data catalog, which is where allows the end users or the developers to find out, where do I find this data? What is the sensitivity around it? What is the lineage around that data? And then you can drive insights. Insights is, how does this data get created and used across your organization? So if there are applications consuming this data, you get that information that this application is consuming this data in this particular fashion. So across your on-prem multi-cloud anywhere, this is something that you can get onboarded even today. Most of the organizations that have petabytes of data will be struggling with how data governance can be provided to all the databases and different data warehouses. This is a very good solution that you can adopt today if you're facing that same situation. Now we'll go a little bit deeper on Synapse because that's one of the tools that actually brings simplicity along with scale. So you have data and you have data tasks and you have data teams. All of them today use different tools. You have, for your data ingestion, you have a different tool. For your processing, you have a different tool. For storage, you have a different tool. And Synapse has an umbrella of tools that brings that unified experience and provides you scale. So think of it this way, that you have a Synapse Studio, which allows you to import data models, integrate them with existing systems, monitor them, manage them, and then make sure that you have a DevOps cycle around it. So regardless of where your data resides today, it sits in an on-prem system, accessible via firewalls or through express routes, or you have data on cloud, any cloud, or you have streaming data coming out of IoT devices, you can bring all of that into Synapse and then work on it. So it also means that, let's say that your data today is in traditional RDBMS sources, SQL DBs, or in Cosmos DBs. You can now connect those databases into Azure Synapse to do the analytics. We started Synapse with just SQL-based analysis, but late last year, I think last year, and may not be late last year, we introduced Spark-based pools also to run within Synapse that allows you to run your Spark notebooks and jobs all within that. And then there's Data Explorer that allows you to run Custo queries. If you've used App Insights or Data Explorer earlier, you would know how quickly you can write queries and pivot this data for the purpose of visualization. So it kind of brings an end-to-end platform. Now, where does the industry see the Synapse getting used? It's a combination of Synapse and industry data workbench. So if we go a little bit deeper into how industry is now using Synapse with some of the scenarios that we talked about in the beginning of the keynote, we have data ingestion coming from different platforms. It could be Oracle databases, SAP, Amazon, things on Azure, Dynamics, Salesforce, anything, or relational databases using Link. You bring that data onto Synapse in the data lake. You build these data stores. We'll go into detail of how this entire process works, but then that data gets utilized in a common data framework, the common data model framework, which means you are actually creating an analytics model around it and then performing the computation of serverless or provisioned way using SQL or Spark modules. All this thing can be done in Synapse Studio, but the beauty is that once you do this analysis, you can get an extract of this data using any of those languages or protocols that you see there. So choose a language of your choice. The underlying data platform for analytics remains the same. Your underlying data bases remain the same as you would like from an on-prem world. Or in a cloud-first world, you can introduce things like Cosmos DB, much more mature in handling unstructured data, and then build this common analytics platform that collates information across these different data sources. The key thing here, what Industry Data Workbench then offers, is around logical data modeling. So think of it in this way. Let's take retail as an example, and I'll take retail, show some examples of retail, how Synapse works with retail. In retail, there will be different segments, different types of things you would want to do. You would want to have order management system, you would have customer management system, you would have loyalty systems, all those systems in an on-prem world or in a cloud application. When you look at modeling this on Azure, the Herculean task comes as that, all right, I get my data ingested, but if I have to accelerate building this model on Synapse, do I need to start from scratch, or do I leverage certain things that help me accelerate this journey? That is where Industry Data Workbench helps in bringing some industry models right within Synapse so that you don't have to start from scratch. So think of it in this way. You have different models, different industry models. In Synapse, you can download that model into Synapse, and you can then customize it to say, this is my derived model. This is the model in which I'm going to create my analytics pipeline. And you can keep modifying that derived model. On top of it, which you convert into a star schema, you customize into a star schema and create an analytical model. All these things happen within Synapse through the Industry Data Workbench concepts. So that defines your one side of the pipeline where you have a model defined. The other part is when you start ingesting the data from source systems using Synapse pipelines. So it collaborates all that you've seen in Data Factory. It brings in capabilities of Spark. It brings in capabilities of HD Insight, machine learning, all into that single pipeline, or multiple pipelines if you want to, and bring that data in a transformed way in the data lake Gen 2. So you have hierarchical data put into your Azure Data Lake Gen 2, which then uses the analytical model. And then from there, you create separate orchestration models, whether it runs on SQL pool or Spark pool, your choice. And you can have pivoted data for visualization in Power BI, Power Apps, Azure Apps, whichever way you want. So this kind of accelerates your journey of making sense out of your data, bringing intelligence into your applications, and making your apps intelligent. In by the way, so if we take an example, this is a retail example, something um, that I just spoke about. On the left hand side, you see the highlighted ones are the different tables that the industry model, standard model offers you. So you can see the number of tables that each of them bring out, right? So if we have to talk about budgeting and forecasting, you have 42 tables that talk about budgeting and forecasting. And naturally, when you talk about budgeting and forecasting or contract or claim, you need a relationship or entities with different domains within retail, right? So a claim will also require a contract or a customer. So when you go and say that, let me do a build an analytics on top of claims, uh, industry data workbench is smart enough to build in the data model, a customized data model that selects different entities across different domains of retail. And then what you can do is you can go to the next step where you're now saying, I want to ingest the data. I want to develop my code that looks at different aspects of this data. So you have a lot of options there. You can use typical Synapse tools. You can use Azure Data Explorer, Azure Functions, Databricks, um, machine learning, all those things. You can build and create an interactive pipeline. So if you have existing investment into cloud, you can leverage those and now build analytics on top of it. So imagine you have relational databases from different applications. One talking about claims, second is managing the chatbot. You have data for customer claims and chatbot communications, all in different databases. You bring them all together from different ingestion sources. You, regardless of where the data resides today, create a pipeline that merges this data and creates meaningful interest on what demographic of data is asking for most amount of claims, or who is chatting with the chatbot, what are they querying about. All those BI capabilities now come from different varied sources through a layer of governance with Azure Purview in Synapse, and then magically help you with the visualization. So you can build those pipelines, and at a point in time when you want to copy data or bring in data, you get by default zero code capabilities from different sources. It could be on Azure, it could be on other clouds. So you can bring those data sets into Azure. Last thing, there are endless possibilities with data and AI. You can talk about building a modern data warehouse, which uses Synapse, uses event hubs for different kinds of data. You can look at ML-driven forecasting in applications. It runs on how do you create an ML compute cluster where you can do feature engineering. You can have featureization, training of models, registrations, and you can use Kubernetes and Synapse and Power BI to showcase that data. You can have real-time analytics coming from IoT sensors, where you can actually ingest, store, prep, train, model serve. So this is something that we have seen happen in the cloud a lot. I was involved in one of the engagements where we captured IoT data from fields or places where there was no 4G connectivity. So how do you use the gateways to get this data into cloud and then run analytics on where the accidents can happen, or from scenarios where you are traversing in the lift and you want to capture the telemetry from different IoT devices in the lift and determine where can I first put when does the lift first need the maintenance. So all those real-time analytics can be driven with the architecture that you see today. On the left-hand side is around modern data, modern applications built on IDW. We spoke about it in detail. You can explore these possibilities. A lot of these architectures are on Azure Architecture Center. So the real question now is, what is your next gen innovation? whether you're in whichever industry you are, if you are not innovating, if you're not thinking about how you are capitalizing data, which is the new oil, um, the question that begs is that will your applications become legacy soon enough? And what is that soon? Is it the next year? Is it the year after next? So think about this. There are many sessions in the track two that will double click on some of these technology platforms that will help you think about innovation that you can bring into your industry and revolutionize your application, your data to make them more intelligent. With that, I'll pass on the baton to Faisal, who will talk about the underlying infrastructure and security that makes this innovation reality. Faisal.
Faisal, no audio. Faisal, no audio. I think you need to check your audio.
Faisal, you may be.
Yeah, I guess check. I mean, uncheck. Is it no?
Yes, yeah.
Yeah. Give me a second. Let me pull the screen to other screen as well. Okay. Thank you. Okay. Right. Thank you so much, Puneet, for the wonderful keynote on the application and the data. You have covered various topics, and a lot of new things that people need to focus on, especially the companies need to work on, right? Great. So now I might turn to talk about the underlying code, which is also another area that whatever the improvement that we are bringing on the table. Right? Hey, my name is Faisal. I'm a product solution architect, part of the customer architectural engineering team, which is a part of the global team I'm involved. So we take care of the various strategies, various stuff in the industry. So one of the things is actually today I'm going to cover what we are working on the back end, right? So if you look at the, this report, especially from the Information System and Audit Control Association, which is released in 2018, you can see that, 91% of the business leaders are seeing the digital transformation as a way to sparking the innovation and finding the efficiency, right? And 85% that people sees that either you offer a digital service or you become irrelevant. And 68% of the digital transformation increased profit. 64% they say no, they have a 4 years to complete the digital transformation, right? So this is what we see in 2018. Now with the pandemic and COVID-19 and everything, you can see this reality is already happening in the market, right? Every single business that you see actually trying to provide digital service, because without digital service, they can't survive. That is the reality that we see in this pandemic. So now even small business and everybody is transforming. They are actually trying to provide one other way of digital services today. Okay. Then if you look at the other thing is actually is, other hand, yes, we understand there is a digital transformation required, but change is difficult. As you know, we all human, we all understand how to change in a single habit in our single, even in our life. And we are trying to change an entire big organization. This change is not that easy. Even you want to learn something new today, you have a struggle and you need to put your time and effort to change, right? So same thing here is as well. So we understand the changes here, impact people, culture, and also, you also feel risky. So one other thing is actually is change is important. Without change, nothing will going to be constant, right? So it won't be, stay. So we must change. Okay, we need to take a risk. We need to learn quickly. That's also another important piece that we need to take care of here. And the other thing is actually is, change also need to be in a cultural shift, in this thing. Okay. Now, look at the trend and industry that is happening. One of the thing is actually is changing is one of the cloud configuration tools is one of the biggest things that we need to look at. everyone is want to automate, everyone want to do something is better, right? So if you look at the tools perspective, the industry is actually moving, trying to use Azure Resource Manager template or Terraform, or if I take another cloud provider, the respective tools they are trying to go. It's not just only happening through one area. It is also happening through various things like enterprise cloud configuration tools is actually happening something, and if you take the SMB is happening something as well. So that you can see the trend between these two is almost identical, right? You take the resource template as how much of it the enterprise using, how much is actually is the other team the SMB is trying to use, almost identical. Okay. Now, if you look at this, right, there are actually is various things that you can see here. Implementing and automating of policies and governance is actually is another area that the people are trying to do. Okay, uh, you know. That is a third priority for every industry is trying to do. Okay, then there is an optimization of workload, which is a first priority, and progressing of the cloud first strategy and migrating of more workload to the cloud. These are the things that we can see based on the survey in 2021 that we have seen, or even 2022 survey that we've seen here. Okay, so this is what we can see in general. So what we are, as a Microsoft, we are doing to address this part, because if you look at the heaviest part, one of the things is actually we need to take care of here is how do we address this? How do we help enterprise to make this life easier? So I'm trying to cover three areas today. Is one is the framework for Azure. Second is actually is what are the solution accelerators that we are building, and what is the governance and compliance piece that we are trying to do. Okay, these are the three pieces that we are trying to I'm trying to address here. Okay, one. Let me go through one by one. The first one is the framework for Azure. So if you take that, right, we have developed a two framework, one for Microsoft Cloud Adoption Framework. Okay, the second one is for a well-architected framework. Let me cover the Microsoft Cloud Adoption Framework. Basically, what we are trying to do here, the Cloud Adoption Framework is an enterprise modular framework, okay, that you can increasingly onboard to the cloud. So basically, we can walk you through step by step, to onboard you to the cloud with a shift of your cultural changes, skill upgrade, even in the workload that you want to bring onto the cloud. What are the steps that you need to take, right? We can help you to do. There are proven enterprise guidance that we can try bringing on the table to help you to, accelerate your journey in the cloud. So, for example, you are trying to migrate the existing workload. Okay, if you are trying to migrate existing workload, what I should do? One, first you need to understand, who are the stakeholders. So, you need to get an agreement with the stakeholder. Why I need to migrate this to the cloud. Second, you need to align with your partner. The partner can be your internal IT system partner, or it can be your service provider or Microsoft services or programs that is available for you to help, right? You just need to identify what is a partner that you are looking for. One. Second, once you identify, then you just need to collect, gather data, analyzing asset and workload. Basically, you just need to understand, okay, I'm trying to migrate workload A. What are the inventory for this workload? Okay, what are the dependencies that I need to do take about? So if I just want to move, can I move just this simple workload? If I'm trying to move the simple workload, is there in a firewall is requirement is there? Is there a firewall is there in the cloud? Is there a network requirement? Is there a log requirement that I need to retain? What is a data strategy I need to take? What are the integration point that I need to take? Right, all this that you need to collect. Right, we have given you guidance one by one what you should do for in these areas. Then what type of identity that you want to use. Then make sure that you have business case for this. Then you can also make a migration plan. There are a lot of tools, lot of guidance that we have providing on this area to migrate your workload to the cloud. Then once you have done, right, then you can start thinking about how do I upgrade my skill, which my team skill. Basically, what we have seen trend there are traditional IT in the organization. There are non-traditional the new cloud team in the organization. So basically, what they are trying to do, the cloud team is trying to go and accelerate and fasterly migrate workload to the cloud. When it comes to day-to operation, they are very much depending on the traditional IT. The traditional IT is not upgrade their skill set. So there are a lot of barriers, a lot of pushback coming from the traditional IT for you to bring down or actually is put a lot of controls inside, right? There are a lot of red tape they can bring it on. So one thing what we are trying to say here is while you are trying to migrate, please bring your traditional IT inside and make them to upskill so that they are confident to maintain or actually continually to support your day-to operations, right? So bring them on board, make them to upgrade their skills as well. Then you decide, which deployment of landing zone that you are going to go and put it. I will walk you through what are the accelerators that we are working on this areas as well. Then you identify the workload that you want to go. Then you can go on to, hands-off day-to operations and managing it thereafter. This simple realization of how do you migrate your existing workload. Let's say if you are changing your scenario to, no, I'm not going to migrate my workloads. I'm going to build brand new products and service in the cloud. The definition of this, the same steps, but actually each area that you pick a different type of, things that you need to go through. The previous one you saw there are 10 steps to go, 10 items to look after. Now you have only less 6 to look after, right? You understand, you define your business strategy, you evaluate your business, justification, gather data, plan or assist or migrating, or actually, the next is define your, governance, which is very important that you need to do here because you need to be clear on your governance piece. So once you define your governance, you define how do I'm going to manage this, operationalize on this. Then you deploy a landing zone, then you can innovate to the cloud, right? So this is another area that you can think of. Then the third one is unblocking the environment design and configuration. This is the important piece that you need to take care of, because you are going to define your environment design and configuration. So this is where your landing zone conversation come to picture, or the different type of workload, different type of thing that you need to do. Because there are certain workloads need a low latency, certain workload can go into better than that, right? So you just need to define what type of environment that I'm going to build for my entire organization. So each environment can be different. Generally we call it, different type of environment, UAT, prod, pre-prod, and all those things. But here we are talking about even in the prod itself, a different environment. So there is a certain environment for meant for low latency workloads, certain environment for highly transactional workloads, certain environment meant for simple workloads. So how do I define that? How do I able to land that? We have also giving you a guidance for all these areas. And not only that, you can also find your path. There are so much of documentation, so much of help that is be put in place. Okay, so you can walk you through. There are a lot of videos that we have given. We build not only that, we build a lot of templates for you to use. So you can go to this specific, documentation page. You can actually download templates. You can assess your starting areas on everything. This is one of the things that I just want to bring your attention to focus on. So this is one area. The second area is what we call it is actually Azure well-architected framework. The well-architected framework is the center of the pillar. So this is very important piece that you need to take care of because the center of the pillar is very important to your organization. Because this helps you to build a workload with a confident and proven best practice. Because this is very important because if you build the workload with confident, right, and also with a proven best practice, you know how much reliable that you get to the systems. That's one of the important piece. Then the performance point of view, you must have a high performance on your workload. Okay, you shouldn't wait to whether this workload will go down when, what, I don't know how this is done. No, you just follow or actually review. You know where is the gaps are exactly for your systems. Optimizing the workload, right? So One of the thing is actionable, focus area that I need. It's just not about a simple review report that I see, yeah, everything is good, I just put it. You go to your doctor, you are trying to examine your health. So you get some actionable outcome, right? I have a cholesterol, I have a BP, I have, diabetics. What are the actionable that I need to do? Similarly, you have to optimize your workload, you have some actionable detail of this area that you can get outcome so that you can make use of this actionable outcome to optimize the workloads. So these pillars actually, the well-architected frameworks covers in mainly 5 pillars. First is actually if you take a cost optimization. When you look at the cost optimization perspective, pay as you go. Today you may running as a pay as you go. My workload is growing. I'm running over 24/7. How do I make use of there is various program that is available in Microsoft to optimize my cost? Can I able to transform this to reserved instance? Can I able to use often off-peak workloads? Can I downsize during weekends? All this kind of thing that you can evaluate, right? You can control, you can able to optimize your cost. Better to make your ROI is best so that your organization is able to make use of this ROI and able to optimize your entire cost. Second is actually is if you look at the operational excellence. If you look at the operational excellence point of view, how do I build reliable, predictable, or design, especially when I automated my deployment, because I'm not doing the portal to go and click and deploy. I'm basically automating entire my deployment. When I automate my entire deployment must be reliable and predictable. Okay. Also, I need to monitor my workloads, how I'm going to efficiently monitor, how I'm going to make a performance management of my entire thing, right? This is one of the things that you need to make sure that your operational point of view, day two operation, the day one to day two of operational point of view, take care of every aspect of it. Then the performance efficiency, right? I want to have a lower maintenance cost and I want to improve my user experience. I also increase my agility and architecturing my entire solution, right? And I also want a scalable solution because I build something. There are certain product limits I can't scale. That doesn't going to work, right? So one of the things that I got a code. You are trying to build the 99.99% of the reliable architecture, but the entire component that you build with many things, but when you come to one item on the component is actually the one of the product is giving you only 99.9% availability. What is your resiliency or actually is the high availability of your system? Is it 99.99 or actually 99.9? Even though you have 100 components in that product, but one product is actually is 99.9, which means your reliability or actually your high availability is just 99.9 because that one component goes down. Whatever you build with 99.99, it's everything go down. Doesn't matter. So you make sure that your entire tool set that you select is actually matches the highest item or the lowest is your HA or the high availability requirement. That's very important piece that you need to take note of it. Don't take always higher than. These are the things that will help you to address by this well-architected framework and help you to build. Then the reliability. The reliability is very important piece, right? So one thing is actually is how do I scale out my entire infrastructure? Okay, in terms of my business growth or in terms of my disaster recovery scenario or high availability scenario. How do I build my reliability in Microsoft? That Azure, we have availability set, we have availability zone, we have actually also we are having in a regional resiliency patterns, right? Which one you are selecting, what you are going with, what is your options are, right? Those things we talk about more detail in the reliability areas. I have been working with one of the customer who actually is trying to build biggest B2B e-commerce portal and trying to build the reliability score. And we have been went in and did the entire architecture, and we managed to provide the better reliability moving them from one Azure region to another region and trying to build the entire reliability, better. So that these tools help you to identify the gaps of the entire thing, right? Then the last part is security. When you actually build your solution, you must build with security in mind, or secure all the services that you're trying to build security in mind, and trying to automate all those things as well, right? So these are the things that are very important piece. So this helps you to all these 5 pillars will ask you is a number of questions when you go to our well architected framework. It says self-service. You can also engage Microsoft partner. You can also engage your Microsoft Cloud Solution Architect to walk you through, or you can also do your self-service framework as well. You can go to the portal, you just click. That will tell you all the questions that you need to look into. You just go and answer, yes, I'm done this, I'm not done this, I'm done this. So one by one, you can do it. When you do it, it will tell you what is your reliability score against your environment. Okay, this is very important. Then based on that, you can be able to determine whether I need to review my architecture, whether I need to do. By doing this entire thing, what you do, you will be building a reference architecture for your implementation. You're also able to identify the gaps, right? That's one of the things. So these are the 2 framework that I want to cover in terms of addressing the operational excellence and areas, and the cost optimization areas that actually is the industry is worrying about, right? This is what we are working on. One is cloud adoption framework. Second is well architected framework. Okay, please make use of it. We have put a lot of effort, a lot of things on this area. This is the emphasis that we see enterprises looking after. So if as a community that you guys are here, if you actually get upskill or level up yourself on this area, this help you to have a better conversation with your customer or your internal IT teams, right? One. Second is how I actually able to optimize my entire workload, or sorry, accelerate my deployment of workload. This is the second piece that we need to take care, right? One of the things is actually what we've seen, there are some specialized workload that is available in the market, okay? Especially if you come to, VMware solution or SAP solution or virtual desktops, all this kind of specialized, or even Kubernetes, right? All this kind of workloads needed some special skills or actually some special design elements that we need. We see that not everybody, traditional IT users come to the cloud, as all of them are not in the same page. They require a lot of guidance and a lot of acceleration to implement this. So we see this trend across global. So what we did actually as a team, we put together, we build the accelerator for you to help you to accelerate the deployment. Okay, so another thing that you see here, this particular page that you see here, this is actually for VMware solution, right? What we are providing the design principle guidance for you. We are providing you, how do you identity and access management should look like? What is the network topology connectivity should look like? Management and monitoring, and disaster recovery, security, and also automations point of view. All this point of view that we actually be giving you guidance. Not only stopping you, just giving you guidance, we also follow this entire guidance. We build the accelerator for you. Okay, so this is the landing zone design that you see. Okay, if you look at this landing zone design, here we actually build the accelerator. You can able to deploy the workload into Azure, right, with these accelerators. So one of the things is actually you can see here. Let me bring my AVD accelerator. So this is AVS accelerator that you see. Okay, you can see here there is an AVS enterprise scale GitHub page, and then you can see that there is a greenfield deployment, there is a brownfield deployment. We click a greenfield deployment, that you can see that how your network architecture is look like, what are the things that you need to do. Okay, all of them is taken care. Then there is actually an implementation reference. Do you want to do via portal? Do you want to do ARM template? You want to do Bicep? You want to do Terraform? Okay, all the options are given for the tools perspective. Whichever tool that you are familiar, you can use this specific items to go and explore your item. So you can go to Terraform. If you are familiar with Terraform, you can go to Terraform. All the Terraform files are actually scripts are already available. If you are actually comfortable with Bicep, you can actually go to Bicep and you can deploy Bicep as well. Okay, you can click Bicep, then we also build the Bicep template. Okay. So just given a couple of comments that you can able to build. If you are looking for ARM template, you click this link, it will take you to the portal, then actually give you the portal experience as well. Okay, so all of them is readily available by clicking a single click that you can able to go to. Okay, same thing happening for SAP, because SAP is another big specialized workflow. Okay, what we are trying to do for SAP as well, if you look at this SAP, right? So one of the things is SAP required low latency, proximity grouping of VMs. So example, if you are putting these two VMs, it must be very close to the storage account, very close to the network equipment that you are putting in. So if you are going to do all this thing, do you have a control to put it in cloud? There is a way to do it. If you understand the proximity group concept in Azure, there is a way that you can able to group them into all your servers and equipments into proximity group, which help you to put your resources closest to the place, which is a low latency that we can milliseconds of latency that we can able to get it. Okay, so this architecture talks about all about that. Okay, then how do you can implement, how you can able to deploy those, right? So there is actually also accelerators available for that as well. So if you go to SAP page, you can able to get the accelerator for SAP page as well. Okay, so that's another accelerator that you can see. I'm not walking through that at the moment. Okay, so now the next one is actually is AVD, right? So Azure Virtual Desktop is another big piece that you can see. We also build the accelerator for Azure Virtual Desktop. Okay, so we are also giving you a guidance to how to deploy the Azure Virtual Desktop. It also comes with the 3 flavor of Bicep and Terraform, and as well as for ARM templates. We are not stopping there, right? If you look at this, we have built the accelerator for various platform, various items that you can browse from this web page, and you can able to see what we have been working on this areas. So all this actually, you can also see that if you go back, every area that you can see that there is actually what is a design area that you need to go, what are the implementation options that you need to take care, right? You can see that whether you are going to for small scale or big scale enterprise, that you can see design area that you need to look at. So please explore all this, in your left side menus as well. There are a lot of options, or you have a lot of information that you can able to get across. Okay, this is another piece that you need to look into. So the last piece actually is governance and compliance piece. So one of the important thing to take note of, governance and compliance is very important for for the industry. So especially if you are operating industry like regulated industry, it could be a government industry, healthcare industry, or banking industry, right? So there are a lot of regulators is actually around. The regulators want you to comply the workload that you are bringing onto the cloud to make sure that they comply to their regulations or their controls, right? So we hear this for a lot from the various customers. What we did actually, we put together a team to build the Azure policy package or governance for this. Basically, you can see here, this is for the one of the items that you can see, RMIT Malaysia regulatory. So if you are customer from Malaysia, you can actually trying to deploy financial workload into Azure. You can just go to the Azure, then you can apply this policy initiative. Basically, this policy initiative will provide you whether the workload that you deployed in Azure is complies against this regulatory compliance or not. Right? How efficient and how easy for you to deploy and monitor your entire workload. Okay, so basically we try to group them. So we have did actually for various compliance things. For example, you have CIS benchmark, you have a FedRAMP, you have a HIPAA, you have various things that we have in. When you go to Azure portal, basically you will be able to see this as a package. For example, for RMIT Malaysia, that you can see is here, right? You just need to go here and apply this policy into your workflow. This policy can be applied at the management group level, or resource group level, or subscription level, or even at resource level, right? So you can apply this policy. Once you apply this policy, it will take effect of your start monitoring, or actually able to do three things, right? One is actually, if you are define any prevention, which is deny rules, it will actually deny. If you actually set up any of your detection, which is actually monitoring whether the resource that I deployed is a policy, is a comply or non-comply, it will tell you detection mode. Or if you are going with a compliance remediation, you did something but you want to automatically remediate, it also does that as well. Okay, how do I know which resource is actually is really is comply or non-comply? Is there a way for me to look at the categorization of everything based on my audit, my regulatory requirements? Yes. You go to Microsoft Defender under regulatory compliance. There is a tab for you because we're RMIT for Malaysia. Then you can add on, this is an add-on. Then you can add on this specific controls. Then you can able to see based on the regulatory category, you can see that cybersecurity risk management, whether my resources actually comply or not. Okay, so that you enable to see visually is which resource actually comply, which resource not comply. How do I able to take into the next levels, right? So these are the things that you can see in the overall perspective. So today is what Puneet is covered all about is application and data security events. There are so much of things happening in Azure, but we can't cover everything in 30 minutes. That's why I decided to take a three important area to help organization to make faster based on the faster, the survey report that we see. One of them is actually how I'm able to, optimize my workload and improve my deployment faster, and also govern, secure, and govern my environment. So I just focus on this three area, and I have given you the update on what we have been working on at the back end on this area. Hope this helps you, for your thing to accelerate or actually bringing workload onto the cloud. That's all from me. Thank you so much for with me. So we have 5 more minutes. We are happy to take any questions or any of the stuff that we need. Yep. Any questions? We can unmute and ask.
Super, folk. So nice seeing you, first of all, Faisal and Puneet. Now that Rivet has, got his camera app as well, so nice to see you as well, Rivet. And thank you very much for, super information. Here's a question, and more perhaps to both of you, actually. With the preponderance of Microsoft's orientation towards end users and empowering end users, themselves actually becoming a center of IT, if you will. And I'm looking more at Power Platform right now, which we never had, at least in my 25 years of work experience, I never had, right? It's the best thing that has happened to me. I'll admit it, right? However, you need ancillary services to go along with it, which is kind of going to be my topic next. Is you look at like data lakes or like, storage accounts and things of that nature. How do you see that marriage happening? Because traditionally, the Azure side of the house has been more enterprise IT focused. And then you have this entire body of work, as another, pillar on its own. How do you see the marriage happening?
Let me take that one. So I briefly covered that in the earlier part of my keynote, where we have the overarching framework of applications provided both by Power Platform and Azure applications. Now, Power Platform promotes low code or citizen developers to start writing code, to start developing applications, not write code, on top of some of the services. Now you look at Power Automate, you look that gives you enormous capabilities to integrate with different systems. You look at Azure AI that provides endpoints, REST endpoints that can provide data to the Power applications, right?
Right.
So
Right.
that becomes a layer of integration across applications that run on Power Platform and enterprise applications that run on Azure or on-prem or other clouds.
Correct.
Underlying them is your data strategy.
Correct.
Your data strategy would be different platforms or data stores that would be ingested across a different data, or will have application specific materialized views and all those kind of things. So the possibilities of integration are enormous. It's just that the different patterns around which you can now take Power Platform, Power Apps, Power Virtual Agents, and then integrate back into the systems that have the source of truth for data.
Right. Right.
Yeah.
Great perspective, Puneet. I mean, for me, it is actually more along the lines of people, for the simple reason when you look at a large organization and an IT organization, they usually are program managers. And then they outsource it to like the Dimension Datas of the world or whatever. They're also program managers. And then you keep going down the chain and somewhere, you have out in Kazakhstan, somebody actually doing the real stuff, right? So on the other hand, you have end users who themselves are now empowered. Here you have to go through this program management office basically to leverage those services. That's where I've seen some, how do you say, gaps, if you will, to be able to connect to leverage those rich services, which are absolutely fantastic. You have to go through, the end user has to go through all these channels to get to that, to even provision, let us say, an Azure storage account. I have to go through such a headache,
Yeah.
So is there anything that you guys are doing to cut that layer, where I can go directly leverage the Azure services?
Okay, so one of the thing is actually, just walk you through, that's one of the reason actually we are trying to put together various solution accelerator right here in this space. So if you look at this accelerator, right, this will open the eye for many organization, many people, which exactly that you're asking, right? It's just Power Up, not just standalone app, even though
Correct.
it is a thing,
Correct.
but it need to work with various backend system that
That's
you see
right.
here. You see here, these are the accelerator that we're building in on it. Okay. So this is the first step that we have been putting together to see, all this accelerator. There is readily available solution that you see here. Okay. So you just go here to GitHub repo, then you build, whatever that you want, you can pull it out and you can able to do it. For example, potential risk analyzer, maybe you are one of the business unit required. Then they can able to take this as a item. Then they can just go to this particular page and talk to your IT. Hey, look at this is what Microsoft suggests. Actually, I'm trying to use this piece, but I need to have all this backend pieces to be done. Right.
Correct.
So this is one of the best way to start your conversation architecture, because most of the time that we stuck without reference architecture, without talking to them reference, right?
Right.
Hope this accelerator page that I'm showing you help you to overcome. Then you can talk to the backend IT team, which is a cloud team, and telling them, hey, I need actually a sandbox environment, or actually I want to have a test environment.
Correct.
So once you get a test environment, you can click deploy. Then this all services will deploy.
Right.
Then their internal team able to go and evaluate. Okay, let's say I already onboarded this Azure Kubernetes service. I already onboarded this, but I'm not onboarded, Power Up and virtual agent, which I need to be done, right? Let's do that. What are the security requirement to go through? We have to go through the pain. There is no choice, because that's how the team is built with. That's how the entire operation has been built, right? We have to respect on that. But that is one of the reasons that actually, if you notice, just now I showed you the regulatory page, compliance page that we are building. We are trying to build across services, right? Right now, the focus is on Azure, but we are working on Power Up. We are working on the Dynamics. We are working on other areas to build the same kind of accelerator, the regulatory compliance as well. Once that is built, then the things will be much more easier.
So I think Sanjeev, as Faisal suggested, right, there are accelerators that help on the technology front, and then there is a cultural aspect of an organization, which somewhere the team needs to be, the implementation team needs to be aware of how they have to navigate within the organization to make sure the backends can be accessible to the citizen developers.
Yeah, super. Super.
All the best
Thank you
for
very much.
All right. Thank you. Very interesting discussion. for this session, and thank you for the keynotes to
Thank you.
Faisal. Yeah. So thank you. Any more question from the folks on the floor? If not, then we will go to the next session. So thank you. Applaud to you guys. Thank you.
Thank you. Have a great
Okay.
day. Enjoy learning. Thank you.
Okay. Thank you.
Bye.
So
Rivut, will continue for track 2 in the same meeting, right? The
yeah,
guys
so
who are in the track 1, we will start the separate Teams meeting now.
correct. So track 2 will continue on the same meeting, and
Okay,
for the
I'll go and join track 1.
yeah.
Thank you.
Okay. Thank you. Okay. Sanjeev, you can check your. You can. And it is. All right. So the next sessions is Sanjeev. So Sanjeev is, I admire him because he is very creative. He takes, like the Lego, create that things with power apps. So I'm very exciting to hear what is he have now for the dynamic storage from drone to the Azure Data Lake Power Apps. Yeah. So he has a 20 years more experience for the in North America and APAC. He's a founder and CEO for Prudential Consulting. And yeah, so Sanjeev, your sessions. Thank you very much for the kind words, Rivit. And first of all, I got to say, thank you very much for giving me this opportunity to being here with you folks today. Truly means a lot. This is actually a special event where it's a congregation of all the services, and then you get to meet so many great people. I mean, typically we would have done this, face to face, but the unfortunate circumstances, and we have to do this, online here. The other thing is, I want to thank everybody for making time on a Saturday away from family to being with us today. So thank you very much. I just noticed that some of my images over here have actually, kind of disappeared on me. But that is absolutely fine because the focus is this was just going to basically say, let me just check the visibility over here. I'm going to actually, this is the background here. I'm just going to say true for now, right? I mean, this was supposed to be, the entry, and I was going to actually introduce myself, but very simply put, I'm a community member, right? And I got to thank people like Rivet in front of me for inspiring me to take up this journey with the community. It's probably the best thing that has happened to me because the learning over the past 4 or 5 years has been off the charts, right? I wasn't doing anything of the sort over the past like 10, 15 years. My engineering days actually ended in 2005, after which I was completely on the business side. This has brought my engineering roaring back. So I have to thank you for rekindling that love for especially on the software side, right? So my perspective here and taking off of what we saw, before, and many thanks to Puneet and Faisal for talking about the depth of services and the possibilities, and then what well architected actually means, is a perspective of the power user, right? It is not so much about, and before I get into that, I'm just gonna do candid camera over here for a couple minutes, say hi to everyone, and then I'm gonna take myself off of it because we'll need the camera for other stuff, okay? So let's go. So essentially, my perspective is actually going to be of the power user.
And this is for various reasons. And of course, these are end users, but over and beyond this, they actually control a lot of the action within your enterprise organizations, right? As an example, if you are a power user design engineer in manufacturing, you're the one who's actually putting the bill of materials together that actually gets the module bought by the customer. So you control millions and millions of dollars, right? So it is very, very important for us to put the power where it belongs with that power user, right? Which is exactly what your power platform is actually doing. And as Puneet and Faisal mentioned, the ancillary services that actually come in to support someone like that it's amazing. Then the possibilities are amazing, right? So what I thought I would do is, from that perspective, talk about Azure Data Lake, which is basically, among many other things, storage to me in a the Power Platform-esque scenario. So give you why do we need this in that kind of scenario, in that space, is first establish the need, right? So we'll talk about a couple scenarios. One is a request for quotation or request for proposal in the manufacturing industry, and see how this actually helps that process and how important that process is, right? The second one, as I think one of the guys was actually, I think, Rivit, you were saying preventative maintenance in a cross-industry scenario, right? It could be in manufacturing, it could be in, let us say, construction industry, it could be in logistics, wherever it is, preventative, maintenance, right? So we'll look at these two scenarios. From there, we'll actually, once the need is established, we'll dive right into the process. How do you get your ADLS up? How do you get your images and, let us say, 3D models from various sources? That's where your drone, etc., comes in. It's one among the sources. And then how do you access it within your Power Apps environment, and how easy it is to actually access it for you to form a process around it. Okay, so that's kind of the story. And then we'll quickly talk a little bit about security and governance and so on and so forth. And then we'll close with some Q&A. Okay, so with this as a general introduction, we'll actually get into, scenario one. So this is a scenario that involves people, and this is a true scenario, and I could, put myself in this. I was a design engineer in the automotive. I used to work for a Japanese parts manufacturer, and it was based in Michigan in the US, right? The plant, or the manufacturing plant, was actually in Mexico, among other places, right? So this involves the information worker, me, and then people.
Thank you. Sorry, just to are you sharing something? Because I don't see
Jesus,
anything.
I wasn't sharing my screen. Oh, that is so terrible, man. So, my goodness, thank you for stopping me, because this is okay, because that was just an introductory thing. So, it's good, right? So let us focus on this, right? So thank you very much, sir. So the point here is that I was a design engineer among many others based in Michigan. There was program managers, and then you had the management and the salespeople, so on and so forth in Michigan. And then you had the factory. So you had the plant manager, the production engineers, and the production workers, right? So the scenario here is that today is a Friday. It's a Saturday, but imagine today being a Friday, and we have an RFQ from the customer, right? And it could be from Toyota. There's an RFQ. We need to turn that around and respond back to the customer in a week and a half's time. A week and a half's time in manufacturing is not a whole heck of a lot, because when you do the bill of materials, first of all, you need to go through the design and make sure it meets the requirements as you're doing the RF. Then the other complication is you need to test some new components before you put the pricing on it, right? So here, that's the goal, right? And let us see that the production worker essentially on the floor, right, in the factory in Mexico, when the person receives the bill of materials, the person has to test a particular component on the shop floor, cost it, and then send it back to the program manager in Michigan, right? So that's the scenario. So let us see what happens as is. So the worker actually gets the bill of materials in an Excel format, fairly typical in manufacturing organizations, right? Why is this? By the time I generate the bill of materials, put it in an application, get the requirements, first of all, out to IT for them to build the application, I would have lost time. I will not have the time for them to take a week to understand the requirements, take another 3 weeks to go build, and we don't have the time, right? So And here the implication is huge because this module was 1.9 million units per year, and it was approximately $250 per unit. So every year you're looking at $500 million worth of impact, right? I do not have the time to sit and like give the requirements to IT to build out. It's my butt on the line for $500 million per year, right? So I would like, we would, put everything in a bill of materials. The program manager would send it to the factory, and the production worker now is looking at the bill of materials. The person then has to look at a part number, go back to the computer-aided design system to verify the part numbers because there are zillions of part numbers, perhaps look at the ERP to actually reference the design, and then the person will most likely have to call the design engineer who's sitting in Michigan, right? And you can just imagine the difficulty, the design engineer speaks English, the person in Mexico speaks Spanish, and these guys have to talk about a complex component and then come to an agreement on it, right? You can just gauge the difficulty here. And when it's the bill of materials and when you're rushed on time, you're making changes, right? So you have version histories, complexity built into like sharing all this good stuff in this scenario. Then the person has to fill out an Excel-based requisition form, chase the manager, this is classic, chase the manager for the approval, and then send over this to the vendor for approval, right? So you can just imagine for $500 million, such a deep impact, the process that is involved is so crappy, So you could go wrong in many ways over here and lose that deal, right? So let us actually see how this new scenario would actually benefit us, right? So first of all, you have the BOM here, right? So this bill of materials is from the design office. It is, shared with the factory. So you have one source of truth, right? And then the data that is actually sitting out here, if you're really pressed on time, you could just cobble it up, with an SQL server, let us say in Azure, you could just dump the data there. Or if it is easy for you, you could just cobble up a SharePoint list and then like put the data there. Or you could use Dataverse if you have the licenses for Dataverse. Dataverse to me is a gold mine. It's a consolidation of many Azure services in and of itself, and it has business process, so you could dump it over there. So it's one source of truth that is gold all the time. If I make a change here to the quantity, that is, percolated everywhere, so everybody has this. Here comes the interesting part, right? Now I can take this 3D model. This is no joke, huh? I could take this, I could feed it to my 3D printer and get a 3D part to do rapid prototyping. So I could test it really quick. It would probably take me about 4 or 5 hours to actually print this. Then I could take this very component, I could actually feed it to an injection molded machine and actually print a plastic gear, right? I could literally print it, right? And this goes into the assembly over here. It's one among the components of this blower, right? Never have me as a design engineer and a production worker being able to see the bill of materials and the component together in one place with security. Here, I've got layers of security. So assume that this, this 3D, model is actually stored in your data lake. And then this data, let us say, is stored in your SQL Azure, or let us say your Dataverse. I could build out security and governance in such a way that if I don't have permission to see something, I will not be able to, right? I'll only be able to see. All those can actually be built in. Now, it's fantastic, right? So basically, I immediately see this. Then I could, this application is on my phone, on my Teams. As I'm walking the shop floor over there, I could just pull this up. In fact, I get a notification as soon as the bill of materials comes down to me. I get a notification. I open this up. I have a question to the design engineer. Let us say it's Friday evening now. The engineer has left the building. He's going to the car or to the MRT or something. Historically, what would have happened? If I called the engineer, first of all, I don't know whether the person would take the phone. Let us say, the person takes the phone, he or she will say, hey, look, I need to go back into the office to actually like pull this up on a CAD system, look at it and respond back. Why is that? They're working on like thousands of components, not just this one. So they'll have no reference when you call them, right? Now, the same person can answer, he has the same, or she has the same application on their phone. So they basically see the same exact component on Teams, right? You call them on Teams, they pull up this application on Teams, they see that same exact component, they say, hey, look, the finish on this is supposed to be X, Y, and Z, and you're all set, right?
So then Friday evening, what you do in the same exact application, you go in, you basically make a new request over here, right? And then you say, hey, look, I'm going to see all my requests as well. I see my, let us say, crank or whatever it is, some bracket out here. This like loads that particular component. And this is done in the mixed reality feature, if you will, within Power Apps. But the data is actually being fed from your, what do you call this? Data lake, right? The data is coming from the, we'll see that very shortly, right? And once this actually loads, because these are 3D files, it'll take 30 seconds to load. Once this is there, I can go and fill out the quantity, enter it, and then submit this. I have whoever the approver is, select the approver, and then save this request. Now the process is started, right? So now imagine the plant manager is the one who has to approve this, and the person is walking the shop floor. Ping gets a request on Teams. He has the same app. He knows exactly what I'm requesting, approves it. I'm not going to do that here because that's not the scope here. And then the request is done. So much so that by next Tuesday, I have the component. I can put the cost in, and by Friday, the program manager can work with the sales to send the quotation to the customer, right? So the process now becomes incredibly efficient, and then it gives the team a chance to do more to win that deal, right? That $500 million pot per year, right? So the impact that you have on the end user, on the information worker, as well as the production worker, the production worker is going to be a consumer, the information worker is going to be the designer, is amazing. So now you're opening all kinds of doors, right? So with this, this is one scenario, right? Now let us look at another scenario. So to do this, I'm just going to go over to my LinkedIn over here. And this takes literally a minute. So what I'm going to do is I'm going to minimize this guy, and I'm going to actually reshare with sound. Okay, so I'm going to reshare with sound here. And kindly let me know if you folks can actually hear this. It hardly takes a minute. Okay, so kindly let me know if you folks can hear this. Driven by drone. Can everybody hear this? Kindly, if one of you. Greetings, everybody. Can? Folks? Anybody? Can you hear?
Yeah, can you hear?
Okay, so let me actually play this really quick. Hope you're well and staying safe. Here's a quick example of preventative maintenance using a drone driven by Microsoft Power Apps, Azure Blobs, and some Python code, among other things. So what we have here and in sequence is using Microsoft Power Apps and some Python code to fly the drone to an access point of the equipment, an AC unit in this case, which is hard to get by manually. Now, using the same Python code, we take pictures here, and I'm going to actually tap on the space bar to get a couple pictures. And save this to the Azure Blob store. Sorry, someone was saying something?
No, is it taking picture automatically, or we have to control by clicking it?
Well, you could do it automatically too, but then in this case, I'm actually manually tapping on the space bar to do this. But you could automate it from Azure IoT to Central, Yeah. Good. I refresh the store here, and as you can see, there are 3 pictures that have been recorded. And if I were to actually refresh the Power Apps here, I will actually see the images show up in our gallery. So what I could do is select a particular picture, indicate the AC unit, and the rest is fairly straightforward. I basically go in. Yeah. So, let me describe this, right? And Rivet brings up a very good question. Hey, look, are you manually doing it? Are you automating this? So it depends, right? So sometimes when I look at this, right, if I'm looking at this, I may not get a clear enough picture for me to get an automated picture. So I will orient the drone to the right exact place. Then I want the control as a customer service representative or a technical representative to actually click the button, right? So that's one scenario. The other scenario here is that you go up to an access point. Let us say in this scenario, you want to turn on a pump, right? And that pump should be turned on automatically. I shouldn't have to go up there, put my hand in and expose myself to all kinds of dangers. I mean, you're in the attic somewhere. So in that scenario, what I would do is I would have a barcode here, right? So then what I would do is I would put the drone up there. The drone camera basically scans the barcode. The moment the barcode is scanned, I take that output of that barcode and I bring it to the farm, send it to IoT Central, and then IoT Central will actually send a command to start the pump, right? So I could automate that as well. It just depends on the scenario that you're looking at to do this. I mean, you could either automate it or you could keep it manual. Does that help, Rivit?
Yeah.
Yeah. Okay, so let us actually, now that we see these scenarios, and you can actually see how powerful these can be, from a remote assistance standpoint, from a productivity standpoint, many times you don't physically even need to come to the place, right? You could just ask someone to say, hey, look, turn on this, IR camera, whatever it is, or you could turn it on remotely from your premises, monitor what's going on in that environment. If there is a need, then you actually come down. So it saves, your technicians' visits as well, right? Lots of possibilities. You could have robots in those spaces. The robots could be on rails, as an example, something like this, like really quickly, right? If I go over to my posts, kindly give me just a second, because this is also mixed reality over here. And I'll tell you what I was actually trying to do with this, and what I ended up doing was completely different. Okay, so this one here, I'm not going to play this in the interest of time, right? So basically, you see this engine that's actually going down the rails. Now, in this scenario, I just turned it into before I destroyed this engine, I said, you know what, I'm going to do a mixed reality scenario that for architects, who are designing railway museums, or even for general architects who are using buildings, you could use mixed reality over here and then have wonderful conversations with your customer, right? As opposed to like blueprints. The point here is what I was going to do was strip this engine, and then you actually put an RF, a scanner on this, right? So this is a scenario in logistics. You have boxes in the aisles, and then you have a rail running the length of the aisles, right? And then you put the RF transmitter is in the boxes, the RF scanner is on the train, and the train actually makes its way up and down. Instead of a drone, you use a train. It makes its way up and down the aisle, and then you can actually scan for empty spaces or something like that without actually having to every day take stock of like what's going on, right? So that's another example of actually using the system, right? ADLS obviously has all the images, and then your Azure IoT, and then your Power Apps or whatever else, right? So you're bringing multiple Azure services in to make this possible. This is yet another sort of scenario, and these are kind of real. In fact, I'm actually working with a customer to do a little bit of R&D on these sort of things, in a logistics place, right? Anyway, so this is the reason why nowadays with your, how do you say, power users, with, some specialists within your IT teams and certain consultants, you can get into some amazing scenarios that you would have never actually were able to do before, right? I mean, just imagine doing something like this 10 years ago. It's impossible, right? So with this establishes the need, if you will, for ADLS and these sort of scenarios with end users. So what I'm basically going to do is I'm going to actually cobble up a ADLS, and I'll tell you why a data lake versus a storage account very shortly, right? So I have my resource manager here. As people were saying, your resource managers could be used in two ways. You could either have all the resources for your application, let us say, in one place, or horizontally. If you're an IT guy looking at many different SQL servers, you could put different SQL servers into this as well, right? So what I'm going to do here is I'm going to go create a resource, a storage account over here, right? Start with storage. And then I have my subscription, etc. I'm going to give it my storage name here. Say I'm going to say Azure Bootcamp SV, right? Sanjeev, okay? And then I'm going to select like a location over here, South Asia, which is closest to me from the perspective of latency. I'm going to say geo-redundant. So this depends. If my solution actually crosses like geographies, then, I won't say locally redundant. I would actually do global. It just depends on the scenario, right? Then what I'm going to do is I'm going to actually go ahead here and then ask for a hierarchical namespace. This is the difference primarily between a pure storage account and your data lake, right? Among other things, right? So over here, the point is that if I say hierarchical namespace, I can get security down to many different levels, to the actual file that I'm going to be storing, to the folder in which the file is, to the container in which the folder is, and to the overall storage, right? So I can have security up and down. And there is a definite place for something like that in larger organizations as you enable these for end users to do their applications, right? So with this, I'm just going to actually, for now, just say review and create this. Required information. Okay, what did I miss over here? It's always fun, isn't it, when it is basically asking me for tags. I don't want any tags over here. Let me just go back here. Did I screw up something? Basics. Let me just see. Field can only, okay, this one. 24, okay. BC, I'll say BC and SV. Okay, this is the naming, right? Lower characters and name must be 3 to 24 characters. Well, it is 3 to 24 characters. What's wrong with this one? A, Azure. Look at me, right? So Azure Bootcamp SV. Okay, so now I'm gonna say this should be fine now, right? And I'm gonna say hierarchical namespace. Okay, so I'm gonna say review and create. This should be fine now. And let's create this. Okay, so this is initializing. It'll take a minute or so for it to actually go through. Now, once this actually goes through, it gives me an Azure Storage Explorer, right? That I could actually, it's a thin client that I could download to my PC and then operate directly from there. While this is being deployed, let us actually see how I was able to get those 3D files, right? The starting point in the manufacturing setting the 3D files would be a CAD system that looks like this. This is a computer-aided design system called SolidWorks. You have other things like Ideas, CATIA, so on and so forth, but this is one among the main ones that you would actually use. There's another from PTC that Microsoft actually works with. I grew up on that. So you could actually have a full-blown car assembly over here, right? And this usually is on a very heavy-duty machine, maybe a Cray, so on and so forth. You could do all kinds of simulations over here. From here, what I do is I would basically go save this file as what is called as an STL file. Okay, so over here, you say STL file. These are triangulated files, basically, right? And I store that as a triangulated file. Then I bring this up in my, what do you call this, 3D viewer, right? If I go here and then say 3D viewer, it'll be on your PC here, your 3D views. You bring this up, and then you can import STL files. So once you import these STL files, what you do is you basically save this as a graphics file called as a GLB file, right? So I save this here as a GLB file. Once that is done, and then here's the other thing, right? Every little nut and bolt and spring, I'm not going to create a 3D model for this and save this. Only those complicated components that require attention from the factory, from a costing perspective, where we don't screw up on like 1.9 million units. That's where I would create the 3D files and then actually make a GLB file of it and put it on the application, right? So once I have this GLB file made from the 3D file, I think our resources here, it is actually like, if we go to the resource over here, and then this is how do you say, a little like me today, a little slow, otherwise it like pops up immediately. So we'll give it 30 seconds or so for this to come up, right? And while this actually comes up, I'm just going to go over to my Azure Storage Explorer over here, right? So I'm just going to pop the Storage Explorer up here. And this is what I tell people, some of my customers say, they say that, hey, look, for images, not 3D files yet, but for images. So classic example, I'm doing an art test I'm a medical doctor. So for my organization, I am validating if somebody has done their art test or not. That's history, but, imagine, right? So then when I'm designing my Power Apps application, when somebody actually takes a picture of their art test, then I store it in a SharePoint library. Storing it in a SharePoint library, it's for us, it may be easy, but for end users, it's not, because you have to convert the binary conversion. You have to use a flow for it. You have to put it in a, how do you say, library over there, document library. And then you bring the IDs, correlate the IDs with the ID that is actually there in your SharePoint list, all this gobbledygook, right? I don't have time for all that. Can I do it? Of course. Do I have the time? No. So then what you could do is you could just dump those like images over here, and you will actually see how ridiculously simple it is to actually connect this to your application, okay? So if I basically say refresh over here, this is my Storage Explorer, you will actually see if I open up my subscription here, you will actually see, I have got one storage account, pure play storage account. I also have this data lake over here. You see the one that we just created, right? So it is actually saying ADLS Gen 2. There are friends over here who would use data lakes for all kinds of things. The moment you mentioned that data lake, it reminds you of the Atlantic Ocean, right? For us end users, no, we don't care. To me, this reminds me of your Windows Explorer. That's it, except that it's got a layer of security. That's what I'm interested in. Whether somebody puts all kinds of big data over here, pulls it into Databricks, does all kinds of AI stuff that is at the end of the day useless, no, I don't care, right? What I care is I want that deal. I want it done really quickly. So I'm just going to go over here to my container, this blob container, and I'm going to say, hey, look, create a blob container over here. I'm just going to call it 3D files, right? I'm just going to call it 3D files, right? So I'm going to be storing my 3D files out here. So what I'm going to do is I'm going to go over to my, this guy here, Windows Explorer. Looks like there is a lamppost or a water tank here. Let us take this lamppost is a small one. The water tank is a bigger file. I'm just going to drag and drop this over here. Behind the scenes, there is Azure copy that actually copies this over to, the storage account. You could automate all of this with PowerShell and so on and so forth. I have no time for it because I'm only going to be looking at 5 or 6 critical components, right? So I dump this here, right? And then we'll talk about security later. There is a difference between doing it here in this blob container and doing it in this storage account. If this is a pure play storage account, okay? This is not the hierarchical namespace. So I have stuff over here as well, but there is a difference between doing it over here and doing it in your data lake. We'll talk about that in some time, right? So once I have cobbled this up over here and put my 3D files here, then it's actually time for me to head on over to my application to pull this information to that, right? So this is where it gets interesting. So what I'm going to do is I'm going to go to my application here. I'm going to go back into my application. And then what I'm going to do is I'm going to go to my last screen here. There literally is nothing on the screen, right? So there is a bunch of controls over here, text controls and labels and so on and so forth. I need to now connect to this particular data store, right? I need to connect here. Now, there are 2 ways of actually connecting to your data lake, right? If I'm actually reading files and doing, your big data, whatever, and consuming some of those output into Power Apps, I will connect to the data lake itself, right? I could also connect, even though this is the data lake, I could also connect to this storage account over here because at the end of the day, there is a storage account embedded. I could connect to the blob, right? This is a blob store, so I could actually connect to the blob, right? So let's actually do that. Instead of connecting to the data lake here, which is the connector, I'm actually going to connect to the blob. So let's see that. So if I'm going to go over here and then say add data, if I say Azure Data Lake, see there's a data lake connector. I'm not going to use that. I'm actually going to go say, give me Azure Blob Store, right? So there's my Blob Store. And then I'm going to add a new connection. Now it's actually asking me for the name and my primary key, right? And you could configure this with access control lists. You could basically, if it's a vendor who is doing this for a very short period of time, someone like me, you could give me what is called as a SAS key, which expires after a period of time, right? So that I don't have continued access to it. You could do all that good stuff, but we'll come there later. So what I'm going to do is, this is called Azure BC SV, right? I'm just going to say Azure BC SV. There you go. And then the storage access key over here, if I go down here and then right mouse on this guy, I'll say copy the primary key, go down here and control V this and connect to this. There you go, right? And it's saying, hey, this is a premium feature, blah, blah, blah. Of course, I get it. It's a premium feature. So my data lake is now connected to my app, right? So then what do I need to do? I need to actually access this particular root, right, which is your Azure. So the storage account. Once I access the root, it'll give me the ID for this particular container, right? This 3D files, it gives me the ID. Once I know the ID of that, then I can actually pull the actual file and then add whatever control I want to add, right? So let's do that. So I'm just going to go over here. I'm going to say insert, and I'm going to get a data table over here, right? I'm going to get my data table over here, right? Like so. It says data table 1. I'm just going to say data table, DS1. This is my demo screen. And this one, I'm going to actually say in the how do you say the source, I'll say, look, I want this blob store one, I believe, right? It was blob store one, right? So then I'm going to actually say list the folders, right? List the folders over here, and I'm going to say give me the value of those, right? List root folder. This should be the root, right? So I'm going to say list root folder and give me the value. So I'm going to actually add the ID of this, let's say the display name of this, the e tag, and the ID, right? I want these three over here. And there you go. It has actually given me this ID, right? So it's actually given me these, tags and IDs. So I can actually refer to this, right? And I can refer to this ID. Now, once I have this guy over here, right, I'm going to make this a little smaller. I'm going to add another table over here, data table, and then I'm going to move this guy over to the right like so. And here, once I have the root, I can actually get this ID and list down. I'm going to say this one also points to this Azure Blob 1. And I'm here going to say list folder v2, and it's asking me for the ID here, right? It's asking me for the ID, and I'm just going to say, hey, this ID is actually in the data table ds1, then whatever is selected dot my ID, right? Where is my ID? I'm just going to say ID, and there's my ID, and then give me the values that are actually there inside it, right? And there you go. Once I do this, this goes away and actually gives me, if I go actually add the path, so I'm going to add, let us say, the display name, and I want the path, right? So I can actually now get my lamp post, and I can actually get the path to this. You see it is saying /3D files, right? So now if I go over here, right, if I right mouse on this, I can actually say copy URL, right? That's one thing. However, before I do this, I have to do two things, right? One is that I need to go over here and set the if I go here, right? And I need to set the public access level, and I'm going to say, hey, look, this is going to have, let us say, public access to both the containers and the blobs, right? So I'm going to apply this. If I'm in the enterprise context within that particular, quotation, I'm not going to obviously do this. I'll have layers built in. But for this one, I'm going to do that. And the second thing I need to do is I'm going to go over to my Azure storage account. This is still refreshing. It's a bit like me, a little slow, right? So if I go to my resource over here, and then if I scroll down here, configuration, there is this core settings, right? You see this core setting. This is basically, and I have a cross-origin sharing basically across different domains is what this is, right? From your blob. So you need to set this, and then I have a blob around this. So when I did this particular, what do you call blob, post, whatever you call it, there is a little bit of reference to this. So you could actually go refer to this and set this up yourself. Is that I'm going to say, hey, look, any particular domain is fine, allowed domains. And then the method is going to actually get information. So it's a get protocol here in the methods. And the rest, I'm going to actually leave this as such, right? Which is exactly what this says. So I'm going to leave this, and I'm going to actually save this guy, right? So this is actually saved. So if I now go over here and right mouse on this, and if I say copy URL, this is a 3D model. So if I put this up here into my browser, it is not obviously going to load the 3D model. If it was an image, it would load it. But let me do that as well, right? So I'm going to actually go over here from my other storage account. Right now, I don't have an image out here in this, right? So let me actually go to like this barcode here, right? So I'm going to get this right mouse on this. I'm going to copy the URL. This is a storage account, right? And if I paste this here and enter, you will actually see the barcode, right? The reason is I've set my core settings. I've actually set public access, so I'm able to see this image now. In a 3D model, I won't actually see anything because it's a 3D model. It needs a special viewer, right? However, I can actually grab hold of this URL here. This is my tenant. So basically, I can grab hold of my tenant over here, right? I grab hold of my tenant. Then I go back into my application. What I'm then going to do is I'm going to actually add a label out here like so, make this label a little bigger, right? And I'm just going to paste this here, right? I'm going to paste this here. So that gives me my label, right? And then I'm going to say whatever is actually data table, is this two? I see that's why naming is very important. So dot selected dot path, right? I've got my path here, right? So now I have my full path to this one. You see, I've got my full path in my application. So then all I need to do is go to mixed reality and just add my, so I'm gonna make this a little smaller. And I'm just gonna go over to my mixed reality over here, like, the 3D object, not the image. I'm gonna delete that for a second. I'm gonna actually add a 3D object, right? So this is my 3D control over here. Make this a little bigger, like so. And then instead of this link over here, I'm basically going to say label3.text. There you go. And lo and behold, my 3D model is in, right? So this is a full-blown 3D model I'm in. So I've used my Azure Data Lake and I'm talking, right? How long did it take? Like 3 minutes, 4 minutes? It took as much time for me to do this, as much time it took for the storage account to get provisioned, right? So within a matter of like no time, I've been able to do this. And if I had multiple files, simple, go ahead and actually do this, right? So this is one example of getting your, what do you call this? 3D models into your Power Apps, right? And then you can form a process around it. You can do whatever you want to do with this, right? You can make, add a camera, place this inside the camera, add an LED inside that, blah, 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 whatever you want to do, right? So this is one thing. The other thing is basically, how did I get that image off of the drone? So what I have here is my interface with the drone is through Python code, right? So the drone is unimportant in this case. It doesn't even, it's an endpoint, right? It's a camera, basically. It's not a drone. It's a camera. For what we are talking about, it's a camera, right? So I might as well, I'm sitting here, I might as well use my own camera. If I go to, I think I was playing around with this, right? So yeah, there you go, right? So over here, I have a Python code from which I'm actually like streaming through my camera here. That is my PC camera. If I were to say connect to the drone, I could use a library, the drone library, and then connect to the drone and then say video stream on, just like this one, video capture. If I say video stream on, it will stream the camera from the drone. Same exact thing, no different, right? So in this case, first things first is if from Python, you can actually connect to the data lake, right? But that is where the next speaker probably is going to do that because she's going to be talking about AI and all that. I have, I am interested in it, but I have no, like case for it right now, right? My interest is actually connecting to the storage account, right? So what I'll do is first thing, I'll import a library that actually connects to the service, right? This is my service. Then from the service, I basically want, right? Let me go up here. So this is my service here. From the service, I actually want my container. So I'll go to my container library out here. And finally, I want my blob, right? So my blob is my file. So I need 3 levels. Then I actually go ahead and connect to it, right? So when I connect to this now, basically I'm connecting to the storage account, right? So if I go here, and then I'm going to go to this 3D, whatever, I'm just going to delete this for now, right? I'm going to take this off so we just see the images, okay? There you go away, and there it's done, right? So what I'm going to, it's called Azure BCSV, okay? So I'm going to actually go change the name of the account to Azure BCSV, there you go. And then basically I have my key, right? I have my key over here. So I got to delete this whole gobbledygook, right? And then where is this? Like so, right? I'm going to delete this guy. And then I'm going to go over here. I'm going to say, hey, give me the primary key, copy this guy, go back, and I'm going to actually paste the primary key here, right? And the endpoint is like, corewindows.net. That's absolutely fine. So with this, I'm actually have a connection string to connect to my Azure account. Just the same way I connected to my, what do you call that, my Power Apps application. I'm doing the same thing, except in Power Apps, I got none of this nonsense to deal with, right? I don't care for this. This, is handled by, Power Apps. But in this case, I need to put all this stuff in. Will I put it this way? No, I'll actually add a module, take all my secure information, put it in the module and read it, into my app here, right? So then I'm doing the video capture over here. I'm naming the window that actually comes up when this runs in OpenCV is called test. And from here, kindly don't pay attention to this one. I'm doing something with mouse clicks over here. Once the window opens, I want to click some, buttons and do some integration and all that good stuff, So while this is actually connected, basically I read from the camera.
When I read from the camera, it gives me, OpenCV gives me two variables, ret and frame. Ret is basically a binary for true or false. Basically, is there a frame or not? Then in my case, I'm actually like, I don't look too good in color. So I thought I look good in gray. So I've like converted this to black and white. And then I show the particular image. And then what I do is I basically go ahead and then I, convert the actual, like, if I press on the save button, the S over here, I convert this to Unicode over here. So this is what this ORD function in Python actually does. And then this 27 over here is the key. This is the escape key. And then if you don't want to capture the picture, you can press that. And then you basically go ahead and then you connect to your string here, right? And in this case, I need to go ahead and change. I got to make sure that this says 3D files. I just got to say this says 3D files, right? So let us say THREED files. Now it looks like I was playing around with this. So I have this particular container, and then I set it on a counter. If I want to take multiple pictures, I keep pressing the space bar and I take multiple pictures. So Rivet, in your case, right, as you were saying, hey, Sanjeev, like, would you automate this? So in this case, what I would do is, in addition to connecting to my storage account, I would connect to Azure IoT Central or Azure IoT. It just depends, right? So from Azure IoT, I would pass a command. And then when I pass the command, basically it goes and sits here as a variable, and then it does whatever it wants to do, right? It will basically take a picture, so on and so forth. If I'm reading barcodes, there is a service within Python that actually reads barcodes. But guess what? If I were to do this in the real world with a proper drone, like a quadcopter or an octocopter with, let us say, a really powerful one, I would not particularly use Python, to be honest with you, as a service. I would actually use Azure services, right? So I would use, instead of writing the code in Python, there is a C# that you could actually write this in. Obviously they're fairly similar. This is easier. That may be a little harder. Who cares? So if you spend enough time, you can figure this stuff out. So I would write it there to recognize barcodes, to recognize faces, whatever it is I have to do on an automated basis. And then the question really becomes, okay, Sanjeev, that is great. So every single time you fire a command from your Power Apps, how does this Python code or your C# code actually run? So basically what I need to do is I need to start this code when I press a button, right? In Power Apps, I'll basically have a start drone or start engine or whatever. So when I press that to arm it, then a Azure function goes and fires this like Python code up. So now the code is up. And then the function actually sends a signal back through Azure IoT to me in my application that says, this is ready. Now go ahead. When you do your remote control, it beeps, right? It says beep. That's exactly what we're looking for, right? So once this code is actually running, so if I now run this code over here, hopefully I don't, the greatest thing about like doing all this is you lose your ego when you're doing stuff like this in front of 1,000 people, Let me just see. It should connect to this one shortly. There it is, right there. There's I am with my, beard. And as you can see, my house is like a garage right now. So if I hit escape over here, this closes, right? This closes. But then if I run this again, come on, where's my, there you go. And then if I actually tap the space bar, this should actually go away and put this here. It didn't. Let me just see. Did I do something to this guy here? Oh, look at me, not space bar. I'm using the save key here, right? I was bumming around with it yesterday. Earlier had the space bar. Here I have the save key. So where's this S? There you go. And then I'm going to say escape. This goes away. And now this is basically, I think, saved here. It should be saved. There you go. It's right there. You see? And then you know the rest of the story, right? I can pull this into my app. I can, form a process around it, so on and so forth. So the point here is no matter what kind of end, point you have, wherever the camera is, it's in a drone, it's actually in it's outside, the buildings, you have the cameras, you have those kind of cameras, wherever your endpoint is,
you could actually use a combination of Azure services. So ADLS to actually store, and here's the last part, right? I forgot about it, so let me actually walk you through this. What is the difference here between, let me actually add a folder as well. So I'm going to add a folder here and call it my folder, right? Very creative. I'm just going to say my folder over here. So I'm going to put this folder, right? So what is the difference between doing something like this in my ADLS over here and then my storage account over here, right? In my typical storage account, there is a folder here as well, right? If I go to my containers, I think there is a folder here, maybe over here, one of these. I'll just add a folder here too, right? For kicks. So my folder here as well, right? What is the difference between the storage account and the data lake over here? If I add this folder, I don't know where I added the folder, should be somewhere down here. Where am I? Never mind, right? When I add a folder here in my storage account versus adding it in my storage account in my ADLS, the difference is of, security, right? So if I right mouse on this, I can actually say manage access control list, right? So from my Azure AD, I would have actually set up a layer of like business units versus users, and within users, you have a hierarchy of like a basic user versus a super user, so on and so forth. Once I have that entire thing aligned in my Azure AD, I could directly connect this to that, principle within Azure AD. Or what you could do is you could basically go ahead and then you could set up your access control list, right? So what we have here is this, docs.microsoft.com. Someone's done a beautiful job of actually describing how you could actually set up an ACL with your CRUD permissions over here, so that, and the way I would use it, is a little different from how traditional IT would use it. I would actually take a business point of view when I set up these storage accounts. And then depending on who the person is who's actually building those applications and then what level of permissions he or she needs, I'm going to set up these ACLs and then, let them play, right? So to an end user, now you can see how powerful this is, from being able to create applications on the fly as you're responding to impact that is in the millions and millions of dollars, right? So you really, really enable the people. Now, then you would say, hey, look, Sanjeev, if all this is good, what is the role for IT in this, right? Well, obviously, as an end user, I don't have permissions, first of all, to access any of this. And that earlier conversation, right? It's like, you have central IT, they would have outsourced it to somebody else to do managed services. That person would have outsourced it to somebody, blah, 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 right? So then you have to chase the trail, but no more, right? So what you could do is like, find the head of digital transformation, consult with the person to say, hey, look, if you want to enable these end users, you need a team of super users, and you need like that strong connection with one or two people within IT who can actually provision this for them, right? So those people then act as like, guardians or gatekeepers, if you will. So they are the ones who will actually come up with your storage account, define, security based on what the community internally actually looks like. Then they are the ones who will actually bring the ancillary Azure services as well. Like, hey, look, I need my function to actually run my Python code. Sure, I'll actually get you an Azure function. Let's say I need logic apps beyond Power Automate so I can actually get into the code itself and manipulate the code. Sure, So there is now a healthy marriage between your super user community who act like your, baby admins, if you will, then your IT itself, heroes within IT. And then the other thing, one last component is APIs, right? So if you're in a bank, let us say, and if you want access to Bloomberg, going to Bloomberg.com is the stupidest idea one can imagine, right? So you need an API. So you work with Bloomberg, get the API, add that as a connector, and then you provision like your power users to go do whatever they have to do, right? So the combination, if you will, on the front end, if you will, as Power Platform, and then the ancillary services that you can bring, with ADLS being one of my favorites, with functions, with logic apps, is just marvelous. It is incredible. I mean, the amount of fun that you can actually have here is remarkable. Okay. With this, I will stop here and I will hand it back to our good friend Rivet.
All right, thank you. Very, very interesting. I learned a lot about this from these sessions. Okay, so any question from the floors?
Come on, folks. Have I stunned you into silence? It's okay if your kids are crying in the background. It's okay. Kindly unmute and shoot,
Yeah. Sure, before this is very, very interesting because this is a real case using the Power Platform combining with Azure. I think later on the AI, the next sessions is classification. So combining all of this with the real use case, I think is the most interesting things compared to just reading on the, on the document, right? So and definitely, Sanjeev, can
Yeah.
I ask about the size of the storage, right? If you do that, keeping like a stream of the data, let's
Yeah.
say imagine you have the drone
Yeah.
stream all the data. So how do we do the streaming? Because uh, you know it, usually when we do the streaming and we'll create a lot of storage, is there something
Correct.
that
See,
we can have, like the scenario where the streaming
yeah.
is coming in, but at the same time there's a processing on top of it and capturing the most important things, and then
Exactly right. So here's the thing, right? You bring up two, in what you mentioned, there are two things. One is the stream of data that could just like overwhelm, the storage, right? So that's where you actually design it to say, when am I going to capture the picture, right? So that could, like to our earlier conversation, could be done two ways. Our good friend Priyanka perhaps will talk about the AI component. So what I could do is I could read faces, dangerous. I could read faces, or in what I would do is I would read barcodes, right? The moment I actually read the barcode, then I'm going to save it, right? So that limits the amount of things you actually need to store, as opposed to, hey, look, I'm going to store everything in, right? But then that's a business conversation, right? And me as a power user now, I'm unable to have that conversation and then say, hey, here's the approximate size of the storage that I would need. And then kindly remember that I don't need to keep sometimes the history. I can purge away the history at periods of time and then free up things.
Awesome.
Yeah.
Thank you. Any one last question from the floors? If not, then we will welcome Priyanka for the next sessions. Calling for once, calling for two. Anyone? All right. If no, thank you, Sanjeev, for very
Most
interesting
welcome, sir.
pieces. I learned a lot from the sessions. I hope we are all going to be exciting when we bring back to our workforce.
Workplace. Yeah. Excellent, sir. Thank you very much for the opportunity. Cheers. All the best, Priyanka.
Hey, thank you,
Yeah.
Sanjeev.
All right. So the next sessions will be Priyanka. So Priyanka, you can share. Try to check if you can share a screen.
I can, yes, I can. And yeah, this is what I see.
Oh, okay. So you can share screen. All right.
Is this
All right.
good?
So, yeah, I can see you. It's awesome. Yeah. So let's start. Okay. Let me stop the recording so we can have the next session recording, and then split between the session. Okay, hold on. Okay, so start recording again. All right. All right. So the next is Priyanka. She's a Microsoft MVP for AI Solution Architect, Science. She went to I think last month to US for the big events. Right, so we will see. Welcome for Priyanka for the next session. This is about the data classifications, things, tag summarization with Azure language cognitive. Okay, Priyanka, this is for you. Right.
Thank you, Ripu. Thank you so much. Hey guys, good afternoon. And I know it's almost about lunchtime, right? So I promise I keep it as interactive and as succinct as I can. I won't. I promise I won't drone on and on, right? Today's session is about introduction to cognitive services language studio with a special emphasis on seeing custom text classification and dynamic text summarization. All right. So this is about me. I need not reiterate these things. Just you want to connect with me on my Twitter handle on or on my LinkedIn, please welcome to do so. Okay. And this is how the session will flow today. Throwback to Azure NLP. So why? What was the need for coming out with a whole entire new language studio services? Okay. So language services and what is new about this, okay, and then we will have a short footnote about how the new studio language studio has incorporated OpenAI GPT paradigm inside of it, and then there will be a lot of demos, I promise, right? I mean that the theory part of it is going to be very small, very short, and then we'll be headlong into demos all throughout, okay. So this is just a bit of reminder, right? I mean, if people, who are not new to Azure Cognitive Services, we had three type of language based artificial intelligence out of the box AI, right? So it was Luis, which was language understanding integration services, which was used for conversational AI. Then we had Q&A maker, which was your FAQ answering bot based on your knowledge documentation which you had. And finally you had text analytics, where you could extract insights from text, and you could extract personally identifiable information. You could have a celebrity identification, landmark identification, geospatial location identification, and you could then link those entities, right? These were the broad type of cognitive services for decision, for speech, for language, for vision. Okay, and now today's session we will be concentrating on the language NLP, natural language processing services, which are together now combined in a offering which is called as the Cognitive Services Language Studio. Okay. Now the thing is, before we jump into all these beautiful offerings and out of the box NLP and advanced AI, right? What was the need for NLP? All right. So I mean, not just NLP, advanced NLP, right? So we are in the middle of a paradigm shift, right? So where we have the users, also the end users, enterprises have moved on from just basic search to an intelligent, intuitive search. Okay. So, I mean, it's not uncommon for users to come and tell us that I just don't want a keyword based search. So 3 years back, or 5 years ago, it was a huge thing to just have your keyword based search, like exact keyword matching. So if I'm searching for, let's say, robotic cars, or I'm searching for electric vehicles, then it could search the exact term electric vehicles, or electricity based vehicles, and then give me back the search results, documents which had that term or that phrase, or something similar, but matching the words electricity and vehicles, right? Now it is not uncommon for enterprises to come and ask us that I want a semantic search, which means the exact words may not be present in the document, because it is impossible, right? I mean, as an end user, there are like humongous amount of documents in my organization, and it is humanly impossible for me to know the exact words contained in those documents. But let's say I want to search for green energy. Okay, then I should also be shown documents with solar energy, with wind energy, tidal energy, renewable energy, those kind of things. So the semantic matching is something which increasingly enterprises and users are coming and asking us, which is why we've moved on from the your routine search to an intelligent intuitive semantic search. Okay. So data explosion is happening, like as we know, right? We have heaps of data digitally and otherwise as well. Data collected when you visit your social media websites, data collected as a part of your end user agreements to certain pages which you visit. So nowadays, whenever you go on web, right, you inadvertently have this accept cookies sort of a the checkbox everywhere, right? I mean, and you don't have a choice to accept it. I mean, don't have a choice. You have to accept it, and then you'll be able to access the web content, right? So, which means, there's more and more data being generated, right? And then the time to search that data to get meaningful results, it's too much. I mean, if I were a end user of an enterprise or an admin of an enterprise, or I wanted to build sort of a bot for your banking systems, where I would direct users to the correct forms or correct information pages, right? Then searching that huge data which is generated every day becomes a task, becomes an uphill task, right? So which is why this is some of the statistics which we collected real time. Okay, so people have to spend almost 40% of their work week searching stuff in your mailbox, in your document repository, content repository. Okay, so then what are the enterprise challenges with data? Okay, so you want to have improved collaboration, you want to have personalization. So which means typically on your enterprise SharePoint site, you will always personalize it in a way that whatever sections interest you the most are channeled first when you enter the website, right? So apart from personalized content search, you would also want to have a golden data source, like a consolidated knowledge mining platform, a single and intuitive user interfaces. And then on top of all these things, personalization and customization and consolidation of all your contents in a golden data source or a data lake sort of a thing. On top of that, you also, you should also have this sort of an advanced NLP that will empower your users. Okay, so you mean for example, a lot of users, when we are implementing this sort of a document engine search for them or knowledge mining for them, they come back to us and they tell us that I want to also have sort of a feedback mechanism which will learn on its own, so which will learn on the go based on the feedback I give to the search results. And then it is sort of a human in loop training, right? So based on the feedback given to the search results, it will learn to re-rank the search results. Okay, so that is also one of the things which users are looking for. So not only advanced NLP, but how that advanced NLP can empower your enterprises and your end users. So that is the next thing, and these boxes will just keep on increasing, right? I mean, initially we had personalization, then we had consolidation of content platforms and intuitive UI, then we had collaboration between different data sources, right? And then these will just keep on getting added as and when our AI platforms and our NLP platforms keep on getting better and better. So this is something of an enterprise knowledge finder engine. I won't go into the nitty gritties of that, but I mean, just look at the type of content which increasingly users want to harvest and search, right? So they want a summarization. So it's not like I will probably, when I search for green energy and it gives me back 15 documents which are semantically similar to what I'm searching, but I really don't want to click on each and every link and be able to open and see whether it is relevant to the searches which I'm doing. So that's why they also want, a summary of the document returned, so that I can quickly browse through and see if that document makes sense to me, or this is something which I'm looking for or not. As I said, feedback and analytics, right? Where I will provide a feedback to the search result so that, it could be re-ranked accordingly. So many users find the first return search result as not very intuitive or not suitable to what they are looking for. And they give it, a negative feedback or a 1-star rating or a half-star rating. Over a period of time, the algorithm learns. And then whenever I'm searching for green energy or electric vehicles, then probably it won't surface that search results in the first top 10 or the first top 5. Okay, so another an interesting requirement is people want to be able to search images also within a document. So not only just text, but let's say if there was this requirement, so we were working to build this sort of a knowledge mining for a oil and natural gas based MNC, a huge giant, okay, in Southeast Asia. And they had documents which had images of compressors, oil pumps and compressors. So they wanted to search, for example, compressor bulge, okay, and it should surface documents having a bulge in their compressor. So just imagine that, the image also needs to be searched from the document and not just the text. Okay. And of course, it has to be semantic search, so cognitive and personalized. Okay. You're returning personalized results. So for example, someone who's at the engineer level and he searches for compressor bulge, maybe he should be shown documents related to his field of expertise, vis-a-vis a person who is probably a manager and who's searching for the same content, should be shown documents which make more sense to his role and his post. Okay. So something of that sort. And now all of these knowledge finding, right, which is based on our cognitive language advanced NLP, right? It does result in almost 15 to 20% increase in the employee experience. So it is easy to search, it is intuitive, it gives you sort of suggestions like people who searched for this also searched for this, or if I'm searching for electric vehicles, inadvertently it should also pop up the name of Tesla, like, and then if I click on Tesla, then it should also tell me about the newest acquisitions of Tesla, which is Twitter or Elon Musk, and those sort of your AI based recommendations, okay, which you normally also get on your social media platforms, right? Like people who bought this item also brought this item and stuff like that. So we are not new to this sort of a recommendation, but then implementing it in your enterprises with the amount of custom data, custom text which you have becomes a challenge, which is increasingly being addressed by the advances which we have made in BERT with the help of OpenAI GPT paradigm and OpenAI GPT-3 now. All right. So how all of this works in the background is I'm going to take all my documents, my text corpus, ingest it, enrich it via your advanced NLP skills, right? And then finally I expose it out to the user on a web app to be able to interact with the content. Okay, so what does this advanced NLP, the language studio, it helps us with? So it helps us with bundling content, like grouping content together, which is what we are going to see with our custom text classification today. It enables us with auto crawling, getting the best information at before you bat an eyelid. Then infographing, right? Visualization of your contextualized information, expert search, right? Of course. And of course, increased collaboration. So, you can, people with similar interest can always group together and stuff like that. Okay. And now, we move on to, so all of these was, this was the setting, right? So these are all the user requirements and these are all the beautiful enterprise things with advanced NLP, which we do build. But what is the basis for that? The basis for that is your Azure Cognitive Services for Language. So it is, it combines a lot of your NLP offerings. So you can have text analytics, you can have opinion mining, sentiment analysis, you have conversational AI, you have summarization, custom text classification, named entity recognition, linking entities together. And of course, it is all, most of this thing is out of the box AI, which means I just need to know the purpose of my use case, and the AI service is available right out there for you out of the box. Okay, so we'll explore that. We'll see how how the language studio helps us out with our conundrums, with our usual AI based AI enrichments for languages or text documents. Okay, so this service which we have, this studio, this language offering, which is newly unveiled by Microsoft, probably I think an year ago or so. So that is this unifies your text analytics, Q&A maker, conversational AI, and also provides new features. A few of these features are of course in preview. All right. So yeah, but nonetheless, for example, like custom text summarization and classification are in preview. But nonetheless, you can explore these offerings on the portal itself. Okay, and then all of this is customizable. So you can use them for your own text corpus, for your own use cases. Okay, and these are some of the features, right? So you can experience it right on the portal itself. So you can choose a REST API based approach, or you can choose directly configuration on the portal itself, as is with most of the cognitive services. Okay, and these are some of the features of Language Studio. Okay, so like you can automate workflows, you can process medical text, right? You can have conversational AI, you can identify your entities, relationship between entities, and of course, based on your sentiment mining and all, you can better understand customer perception. All right. So let
Yes.
us,
I have a question.
yes.
Just
Go ahead.
curious. Are you showing the slides, or you're not showing the slides?
Oh, did not I share the slides?
No.
Oh.
Yeah.
Oh. This is a
Yeah.
mistake.
That's why I'm curious. Where is the
Oh,
studio?
I'm so sorry.
Okay. It's just your video only.
Oh, okay. Let me
Okay.
let me.
Okay.
I'm so sorry. I didn't know because I thought I was sharing and then okay. Anyways, I'm so sorry. So 20 minutes I've been speaking for nothing. Okay. Anyways, let me just quickly again run through. So this was I was talking about advanced NLP. This I was talking about data explosion. Okay, then enterprise challenges with data. Right. So for example, I was talking about what are the new things which we typically find with data. Okay, so improve collaboration, single intuitive user interfaces, personalization, and this was our knowledge finder engine requirements, like what all users require. They require summarization and preview, they require feedback, they require video and image search, they require cognitive personalization. Okay, and then this was a set of experiences, like for example, users came up to us and told us that they have achieved 15% increase in employee experience. It is easier to search, it is easier to collaborate, and it is easier to get recommendations. Okay, and how it works in the background is you ingest your documents, you ingest your text documents, you enrich them with your advanced NLP offerings, and then finally you set it out on the UI for exploration. And these are the use cases, right? Like bundling of content, then expert search, next best action, which is your recommendations, infographing, right? Auto crawling, so receive information for a similar set of requirements. So if I'm training a AI algorithm for getting weather information, the same AI algorithm should also be leveraged for getting, for example, sports information. Okay, sports updates. And this is the cognitive services for language. Okay, so it unifies text, Q&A, Luis. Okay, and it is pre-configured, customizable, so you can use it for your own use cases. And finally, these are the four tenets of your Language Studio: state of the art multilingual models. So it doesn't necessitate you to have your text only in English. You can have multilingual text, a visual interface to annotate, train, and deploy your models. And of course, your data stays safe, right? I mean, it's not exposed. As soon as you delete your services, everything else is also purged out. And these are the features of Language Studio. So, identifying important concepts via tagging entities, custom entity recognition, entity relationships. Okay. Then via your sentiment mining and opinion mining, you can better understand your customers. You can automate workflows. You can also process medical text, and you can have your conversational AI so that you can build a bot or converse with your customers. Okay. So I'm so sorry for this. Let's jump into the demo right away. So I'm going to show you there will be a lot of demos. Okay. So I'm going to show you a semantic search functionality today, right? So the thing is, we have harvested from Wikipedia, from open source. We have harvested information about artists, their genre like hard rock, metallic rock, pop, and stuff, and the albums which they are featured in. Okay, right? And then we have around 1,000 documents, like 300 artists, 300 regarding their genre, and 300 regarding their albums and stuff. All right. So now, instead of just doing a keyword based search, I can also do a question and answer sort of a search. Okay, so I can directly ask my AI questions about my text. Okay, so for example, here I was searching for what is beat, right? I hope you can see my screen. So if I'm searching for what is Beatles, then instead of giving me a huge set of documents which talks about Beatles, if the AI can directly find out a very pointed answer to my question, it will return with that answer, and also give me a link to that document. Okay. So then here the answer directly from all my 1,000 odd text documents, it has given me the Beatles were an English rock band and blah blah blah, all of this, and then it will give you a score. Okay, same way if I search for who are the Spice Girls, for example. Okay, and I'm searching this, who are the Spice Girls, and yeah, see, so if it is able to get that information from directly the documents, like a pointed answer to your question, rather than pointing you to a heap of documents, a set of document links, it will directly tell you. So the group plays Spice Girls, Mariah Carey, Whitney Houston, and Destiny's Child as their main influencers. So maybe this answer may not be very right. Okay, so it is giving me that with 97% confidence, it is giving you some information about my question. All right. So on top of so the semantic Q&A is a new feature added, all right, which means it will directly give you answers based on your text corpus. So this is based on your birth Q&A answering functionality, where given your documents are given a set of text, it will try to comprehend the text. It is much like how we used to have comprehension in our school and college days. We were given a paragraph, we used to read it, comprehend it, and there used to be a set of questions below regarding the paragraph. So it's much the same way. It's just that instead of a human answering the questions, because typically the documents or the text could run into thousands of pages or thousands of words, and then it's very easy for for us to now be able to feed all these text to the AI engine, the AI NLP engine, and just interact with it directly via question and answers. So if an answer exists to your question, it will give out the answer here itself. So this is a semantic answer. Otherwise, it will direct you to the other search results. So let's say, for example, if I'm searching who are the members of ABBA. So that was another, group, right? So probably if it was not able to find a very pointed answer to my question, then it might, redirect me to search results itself. Okay. So here it has given me some answer with, 97% confidence. Okay. And if I'm not happy with the semantic Q&A and I want to do a more detailed search, I can always do so. So I can click on search here, and then I can, search all. So here it is star. So it is showing me all results, all artist, all genre, all albums. And then here I can, zero down on my search. Okay. So for example, I can search for Van Helsing. Van Helsing was a vampire killer. Van Halen. And I don't have anything. Okay, let's check. Okay, so here, Van Halen. apparently it is keyword, I mean, it is case sensitive. Okay, so Van Halen, and then it will show me all of Van Halen's thing. And I can also view a entity map of this. Okay, so for Van Halen, it will show me the results for genre, for album, and also for artist. Okay, so Van Halen featuring in which genre, which album, and what sort of, and if he has been partnering with other artists. Okay, so I can also view all this information in sort of an entity map, which is like a graph search. Okay, like your much like your okay, so this is your graph based representation with Van Halen at the center. Okay, and then all the relationships with Van Halen shown here. Okay, so I can choose to, for example, reduce the levels and select facets. So here I'm going to select, only want to see what genre is Van Halen related to. Okay, so what are the relationships of Van Halen with different genre. So as you can see, I have chosen to have max 3 levels, which means primary, secondary, and tertiary relationships. I can reduce the number of levels I want to see. Like I may want to see only 2 levels of relationship, where Van Halen is directly related to a genre, and then some other genre is also related to that. Or I can also choose to have only the first level of relationship, where Van Halen is directly related to what genre. Same way, you can also either multi-select or single select. So you can also select Van Halen is related directly to which album. Okay, so Van Halen was directly performing or directly, for example, associated with what album, and you can choose to have the max nodes and the max number of levels, which will tell me that what is the relationships. Like for example, if I choose to make it level 2 at a album level or an artist level, then it will tell me, like, he directly performed in what albums, and then again those albums might be also have a secondary relationship with someone else. Okay, so something of that sort. So it just tells me more information about the entities which I have in my text and how they are related with each other, how entity relationships are related, how entities are related in my documents. Okay, right. Okay, so this is one thing which users increasingly request for. Okay, let us look at more of this thing with the help of also your COVID related search, right? So for example, if I'm searching for ibuprofen, so this is like sort of a auto completion. So if I'm searching for ibuprofen, then it will give me documents for ibuprofen, and also same time it will also give me semantically similar terms to ibuprofen. So as you can see, right, semantically similar terms is naproxen, NSAID, and stuff like that. And I can expand my search. So if I now click on NSAID, then it will also give me documents having both ibuprofen and NSAID. And then if I select another term, it will further on sort of expand my search and then give me documents talking of all 3 of this in a semantically similar way. And then on the left hand side, you will be able to see that there will be entities, like these 3 components were listed in which journals, who were the authors contributing to these journals. Then these 3 medicines affect which body structures, what is the diagnosis for these 3 medicines are used for, and so on and so forth. Okay, and then same thing, you can also, much like the music demo which we saw, you can explore these relationships into graphs. Okay, so here also you are able to see contributors. So here ibuprofen, right? Ibuprofen, and all the papers which mentioned ibuprofen, NSAID, and acetaminophen, you will be able to see the contributors to the papers which mentioned these 3 things. So you can also drill down by symptoms. So symptoms or signs for which these 3 are used. Okay, so this will be a more graphic way of exploring the relationships between your entities and between your text. Okay, so having said that, let us move on to the language studio. So the language studio is like, like how I'm not sure if you've used customvision.ai or luis.ai. So like that, it's a separate portal itself, right? So this is your Azure portal where you create all the resources, storage accounts, and language studio is the place where you will be able to experience the language related NLP offerings. Okay. So this is how the language studio looks like, and you should be able to create projects whatever you want here. We'll jump shortly to that, and then these are some of the things which you can do with the language studio. Like you can extract personally identifiable information, key phrases, finding linked entities. Okay. Then extracting named entities, health information. They have this own AI for health, Microsoft AI for health entity, and you will be able to extract health information, which is the basis of your cognitive COVID related search. The health bot is the AI for health is the basis for your this one COVID related search. Okay. And you have custom NER, custom named entity. You are able to classify text like sentiment and detect language and custom text classification. You will be able to do conversational AI, so answering questions, which we saw in the semantic Q&A, right? Like you can pose questions and it will answer. Custom question answering, so based on your very own text corpus, it will give you answers to your question. And your conversational, like a dialogue flow. So if I say I want to order a pizza, it should ask me what size, what toppings, what flavor, what vegetarian or non-vegetarian, those kind of things, right? Or gluten free, or with a gluten base, so those kind of things. And then we'll be able to also build orchestration and workflow, and of course summarize text. Okay, summarization of documents. And you will also be able to translate text, like translate from one language to another. Right now, let us, so on this portal, once you're on this portal, the basis for this is, before you come to the portal, you have to create a language resource from your portal, Azure portal. Okay. So if you look at all resources here, I have a language resource which is created. Okay. And created in the region of West US2, because not all of the studio offerings, language studio offerings, are available in all regions. So I created for Southeast Asia. Then this Southeast Asia region doesn't allow me to do text classification, custom text classification. So I had to create a new resource here, right, for the West US2 region, which will allow me to do custom text classification. But nonetheless, we will need a language resource, a language service resource created. And when we come to this portal, it will ask you for the resource which you have created, and then you can, quickly jump into sort of experimenting and experiencing all the offerings. So if you, let's say, if you click on try it out, extract key phrases, right, then you can experiment with the sample text which is given here, or you can also do it with your custom text. Okay. So let us, experience some of the sample text which is given here. Okay. So then the chief cook happens to be the owner. I think his name is John Doe, and he's super nice. So this is one of the samples, inbuilt samples I have taken. Okay. And then I click run. And then it will give me the results. Like key phrases it has detected is chief cook, John Doe, owner, name. Okay. And then it is also underlining it, right? I mean, this is name, owner, chief cook, John Doe. Okay. And if any of this was a known celebrity and or a known, for example, let us try another sentence. I visited the Leaning Tower of Pisa last Christmas. Okay, so this is my sentence, and then if I just do run on that. Okay, so here again, it has extracted, like, Leaning Tower of Pisa, and maybe last Christmas was also important for me, and then I can tag it, like I can use custom text tagging to tag custom things. Like this is out of the box, like the whatever, built out of the box. But then if I wanted to tag something custom, I can also do so. Okay, I can also go back. So I'll go back here, and then I will be able to do my custom here, custom entity recognition. Okay, so it can extract So here, personally identifiable information is where it is extracting known people, landmark, countries, celebrities, okay, locations, names of cities, something of that sort. So for example, if I were to go here, right, and it's like, it is listing out a pin code here, and then some address, phone number, okay, and then if I were to run analysis on that, it will be able to give me, like, date, time, person type, person, say the person John Doe or whatever the name, then URL, phone number, email. So all of these things it is able to identify from my text. And if I want to identify even more things apart from the stuff which is given here, I can do so in my custom text tagging. Okay, I will also show you how to tag your custom text. But then if the purpose is, the point which I want to drive home is you can just create a language resource and then be able to freely experiment or experience all of these functionalities, features which is being offered on the portal itself. So you can extract key phrases, linked entities, right? Let me show you about text classification, because that is what is the major thing which we are trying to do here. Okay, so let me, custom text classification is, for example, I have a lot of documents, probably more than 500,000 documents, and then I wanted to classify them as let's say probably government related security documents, or then it is normal your admin related HR documents, or it is exit management like employee resignation and exit process related documents, those kind of things. Okay, so this is your classifying your text into buckets. It could be multiple buckets as well, right? I mean, so one piece of document can also be an HR plus an admin plus something, an employee handbook also. I mean, it can qualify into multiple buckets. So that kind of a thing. Okay, so then if you look at custom classification, you can train your own data on your own classes which you want to. Okay, so I have already done so. I have a custom text classification project created, and what I have done is I have imported a synopsis of around 200 movies. Okay, so from it as JSON files, right? So this is around 200 movies from Wikipedia, synopsis of those movies, and I want to classify them into these categories. Okay, so whether they are mystery or drama or thriller or comedy or action, and these are the classes which I have defined. You can also add more classes, like I can add romance, for example. Okay, so I can add. Okay. Right, I can add that, or I can add like any other class which you want to, and then I can also tag. So for example, this one going on 30, right? This one going on 30. This is tagged as a comedy, and I want to probably tag it also as romance. Okay.
So
And
sorry, question, right?
Yes, go ahead.
So this classification, right, the tagging is done manually or done by the machine learning?
So the thing is, this tags I have defined, right? I mean, what are the buckets which I want to classify these documents into? Okay, so let's say, for example, this is a movie example, but let us move on to a more pragmatic example, which is, in case of for example, your help desk tickets, your service tickets, which you routinely raise in your um, uh, workplace. Okay, so if I wanted to categorize those tickets into buckets, like which are admin related, which are technical support related, which are your your hardware movement related, which are your new software procurement or installation related. So let's say I have 4 buckets, which is technical support, admin, hardware, and software installation. Right, so these 4 categories. So I will define these 4 categories, which is from this add class here. So I'll be adding these classes, and then these documents I will be tagging one by one. So then I have to go and then tag this document as whatever, like mystery, drama, or technical support, and plus hardware request, or admin plus software management, or it could be single class classification. So right now the type of project I created for this was a multi-class classification, multi-label classification, which means one document could belong to multiple buckets. labels. Okay, you could also have a very pointed like single label, like this image is only an apple, or this document is only an admin related document, this document is only a hardware related support request, that kind of a thing. Okay, so if it is multiple, it will give you multiple check boxes which you can check. If it is a single label, you will be able to tick the it will be a radio button, so you can choose either of these. Okay, so these are the categories which I have added. Again, you can add it from the portal, or you can also do it directly in a JSON file, and then you will be importing that JSON file directly. Okay, so just to show you, if I don't want to have all the hard work for defining these classes manually, then here JSON here. So I have a JSON file where I will be able to So this JSON file, I will be able to, open it. I mean, I'll be able to define all the labels and a rough classification of the movies directly inside that. So instead of tagging the movies one by one on the portal, I can also here. So these are my classifiers, which are the classes which I have defined, okay, which will be auto-populated there. And then I can also, take my documents and directly classify them in the JSON file as well. And in the portal, then I can see the result. And if I want to be able to, if I want to be able to change it or, add more classes, I can do so also from the portal or also in the JSON file. It's totally up to how you want to be able to program this. Okay. Does that answer your question? Okay.
Yeah. So
right.
actually, I also thinking, is it possible, like having, let's say, hundred of classification that we are doing manually. For example, like the movie, right? The input is from the Wikipedia or anything about this movie, and then after that, the machine learning will do the rest of thousand of the movie summary to do the automatic.
Yes. So this is, I see, the thing is, I'll show you that, right? You need not tag all of this, first of all. Okay. So if you have 200 movies, there is at least for training your model, you can tag at least 15 to 20 of them. Like that is the minimum requirement. Okay. Once you tag those 15, your model is ready. Then use that model to tag the rest of your data. Absolutely possible.
Okay, thank you.
So you need not, you need not manually tag all of the 1,000 movies. You can choose to do a subset of that, right? And then you can, once your model is trained, you will be able to use that model to then probably, apply the tagging to rest of your documents. Absolutely possible, right? So this is how you will be able to see that your documents are tagged and stuff. The requirement is that you should be only, at least 20 to 25 documents are tagged appropriately for the model to give you a reasonably accurate result. Okay, so this is how I'm tagging my data and into multiple categories. You can define more classes and you can also select those classes. And then finally, once you're sure, like, you've done a decent job and you have a decent amount of data tagged, then you should be able to, train your model. So here, so train the model, then you should be able to come after you completed tagging. So if you are having more tags, or if you're so here, there's nothing to save. So my data is now tagged and I'm now ready to train my model. And then I can do that. So train a new model, and here you can give the name. You can choose to override the model. You will be able to automatically split, into 80% training and 20% testing, and you can click on train. So your training will start, right? And then you will be able to use the trained model to further either, test certain results, or then use that model to tag more data or to be able to classify more data. All right. So, just, imagine if you had to do it by writing your normal Python libraries, Python code in a machine learning studio or a machine learning environment. Then you have to import all those libraries, you have to upload all your documents, you have to define those classes, and you have to also tag those documents using some labeling tool. So all of that has been now bundled together into your portal itself, and where you can just click on these features, and then you can do what actually your code in your code you would have done. So this is actually simulating your coding steps and then making it much more intuitive, much more user friendly, okay, and easy to use as well. Sorry, come on. Okay. So so we'll wait for the model to be trained. Okay, till that time I will just jump on to showing you custom named entity recognition. Okay, so let's take the same movie data set which we have, and here if I wanted to now detect entities within my text corpus, right? For example, if I wanted to detect in all these movie synopsis, I wanted to detect the hero, the villain, and stuff like that. So how can I do that, right? So same thing, right? I am adding tags here. So I added protagonist, which is your main character, antagonist. Okay, then I can add the main, female, or I should say female lead. Okay, something like this, right? And I can also add more entities like type. So or maybe some date time. Okay, so date time entity. I also want to add an entity called as what is that? Author. Date. Oh yeah, date time is defined. Okay, so probably so anything which you can think of, right? Okay. Okay. So you can add these entities, and then you can actually or here something like year. Okay. Okay, so now here, so this 14-year-old Danny Neil is madly in love with this something something. Okay, so I will tag Danny Neil, and I can make him as a protagonist, right? And then love with his teacher something something. So Miss Peggy Noble, I can tag her as the female lead in this particular genre, right? And then this vicious gym teacher Roy Kilton, I can make him as the antagonist, right? I can make him as the antagonist. So this is how you're tagging your text now. Okay. So this is how now, for example, the out of the box entity recognition, which you saw earlier, right? Where it was able to understand names, and it was able to extract dates. It was able to extract time and places and all of those things. Now, if you want to extract something custom from your document, your text, you can also do that. You can define your tags, whatever you want to. Okay. So if you go back to the music example, I want to know the band members, the name of the album, the genre, and the name of the artist. So these will become my entities. Name of the artist, whether it's Van Halen or it is, the name of the band, whether it is Beatle or Spice Girl or ABBA, and the genre, whether it is metallic rock or pop or hard rock, those kind of things, right? So those will become my entities, and I can actually tag parts of the text here to indicate what are those entities. Okay, and then I can again go to the next document, and same thing, Polish artist Julia. So this one, so Julia is the protagonist here. Okay, and husband Piotr. Okay, again I can mark him as the protagonist, right? And then something you can choose to tag tag the text accordingly. Okay, so you can have more than one entities tagged, more than one text tag with the same entities, right? And then so on and so forth. And once you are done with that, again same thing, once you will be tagging sufficient data, you will be able to train your model. And once you feed a new text to it, it should be able to identify all of these entities, who are the protagonist, who are the antagonist, who are the female leads. And if you want to define any more entities, you can always do so. Okay, and not all of these text can have all entities. Like for example, some of these text might not have an antagonist at all, right? I mean, no villain, no negative character at all protagonist only. Or some of these movies may not have a female lead at all, which is also possible, right? So that's why you can define a set of entities as per your need, and then you can just tag parts of speech to parts of text to see, to tell it what sort of entity that particular part of text is, right? So this is your custom entity tagging, custom entity recognition. So this is recognizing entities from your set of documents. All right. So this is also, very, otherwise, there are a lot of tools out there which you have to Google, which are free, which are licensed and stuff to do all this sort of image tagging or text tagging. So all of this has now been consolidated at a single place in the portal, and a very visual intuitive interface available for you to do these things. Okay, so same thing, once you tag enough documents, then you will be able to train, and then you will be also able to improve the model. It will itself tell you some improvements which you have to do there. Like, probably this document you have added less number of tags, so you can tag more parts of speech, or you can tag more sentences there, something like that also it will tell you, and you will be able to deploy the model as a web service and consume it in your end product. Okay, right? So after the custom text classification, I also wanted to show you about opinion mining, sentiment analysis. So you click here, try it out. We will, try out some of the sample text here. So let's say, here, the food and service were unacceptable, but the concierge was nice, right? And then here you see there's an option for opinion mining. So it's not just sentiment analysis, but it's also opinion mining. Like my sentiment was based on my which parts of the sentence. Okay, so it's not just a sentiment, negative or positive, but my opinion about the entire setting. Okay, so this is an opinion mining option also available here. What that opinion mining does is, if I run that, okay, so it gives a document sentiment which is correct. So this total, sentiment is around positive, because that is what I'm trying to say, right? Like the food was unacceptable, but the concierge was nice. So it is giving me as a positive sentiment, and then it is analyzing my, why that document sentiment was positive. So here, if you see, the food and service were unacceptable. So the target, like what was unacceptable, was the food and the service. So the assessment was unacceptable, which is like negative. It was negative for what? The food and the service, but the concierge was nice. So the assessment, nice, is an assessment for the target, which is the concierge, right? So this is your opinion. So opinion for your food and service was bad, but for the concierge was nice. So just imagine the amount of drill down it is able to do. This out of the box is AI is able to do. So not only the sentiment is getting unearthed, but also the opinion about, why, which part your sentiment was or opinion was bad, and for which part it was good. So just see, like, 2 years down the line or 3 years down the line, when we were doing the text analytics or sentiment analysis, it was just able to give us these kind of, positive or negative or neutral, and that also was not very accurate most of the time. But now with the opinion mining, it is also able to tell you that which part of the sentences influenced your sentiment, right? It's a pretty cool stuff, right? I mean, and as AI NLP goes on advancing furthermore, this is sure, going to go to the next level as well. So with the advances in OpenAI, GPT, and in BERT and all, we will be able to surely see even more information being unearthed. So right now, it works good for small sentences, but then it doesn't really work well or bode well for financial sentiments. For example, if I were to tell you that the price of the Australian dollar surged as compared to the USD, right? So which means Australian dollar became dearer, right? I mean, something like that. So it's not able to understand whether it's a negative or a positive sentiment. It will just rely on the English words like became, surged, or something like that, right? Or the inflation increased by 16%. So now it won't try to categorize it as negative, because inflation increasing is a bad thing, right? But then monetary things and monetary sentiments is a different classification altogether, for which we have variants of BERT, like FinBERT is there for those sort of thing. Okay, so not all of the sentiment mining can be very accurately done here in this portal itself, but then it serves serves accurate for most of our 90% of our case studies. I mean, we don't do financial sentiment analysis every other day, right? But we do document sentiment analysis and your reviews analysis and your customer perception analysis every other day on your products, your brands, your websites, your social media content, right? So this, works, bodes very well for most of your routine use cases, and for your specialized use cases, for some other time, we will delve into more details of BERT and its variants. All right. So that is about it. So you can feel free to go to this cognitive language services, create a language resource on your Azure portal, and you can be ready to start exploring most of the cool content which is here. And most of these offerings, they have their own sample text to try out. They have their text box for you to also add your custom text and see the result. What is the accuracy? Does it is it up to your expectations or not, and stuff like that. All right. So with this, I am open for any questions.
You guys can unmute yourself if you want to ask a question directly. Or you can just use the chat window also, possible. Right. So while waiting, right, I have one question. Is it possible to use not a text, a text inside the picture, something like, like an advertisement.
Like optical character recognition, right? So so the thing is, text inside a picture will fall under a different cognitive service altogether, which is your computer and custom vision. Right, so that is possible, right? I mean, if I navigate to a custom vision and computer vision, then you can there extract insights from images, extract text from images, auto caption images, all of those nice things you'll be able to do. Extract handwriting from images, extract your any what you can say what is that? If you have PDF scans, right, then it will be able to extract all tabular forms, like how you have video form recognizer, all those nice things you can do. But that is a separate offering altogether. So that falls under the computer and custom vision cognitive services, where you will also have your image recognition, object detection, face recognition, right? So what I wanted to cover today was the language text analytics part of the cognitive services. So what you say is definitely possible, right? I mean, extracting text from images, but that just falls under a different cognitive service category.
Also, yeah. And okay, so and I saw that there is the graph, relationships graph between one entity to another. So is it something like, is a customizations, or is this like already the offering?
No. So this is built. So entities, relationships extraction is out of the box, right? I mean, I define my entities, I define my relationships, but whether they are directly related, indirectly related, or first order. So let's say, for example, artists. So an artist may have collaborated on an album directly. So that is a first order relationship. But that same artist may have collaborated with me indirectly on some other album. So that will be a tertiary or secondary relationship. So those things we are using graph database to store these kind of nodes and vertices, right? And then extracted out from the graph database, whether it's first or second or tertiary or even fourth or fifth level. You can go up as much deep as you want. So relationship definition is done by using the portal, but representing them is done by storing them into some Neo4j sort of graph database.
Okay, thank you. Anyone else from the floor want to ask? All right, so if no one have some questions, then I think thank you, Priyanka, for the very, very interesting sessions.
Hey, no
Yeah,
problem. Thank you so much.
thank
Thank
you.
you guys for joining, and have a good lunch if there's a lunch break.
Yeah, I think we are not going to have lunch. We will go directly to the next session. The next session will be with Najinder. Najinder, are you there?
Can you hear me? I'm there. Hi.
Yeah, so loud and clear. Right, so Najinder is Cloud Solution Architect, Microsoft, right? So yeah, it's a very long experience with the data and artificials, and he's going to talk about building its tab solutions with Synapse links for Cosmos DB. All right, so Najinder, you will start. You are going to stop the recording first before you start. Okay, so I'm going to stop so that we can have brief talk between the sessions. All right, so the next session is a case study data movement and transformation using Azure Data Factory. Welcome for Najinder for these sessions, and thank you for joining us in Azure Bootcamp.
Thank you. Thank you for inviting me.
Yeah.
Can I start by sharing my screen?
Yeah, you can start sharing your screen.
Okay. Let me know if you guys can see my screen.
Okay. Yep. I think the screen is good.
Okay, so you can see my screen, right?
Yes. The floor is for you, Regina.
Great. So let me start today by saying thank you to the organizers for inviting me to and letting me to present for this session today. So today what I'm going to talk about is how do you build HTAP solutions using Cosmos DB and Synapse Link. Before we dive into this, let me quickly introduce myself. I'm a cloud solution architect with Microsoft. Please connect with me on LinkedIn, where I exchange a lot of ideas, and we can. If there is anything I can help with, I'll definitely try to help them. So before we get into HTAP and what are the different, what is the solution that we can build, I wanted to share with you what some of the definitions before we get into that, right? So traditionally, we have been seeing these two definitions around the architecture of systems, which are essentially OLTP and OLAP. So if you see on the screen, what I've tried to do is I've tried to list down some of the characteristics of these systems, right? So as you can see, OLTP are your transactional systems, which are very row-based row-based organized system. Your databases are heavily normalized in that, which means you will have a lot of relations between tables, and it is used for transactions. And whenever you talk about transactions, these are essentially small piece of work where you insert a new order, or you insert a new user, or update a order column or something like that, right? And the view that you get out of these databases is that it will be a very current state of your database or current state of your data. Whereas on the other hand, if you talk about OLAP, right? So these are online analysis, analytical processing systems, where the data is organized by columns, right? It will be heavily denormalized to make sure that the data is flat, and you can then run your analytical queries around that. Now you can assume that since the data is huge, you would have historical data. It will take a lot of time to fetch you reports. There'll be aggregations at multiple levels, and even you will have cubes in that, right? Over a period of time, what we have seen is these two systems culminating into one, which is called as a HTAP solution, right? Now, HTAP stands for hybrid transactional and analytical processing. So the idea here is that you run your transactional as well as analytical workload within the same database without any costly third system being in place in between the two, right? So let's talk about what I'm going to discuss today, right? So how do you build such solution on Cosmos DB? So before that, just for a definition purpose, what is Cosmos DB? Cosmos DB is a fast NoSQL database which gives you the capability of storing document or NoSQL non-relational data into your database with any of the storage options. Like you can store key values, you can store column family databases data, you can store typical document hierarchical data, or you can even store graph data within that, right? The connected graph data. And Cosmos DB gives you multiple APIs to query your data. You can either query it like a MongoDB, you can query it like a Gremlin API, or you can query it from a typical SQL or Cassandra or a table API that are enabled there, right? So I won't go too deep into what and how Cosmos DB does that. That is probably some other session. But today I want to talk about how do you build a HTAP solution on top of it, right? Now, Cosmos DB typically has been a very transactional database, right? So you try to store high frequency of documents within it, petabytes, terabytes of data. It can scale horizontally, vertically. There is absolutely no issues there. But let's say if you have to run analytical query on the same database. So if you see on the left side of the slide, I'm trying to showcase a scenario where, let's say, you are storing real-time application data into your Cosmos DB, and now you want to run a report on top of it. So Power BI has a connector for Cosmos DB. You can directly plug in Power BI into Cosmos DB, or else you can run Spark kind of workloads on top of it directly, right? But what is the problem here? The problem is, in case if your data is huge, this will be a huge performance degradation for your OLTP workload, because as you know, Cosmos DB, whenever you provision Cosmos DB, you have to define the request unit, how many number of request units you will execute against it per second. And if you try to go beyond that, you will start getting throttled, which means if you are running your transactional workload as well as analytical workload on the same database, probably you would be exhausting your RUs, and that's why it will start giving you issues. The other way is essentially separating OLTP and OLAP. And this has been one of the more prominent architectures that we see with our customers, where what they do is they extract the data into a data lake, a low-cost storage option, and then you run your analytical workload on top of it, either through Spark, like Apache Spark on Synapse, or Synapse SQL on top of it, and then you surface it through Power BI using dashboards, right? But the costly part here is the orchestration of your transactional data into a analytical schema. right? So you will have to do complex ETLs, you will have to write complex ETL jobs, make sure they run at the right time. But still, you are consuming the RU of your Cosmos DB, and hence what you might do is run this ETL once in a day when the transactional workload is less, right? So we see typically these kind of systems, they will extract the entire data in the night and then go and update your analytical cubes, and then it is available for your querying, right? But because of the enormous amount of data, there is a lot of lag between your transactional data and your analytical data, right? Probably it is T minus 1 day old, sometimes more than that as well, right? So this architecture you might see in maybe 80% of the scenarios that I have been working with. Now, this is where Synapse Analytics comes into picture, right? So what is Synapse Analytics, right? So it's a big data and data warehousing analytics solution, which encompasses a lot of services within that whole umbrella, which can give you the capability of running analytical workloads at a limitless scale, right? This is essentially all the components within Synapse. Them, because this is a very this is a very lengthy topic in itself. But what Synapse can do is essentially all your data that data producers, it could be on-prem data sources, it could be cloud data, it could be applications which are generating data, or even streaming devices that are generating data. You can take all that data, store it into a data lake or a data warehouse, create a semantic model on top of that using CDM, and then use SQL, Synapse SQL, or Apache Spark running on Synapse, and then create multiple applications on top of that data, which could be either Power BI report or any other report. It could be even a machine learning model that you could run on top of it. It could even feed to your CRM or ERP systems or low code, no code application that can be developed on top of it. There is a Synapse Studio, which we will talk about today, which gives you that unified experience of running SQL queries or running your Apache workload on top of these data. And it is limitless, which means that depends on what scale you want it to run, it can offer you that scalability as well. So today what we will touch on is the Synapse Link, right? So what is Synapse Link, right? Synapse Link is essentially a service which connects your transactional data in Azure Cosmos DB directly to a Synapse workspace, and you can run your analytical workload directly on the on that data without writing complex ETL jobs. Now, imagine this, right? Typically, you would be writing ETL jobs to fetch that data, transform it, and then load it into a data lake on top of which you could run your queries, right? But with this, it gives you the capability of running your queries on top of the transactional data without writing ETL jobs. And the best part here is it's almost real time, near real time, as I may say, right? Because ETL job you cannot run. Keep it running every minute or so, but this can do it on its own without any special configuration. So let's get a little deeper into what analytical this Synapse Link is all about. So as you know, Cosmos DB is a transactional database, which means the way the data is organized is in rows, right? So when you store data, it gets organized as a document, which are nothing but a row stored in a typical database environment. When you enable a Synapse Link, what happens in the background is it will provision what is called as a analytical store behind the scene, which is not visible to you to the end user, but behind the scene, what it will do is it will take the same row store data and organize it into column store and build up what is called a auto sync between the two, right? So as you can see on my screen, the row store is converted into a column store, essentially, which is optimized for analytical queries. And then on top of this column store, you get an auto sync capability. Usually it is within 2 minutes that all your data will be available in the column store, even in heavy transaction scenarios, but it is quite less than that, right? So once you enable analytical store, it creates this column store for you. And after that, using Synapse SQL serverless or Apache Spark, you can directly query this column store data, and you can build multiple application on top of it. It could be a BI dashboard, it could be big data analytics, or you can build machine learning model on top of it, right? So this is what Synapse Link is. Imagine this is what a typical pattern would look like, right? So you have Cosmos DB where you have your transactional data coming in. You enable Synapse Link, and with Synapse SQL serverless, you can create a BI dashboard. You can even do ad hoc exploration on top of that data, or use Apache Spark within Synapse and run your ad hoc or big data analytics on top of it, or machine learning. And both of them can be used to store data into Synapse SQL pool for data warehousing. And then this entire scenario is powered by Azure Synapse Analytics. Now, before I get into the details of how you could do, and just one more thing, right? Because Synapse integrates with other data sources also, you can imagine that you can pull data from other sources into your data lake and then use Synapse as unified analytical platform over top of these various operational data sources, right? Now, before I get into the details of this, let me show you a quick scenario here where what I've done is I've provisioned Cosmos DB. So if you can see my screen, what I have here is a typical Cosmos DB. I have a database in it called Cosmos Demo DB, which has multiple collections within it, and the collections have items within it. So you will see a product item here, which is nothing but a document which defines a product. And then you have a retail sales data coming into this. So imagine whenever somebody buys a service Go or something like that, the same data is stored in this retail sales database. Now, in order to use Synapse Link, what I need to do is, first and foremost, I have to go into features and enable this Synapse Link. Once you enable this, the analytical store is created, and the data is then auto-synced into the analytical store, right? And you can see from here that once you have enabled the data analytical store within your collections, you will see that now I can see things like this, right? So I can make changes to my analytical store here. You will see this option coming here, right? Sorry, was there a question? Okay, I'll keep going, right? So once you have enabled the analytical store, what you need to do after that is go to your Synapse workspace, right, and create a link service here, right? So let me show you how you do that. I can go to manage, go to the link services here, and I can create a new one called for the Cosmos DB. You can enable Synapse Link for SQL or Mongo API. You select the SQL API, you provide the details, and once it is done, your link from Synapse Workspace to Cosmos DB is created. And every time you query it, you will use this link service name to query it. So if you see here, I have already created a Synapse, a Cosmos link service in my Synapse Workspace. Now what I can do after that is, if you go to the data pane of your workspace, under link service, you will see Cosmos DB option here, and when you expand it, you will see your link that you created. And within this, you will see all the collections which have analytical store created for them, right? This 3 bar here suggests that it's a analytical store that you are connecting to. Now, once this is done, you can do a lot of things. For example, here I created a new SQL script. You can go directly from here also, right? I can load this data into a data frame, select a Spark pool and run this query against that, or I can run a SQL query on that also. So here I'm showing you an example of a SQL query. I created a database, use that database, and I created a view on top of my product collection, the analytical store here. So the way you use it is you use the method called open row set. You specify what provider you want. You specify the connection name, which is essentially your link that you created, and which object within that. And you should have created a credentials, which is essentially the key to your Cosmos DB. The Cosmos DB key is used here, right? Once you create those views, you can then query them just like a SQL table. So for example, here you can see I am retrieving the products database from product data from the analytical store. So initially when you run this, because this is running on a SQL serverless pool, it takes some time for the pools to start, and that's why you might see some delay here. But once you start querying and using it, you will see the results are pretty fast, right? So what I've done is I'm joining the 2 views here, the sales view and the product view, and trying to find out what are the top products based on quantity that have been sold, right? So I can run this kind of complex or ad hoc analysis on my data, and I can use it for analyzing what kind of products are being sold, which store is selling the more product, and then I can even create charts on top of it, right? So for example, here you will see I have created a category a column chart to tell me which product is being sold the most, right? So what the total quantity of this Surface Go in the first store is the highest among that, right? So these kind of analysis I can do. Now let's talk about some complex queries that you can write within this, right? So essentially, we already saw this. You can do an open row set on top of your Cosmos DB and then do a select or create a view and then run your complex queries on top of it. That is the standard way to create that. There are some limitations which we will talk about. For example, the best practice is that you always use a with clause into your select statement, and this way you can even access the nested queries within your document. So you can see an example here. I have a nested JSON document, and I'm storing the metadata.title within the title column and authors into the author column, right? You can even store complex JSON document in Cosmos DB. Now the question is, how would you query these kind of documents, right? So as you can see, I have a pretty complex JSON document here, which has multi-level of nested properties here. What I can do is to access any nested properties, I can use outer apply to once you Once you create a select statement, you can join the same table with using OpenJSON and then explode it and then access the next level of properties also. For example, here I'm saying go to family.parents, and within the parents, take the family name and given name and call it as a view family underscore parents. The same can be done for other nested properties. So no matter how many number of nested document you have, you can apply, outer apply, and get into multiple level of nested properties also. Right. So this gives you an example of how you can go up to third level. You can try to go up to, I think there are 127 levels that you can go up to, which is possible by using this, right? So there are some constraints, as I was talking about earlier, with this analytical store, right? So for now, you can store maximum of 1,000 properties. It could be nested, it could be the same level, but the first 1,000 properties would be only going into your analytical store. The other thing to take note of is the analytical store is not case sensitive, right? Whereas your Cosmos DB is case sensitive, but analytical store is not. So be very careful about when you're designing the schema for this, right? As always, the first document that is present in Cosmos DB will define the schema of your analytical store. The new columns get added, but the old columns cannot be removed. The schema cannot be reset even if you have deleted all the documents. As of now, the only way is to recreate the transactional store and the analytical store, right? So you will have to migrate your Cosmos DB to a new account if you have to reset the schema. Your properties cannot contain spaces. It cannot contain special characters. For spaces, it is still allowed, but then you will have to go back and change a Spark config, which is allow white space in field names. When you enable this, then you can have the spaces allowed in your properties. And any new properties is considered as a new column, right? So you will have to worry about these constraints when we go forward. So what about data type handling, right? So Cosmos DB essentially can have any type of data that is stored in as a string, or mostly it is stored in string values, right? But analytical store, which is based on Parquet, is very strong typed format, right? So for that, there are two type of schema mapping that is available. One is called well-defined. Another one is called full fidelity, right? So let's look at what well-defined is. So essentially, well-defined is when Cosmos DB sees the first document, the analytical store is created based on the data type that it sees in the first document. So as you can see, the first row made two columns, price, which became float because of the data here, and because it found out that this is a data type, the DOB was considered as the date of birth, and henceforth any document that it gets, whether it is sparse or it has all the data, that gets stored in the columns, right? So this is well-defined schema. What happens when there is a missing data or a data type does not match, right? So for example, here the price is float, but let's say I store a string in that value, you will see that the data is not stored in the well-defined schema, because whenever it sees a mismatch, it ignores that data, right? So you can see here, wherever it did not find the right data format, it ignored the data there, right? To overcome this scenario, what you can do is you can enable what is called as a full fidelity schema Parquet representation. In this, what happens is that whenever it finds out a new data type, it creates a new column in the analytical store with that data type, right? So you would see here, whenever it found a integer 45, it stored it into a integer column of price. Whenever it found a float value, it stored it into the float value. Now, this is good, but the problem is when you query this kind of full fidelity schema representation of your analytical store, you may have to coalesce these values to find out the right value within that, right? So those are few things that you will have to take care of, but this is available. What you can do is you can enable this using the parameter in your AZCLI, update a Cosmos DB and enable the full fidelity schema, right? The other, some of the few best practices that we've figured out when working with customers were, it is always making sense to have the client, your Synapse and Cosmos DB within the same region to avoid the latency between the two, right? So whenever you create Cosmos DB, enable analytical store, the analytical store is stored in the same region, but your Synapse workspace could be in a different region, right? Now, whenever you do that, you will see that there is a lot of latency within your queries, right? So make sure that it's on the same region. If you are querying a large amount of data, try to use the native tools like Spark and all that instead of writing complex things there. Always store your strings into UTF-8 calculation, because we've seen this. One of my customer, they were using analytical store on MongoDB, and whenever you store a document in MongoDB without a ID data, it creates a GUID. And that GUID gets transformed into something jargon when you don't do a proper typecasting, right? So make sure you're doing the proper typecasting. Optimize your schema at both the ends to ensure that you are running this as efficiently as possible. And then, although it's a column store and all that, but your queries cannot be ill or your queries, if they are bad, can bring down the analytical or the Synapse resources, right? So make sure that is correctly done. And as much as possible, if Cosmos DB holds multiple databases, try to scale out your workspaces so that you can run efficient queries against that, right? So let's get into a demo here. Before I get into the demo, are there any questions or any concerns? While I switch to the demo, let me know if there are any questions. Okay, if not, let's see how can you run a typical machine learning model on top of your Cosmos DB data. So as you can see here, again, I'm going to the same Cosmos DB, which has data about my products, about my retail sales, and store demographics. So because retail sales is a typical time series data, we'll try to run a time series model on top of it and then do some predictions on top of it, right? So what I've done is I've taken a simple notebook example here, which talks about how you can do this. So because I'm running a machine learning model, I'm using Azure Machine Learning to run this experiment and log it so that I can look at that data later. I'm creating a AML workspace, which is nothing but this workspace that you see here. And then I'm ingesting some data from our CSV. As you can see, I'm using cosmos.oltp format to write the data frame into Cosmos DB. I have written retail sales using the same method and stored demographic data as well using the same thing. Now, on top of that, once I load the data, what I'm doing is I'm creating a database, and then I'm creating a Spark table on top of it using Cosmos OLAP, right? Which means once you specify this format, it will go to the analytical store and not the OLTP store, right? So it's going to the analytical store container of retail sales and creating a table called retail sales and so on and so forth. Once this is done, you can write typical Spark SQL on top of this views that the Spark tables that you've created. I think my Spark pool has died. Let's see. Yeah, because I was not using it for a while, I think it that. But I have some example here which I can share, and then I can run the queries on top of it. I'm not sure. I'm going to try it again, but. Okay, starting the Spark session. Hopefully it should run here. But what it will do is essentially it's running a typical SQL query using the spark.sql method. And then I can do this in a Spark workspace. And with this, now I'm trying to run a predictive analytics on that. So I'm getting the details of the workspace that I created. Then creating a new experiment here. And within the experiment, then I will start doing some training on top of it, right? So I think it got started and it's running the query on my Spark pool. Okay, we'll come to that. And then I am doing some very simple feature engineering here. What I've done is I have made sure that all the columns are converted to the correct time to the correct data type. And once I have done that, I have created some unique bins for my time series data. Because there are multiple stores, each having their own transactional data coming at the time stores, I'm creating these different subsets, and then I am splitting the data into training data and test data. And then I'm uploading this data to my pool that on top of which I will run the experiment. And once that is done, yeah, so you can see the Spark is the pool is now started, and it ran my Spark SQL query. So this is the data essentially. It talks about a store ID, which product was stored, what was the wholesale cost, what was the base price, ratio of the person who bought it, what is the income of the person, and which category does he fall into, what quantity did he buy, what price, and which week was that bought in, right? So with that data, and after doing my feature engineering and splitting the data into test and train, I'm now running a typical experiment on that with 15 iterations. This is an automated machine learning where I don't specify what type of algorithm I want or what I want to do. All I will say that it is a forecasting that I'm trying to do, and I want to minimize this primary metric here, right? So I want to minimize my normalized mean absolute error. So what it will do is it will run multiple algorithms against my data and try to optimize for that particular metric that I set, right? So I ran it for 15 iteration, and you see it created multiple models using different algorithms, and whichever was the best, after 15 iterations it stopped. But you can see within each of these models there were multiple parameters also which were tried, and after 23 seconds the best metric that it could come up down in terms of normalized mean absolute error was 0.003, which is pretty good, right? And then I can retrieve the best model from the experiment that I ran. I will have to run this again because my Spark pool got reset. But typically what would happen is once you have run this and you have the best model, you can extract that from that run and then use it to do the testing against the test data. And then this is something which you will see after that, right? So if you see, initially I ran it for 5 iteration, and you can see how bad my model was, right? It was not predicting at all at the higher values. But I was assuming that after running it for 15 runtime, it should be able to do it nicely. And you can in fact see here, right, in my experiments, you will see multiple times that I ran it. At the first time that I ran, there were only 5 iterations that I did it for, and within that 5 iterations, it tried different models. And the kind of metric that I was referring to, it could go down to 10%, right? Which was not the one that I was looking for, right? And you can see that when it did multiple, when I ran it for 15 times, right? You will see in the last times it got a better value there, right? So I think it was this one. Yeah, so here you can see the absolute error is much lower than what I was getting in the initial stages. I was hoping that I could use this model to run it. Yeah, it was based on voting ensemble, right? But yeah, this is how you could run machine learning model on top of the whole thing, right? So this is what I wanted to show. One last thing before I go. This whole demo that I showed you is actually available on GitHub from Microsoft. And what I did was I forked that particular repository and completed this whole experiment or this demo. In case if you are interested, I can share this link in my document, the slide deck, which I will send you. And this, once you want to try this out, you can just click on deploy to Azure and provide your details like what resource group and all that is needed. And after that, there are some steps that you might have to do. For example, these are the steps which are listed there. Once you complete this, you will have this complete environment created for you, right? So it will create a Cosmos DB, it will create a Synapse workspace, it will enable the analytical store, and it will create SQL pool, it will create a logic app to shut down and start the SQL pool and all the necessary things that are needed. And once it is created, you will have the notebooks also with you. You can run a forecasting, or else you can use it to run anomaly detection on the IoT data. There are multiple examples that are given there. Just go through it. If there are any questions, let me or anybody in the chat know. More than happy to help you around there. I think that was it from my side. Are there any questions? I think there is 15 minutes still left. If there are any questions, happy to take those questions now.
Hey guys, if you have any questions, you can come off mute or type it in the chat window.
Okay, then I guess we have 15 minutes extra that we can give back to the community if there are no more questions. Ribut, can I stop sharing and maybe you can stop the recording?
Yeah, that's fine, Naginder. I'll be taking over from Rivut here. So, yep, you can stop sharing and we will be welcoming our next speaker then, if he's already joined.
No worries. Thank you.
Thank you so much, Naginder, for your time, especially on a weekend.
Yeah, no worries. I think
Okay, so Naginder, I think we have a question from Hifaz here in the chat window. I'll just read it out for you. So, for best model selection, can we get notebooks for hyperparameters used for each model?
yes, and let me see where that is. But you are right. I can take the details of the model that were created and all the other metrics also. Give me a moment. Let me. I'm trying to search for it. Yeah. So let me share my screen again. And if you know the voting ensemble model that was there, right? So okay, let me go from beginning, right? So essentially, in your AutoML, every time that you run an experiment, and it has to be properly logged, right? So if you go back here, you will see I am logging those details back into my machine learning workspace, right? So I am logging all the info details as well as I am specifying uh, the what do you say? What kind of metrics I want to log there, right? So once you do that, and then you can do your custom logging as well in there. But you will see for every run, right? So this was the run that I did yesterday. This is the run that I was running today. And for within the same experiment, as you can see, I ran twice, right? And let's check the best model, right? So for this run, I can click on what was the hyper parameter that were chosen, right? And what was the algorithm of the best model that came out, right? And if you want to look at individual models, even that can be done, right? So for example, for one of my child run within that, this is the model that got created. And I can look at what was the algorithm, which framework was used for that, and what were the parameters within that. Hopefully that should help answer your question. Again, I'm not an expert in the Azure ML, but I believe if you log those details, it will be available here. I think for now, I'm not sure if, because I used the demo notebook, I don't think all those things were properly logged. But yeah, if you do that, it can be, you can download the model, you can even deploy it to an endpoint or a web service as well. Hopefully that answers your question. If not, maybe email me or send a message on LinkedIn and I will try to get some help for you on that. Is there any other question or comment?
Hey, Naginder, I would just like to add on to Hifaz's question, right, for hyperparameters, because sorry to butt in like that, but then because I work with Azure machine learning,
So for hyperparameters, right, HIPAAs, if you wanted to check, like, for a particular model, what sort of hyperparameters are the best, what combination of ReLU, learning rate, or, other min max scalar and stuff or batch size, epoch size, which are the most optimum, you can create a hyperdrive experiment for that. And on the portal itself, it will show you the best combination of hyperparameters, the one which will give you the highest accuracy or closest to the threshold that you have chosen. So there's an option for that, for creating hyperdrive. It is called as a hyperdrive experiment, which will compare the various possibility permutations, combinations of hyperparameters. You can give the parameters which you want, like, as I said, learning rate, epoch size, batch size, and it will come out with the various permutations and give you the best selection, like epoch size 10, batch size 25, learning rate 0.001, something will give you the best accuracy, something of that sort.
Yeah, there you go. Thank you, Priyanka.
And Naginder, one question from my side, Priyanka here. So, because if you're, I mean, if you're talking of synapse analytics or synapse pipeline vis-a-vis Databricks, then why choose synapse over Databricks? Because as I see, right, synapse is a very steep costing.
So as of now, to query analytical store, it can only be done through Synapse workspaces. And that's the reason I've chosen Synapse Analytics. But yeah, that's a good question, because eventually the analytical store is a Parquet representation, right? Which means if I have the correct way of connecting to it, I can use Spark or SQL running in any other system like a Databricks, or for that matter HD Inside, and query it, right? But it seems that the Parquet representation is a very specific or very particular or customized that Microsoft has developed for this, and only Synapse Analytics for now can query the that store, and that's why I used it.
Okay, perfect. Thank you for that. All right, so I'm just waiting to see if our next speaker is there with us. Hey, Rivut, is Aroha here already?
Hey guys, Aroha will be there with a short.
Boys, you share, okay? Okay. There for the three of you. Boys.
Yes.
Yes, boys.
Yes.
Hello, guys. I'm here. Sorry, I have another session in one. Yeah, so yeah. So I can start the session now. Is it already 2 p.m. now? Rivit, I can't able to share my screen.
Hey, Aroha, just hold on. Let me make you presenter.
Sure, sure.
Hey. Hey, can you share your screen?
Okay, yeah, I can go to share my screen. Thank you, thank you. Okay, check
Yeah,
whether
sorry for completing my session early. I I put you in spot. Huh?
Me? No, it's okay. No, not a problem. Actually, I have one more session, another Azure session for the Pune group. So I just want to just finish that off and have this session. But this is Singapore session, so I want to do well. Yeah. So
Hey, no
let
problem.
me.
So, Aroha, just try sharing your screen once. Let me see if you can.
Yeah, I hope you can see my screen now. I can see the red screen.
Hello?
Can you hear me? Can you hear me?
Yeah, I can hear you all right. Yes. So yeah, you can. Yeah, your screen is visible, right? Okay. Hey, Aroha, welcome and right on time. Sorry, I was chasing you to jump in earlier. So hope your earlier session was good.
Yeah.
And we welcome you here in the Singapore version of Global Azure. Okay. And hey guys, Aroha, I needs no introduction. Very familiar face in all of our Singapore user group communities. So he is an BizApps and SharePoint expert. He is an MVP, MCT speaker, blogger, and works at Insights Technologies as a Microsoft technology partner. So Aroha, the stage is all yours, and we are eagerly waiting for you to share about Azure Data Services.
Yeah, thank you, and I'm really happy that we have expert also here in case I could not answer, so that I can just read. So we have so a lot of people are there in case I couldn't answer. So that let me share my screen. Let me start my session. So guys, this is Aro here. Thanks for wonderful intro of mine, Priyanka. Really thankful to you. And somebody had to unmute. Okay, so I'm going to start with my session about the getting started with the data services, Azure data services. So about myself, I have experience in 365. I'm does a lot of Teams, SharePoint, data platform. I also powerful train. I do a lot of trainings to outside and to my company as well. Okay, if you want to contact me, you can see in my slide deck here. Okay. So agenda for us very simple. I'm going to share you about the basic core data concepts we have, and we talk about the second is about relational data which we have. So I have some demos, and then we have a non-relational database which we can use in our in using Azure. Lot of both. Azure and some other non-Azure products we can use in our products as well inside. And then I also show about some modern data warehouse analytics tools which Azure can help you in this. Okay, so again, start the basic one. We have what's the data. We have different types of data in again, I'm not about basic data I'm talking about. The first one we have the structured data. The structured data is where you have tables and columns, right? We have seen from the college and universities about normalizations and those things and all from, and even in different organizations, we use structured data. Mostly it's called as normalization of tables from split one table to another. Then we have semi-structured data, which is called as a JSON data or could be a CSV file. And we have another thing, but it's called as unstructured data, like your video files, your large files and all. Okay. Other systems, we also have something called as a OLTP and OLAP, right? Now, OLTP is mostly used for the translational databases, right? SQL database and all. You had a lot of data to be insert, right? So that's the use of the OLTP. And what is the use of OLAP? OLAP is typically used for your periodic data, mostly for aggregation, right? So what the use, why we use OLTP and where use OLAP? OLTP is mostly for your, when you want to insert database, you have to update, delete. So mostly used for your typical databases transactions like SQL DB and Oracle databases and all, right? Which have the data be frequently be added. OLAP is typically used for the large data set where you don't query, we don't insert, but you mostly query. Examples. These are the example of the of your OLTP and OLAP queries and all. Now, we can do batch processing and the streaming services. So batch processing is where your paid billing, right? For example, your Azure monthly bill, your credit card bill, monthly you pay for that. You pay for that, right? That is called as a batch processing. Other processing we can use is called as a streaming database, right? Example of your IoT devices. Think about your Twitter, Facebook feeds and all your LinkedIn feeds and all. That is called as a streaming databases and all. So it's something which is a very large data set. You want to update those things and all. So that is the use of the typical use of the core data sets. Now I want to share about the relational database which Microsoft Azure has provided to us. The first one, we have something called as Azure DB, Azure SQL database. And then we have something called as a MySQL database. Then we have PostGRE, the MariaDB, and we have a PostGRE database and all. So these are these one is from Microsoft. Okay, and these three are supported Microsoft. So Microsoft supports these other services. So people who have done much better experience in the MySQL or MariaDB or PostGRE, Microsoft support these databases to you. Right, it's a very, very amazing tool which Microsoft provided to you. I can use it as your hard content. Very good for the people who are want to learn how do things works in the SQL DB, MariaDB, or PostGRE. You can Microsoft support these applications for you. Okay, now you have seen these slides previously. I want to share with you that why we are using this slide, because in my next slide are actually related to this. So first one, we have a private cloud. So you manage everything there. You have your where is my pointer? Yeah. So you have on-premises. So you manage all the things. Think about your hospitals and defense systems and all. So you want to manage your private clouds. You manage all your servers, all your OS, everything. They want to be safe. Examples, right? The G Cloud in Singapore. G Cloud is an example of the Edge Cloud. These are the Edge Cloud, hospital clouds. So all the hospitals, they have their own cloud premises. They have their own servers, right? So there's an example, even for in India and US, they have different private cloud they have, right? So that they manage their own applications and their servers, OS and all. Then other applications we can use where your cloud provider, maybe Microsoft provider, these applications provide this compute services, networking, and storage. So these called as IaaS services. So all other things be done by the customer. Customer has to manage, and this is done by the Microsoft. Okay, and then we have platform as service. So Microsoft will provide all things in the runtime, your OS, your storage, and the data is provided by the your the customer or user. Okay, and we have the last slide is something called as applications. All applications maintained by Microsoft, and only the data access done by you. Like example, your Gmail, your Outlook, your all other services like that. Okay, now why I'm using this thing is because many customers they are still want to do on premises, but they want to have some the innovation of the cloud like Azure. So what they can do, they can do go to the SQL Server on premises, right? And they can have on premise. These are the people who have not touched the server, right? Yeah, they want this on the doesn't want to touch the cloud. They want to have all things on premises, right? Physical server, on premise people, right? They doesn't want to touch it. They are totally avoid of the cloud. But if they want to have some innovation which Microsoft and Azure is providing, what they can do, they can just move their servers and call as a SQL Server on the VMs, and they can still have a full capability of their SQL servers, whether it's 2021, 22, or 2019, any server, and Microsoft manage that application. So I mentioned to you, IaaS actually help you in terms of this computing. So all the computing things are done by Microsoft computing and all, and the VM OS is done by the customer. So customer can deploy any VMs, does any other things and all. This is the beauty of IaaS applications, which is maintained by Microsoft. And the other application, which is called as a SQL DB, is a full capability. You can have a better capabilities. You can have the cloud storage. You can have your elastic pools, everything you can do yourself. So now you see here, effort required. Obviously, when you do physical server, lot of cost is involved and the effort is required. So physical server is always a high cost, and always a lot of admin cost required. Many people to maintain. Maybe you have a team of IT developers. I need at least 6 or 7 people to manage my servers. But if I have a IaaS or I have a PaaS, I have only 5, maybe 3-4 people maybe to manage my servers. I maintain and all. So you have a lesser human resources and lesser efficient, lesser cost, right, for that. So you have a better costing, and that's why the use of the IaaS and PaaS, how we can use it in your different requirements. Okay. Now, one thing I want to share in this slide is that many customers, even my customers also, they are moving from the on-premise to the cloud, but they want to have more flexibility. Maybe they want to have. So in those customers, they can use the SQL Server on the VMs. SQL Server on the VMs. The beauty of this approach is that you can have any version of SQL Server you can manage, supported by Microsoft, and everything is maintained. The only things they have to do is that install the latest version and other things, right? So when you use IaaS, Microsoft will manage all the computing and the storage. Other things you have to manage. And other applications like the managed instance and SQL DB, you have full capability. So people who want to do lift and shift, this is the best way. Lift and shift, this is the best way to do it, right? People who do want to do on premises, they want to full capability, and use of managed instance is amazingly good because it gives you almost 100% capabilities. Sorry, compatibilities with your SQL Server. So the server you have in SQL Server, we have a same almost 100%, nearly 100% capabilities which you have in a managed instance. So that is called as a platform as service. Okay, and then we have always have a SQL DB, which have elastic pools, everything, which have all the goodness of the scalability which you can do. Okay. So one thing I just want to share that when they use an IaaS application on the VM, customer has to manage everything. I'm highlighting in bold that this customer has to manage all the OS upgrades, all the upgrades and the backups. Very difficult if you don't do this. But if you doesn't want to do it, I don't want to manage all my servers and upgrades, then go to other tool, another approach, but it's called the PaaS, right? This is called as a PaaS application, right? I can use my elastic pool example. example of one of my customer asked me that, okay, why we use elastic pool. So I give an example that maybe think about the example of the foreign exchange, right? Foreign exchange, or think about a COVID test in examples of in US or India examples, right? In morning, they push the data in the SQL server, right? So the data will be too much data in the morning, but in evening will be lesser data. So in elastic pools, you have you can have multiple databases with the same storage. You can have increase the capacity, and you can have the same storage. That is the beauty of the elastic pool. One of the examples I want to share with you. Okay, managed instance I mentioned is very useful if you want to have lift and shift. Okay, and this is something which I again put slide that is 100% capability in your SQL server. So you have a SQL server, you want to move to the SQL server, you want to have a same capability, you have the option for you is a managed instance. Okay, so these are examples between the when you use managed instance and when you use SQL DB. Again, different use cases and different customers have different use cases. So if we want to have managed services, both these applications give managed services, which means Microsoft provide your storage and computing services. However, I want to have a same level of my SQL server, right? And then I'm able to lift and shift. Then I use managed instance, right? I want to use maybe a large database. I want to have more than 100 terabyte of data. Then I can use hyperscale. Now, these are completely based on the customer use cases and depend on the business requirements, right? So we can't dictate the customer's requirements. We have to ask them what they're looking for and give a proper advice to them, which system, which application, which particular approach, whether it's IaaS will help them or whether it's a PaaS application will help them. So having a proper integration, a gap analysis, what kind they're looking for, then give a right approach to the customers is the best way to for the adding customer, right? And one thing I want to share with you that Microsoft also supports to the PostGRE, SQL, and MariaDB. And one of the exam question, people who are working on the working on this DP900, one question might come about which database provides you the both relational and non-relational. So the answer is PostGRE SQL. This is the only database which provide both SQL properties and MySQL properties. SQL and MariaDB doesn't help in this. They are relational databases. Okay, so this is the thing I want to show you now. Now I give a demo about how we can create a simple. Again, I'm giving it's a fundamental session. So I'm going to give a very simple example that how we can easily create a SQL DB and what are the things to be take note. Okay, so I click here. So it's one of the demos I will share with you. Okay, so first thing first, I have my Azure portal. I click on my Azure portal, and first thing first, I want to provision a new relational databases, right? So first relational database I want to do is a SQL DB. Okay, so I click on Azure SQL. Now again, I'm working on the Azure SQL, the relational databases, just like your SQL server on premises or your Oracle. So right now you can see that there are more than 100 plus services in Azure, more than 100 maybe, but in our scope, you're talking about the how to provision an Azure SQL database. Okay, so I click here and you can see that I showed you that we can have databases, we can have managed instance, we can have a SQL machines, all three things I showed to you. So I click on the create button and again, I can go to manage instance or the VMs. I just click on the simple one, which is called as a Azure DB. Now, this approach is best for when you want to have a modern cloud application which can be used for hyperscale, more than 100 terabytes, or they can use serverless. Again, I give a simple demo, but this is one of the most useful approach if we want to have a modern cloud applications. Okay, so I use a simple database. Okay, and I use this resource group. I create a global Azure Bootcamp Singapore resource group I created before that, and I create a database name. And I put a database name called as Azure's, I call it as Adventure Works. Now, many options I can go for, but I can put database name, and I put a server name. So this is a database name, and I put a server name. So I can go for server name, and my server is this server, Azure SQL. Okay, and the location. Okay, I think I already have 1, 2, 3. Okay, so I have this database name. Okay, and this change to. Okay, so you already used it. Okay, so I put 1, and then I can use the login details. So when in the SQL Server, you have option to go for SQL authentication, Azure AD, or you can use both. So I'm using the default one, using the Azure default one, and I put the default password, the password 1, just for testing purposes. Recap what I did. I just created a new server, okay, and I created a new group, and I just creating a new server database name. That's it. What you do on-premises deemed, I'm doing everything on the cloud right now here. Okay, so that is the one thing. And I again put the elastic pool I can go for. But one thing, as I mentioned to you, this is a lot of things, but this is very useful if you want to have a where your resources can be elastic, can be increased in a specific time zone, different time, or in specific time it will be reduced. So using an elastic pool can be useful on those contexts. But this is simple demos. So I'm not going for that. Okay, and also one thing is if we want to use a backup storage. Now, again, depends on the use cases. If I want to have my locations in Singapore, India, in Australia, in Europe, then I can use geo backup storage. But if I want to use only one location, maybe local, I can use local. Now, depends on the use cases I can go for. But in my demo, I'm going for one of the simplest demo here. At least you can get the idea how it can work. You can have a optimize, you can change, doesn't matter. So I go and click on the networking now. Now, in the networking aspect, I can go and do configuration. The first one I go for no access. Now, if I no access, which means nobody can able to access this particular server. But I go click on the public endpoint. So my public endpoint, which means everyone in the world can see this particular endpoint. But is it safe? No. The best way, maybe best practices could be you could put some endpoint to put some regions so that only specific regions can see that server. So I put a demo here just for the public, and I also put some firewall rules as well here. So in case for the use cases perspective, you can have a understanding that how you can able to provision your networking and how the firewall rules. I really tell you, it's not best practices to always put the firewall. You have some specific endpoints. Only those people can able to access it. Okay, and I click on this. So that's why I'm doing it. Just click on the default security points, and yeah, that is the thing I want to show you. Yeah, and the security endpoint. Another thing which we can do here is the security for the enable the Defender. Now, people know in your laptop you also have Defender, right? Yeah. So mostly the problem is that can be used in any system. The hackers are very smart. They can attack any applications, right? Even SQL Server, even in the cloud. So if you want to have a slightly more security, what you can do, you can go and enable this thing, right? But it's free. But you have to be very cognizant and aware that when you do enable the SQL DB and you enable the Defender, the cost is always high. You have to pay per use, per server, per month. It depends on the use cases. For my demo, I'm not doing it. And I just click on the next button. And I do a sample because I show you that how I can query a database. OK, so I'm using the sample database. OK, and then I click on the tags. I use I put Azure server. And yeah, so this is my tag. And just want to share with you that each month for this server, I will be costing around $380 per month for this one server. OK, so let's recap what happened. We have done. We have basic details. We have the networking, security is there, and click. OK, so this is a SQL database we have done. I've not done all the details here. I just want to share with you that what you can achieve in your SQL DB. Again, one of the examples that I previously, before I worked in the cloud, maybe 7-8 years back, I was on the on-premises person, right? And I work in one of the agencies in Singapore. And what I have to do, I have to set a new server. So I have to set up a new Windows server first. And then I have to do set up the SQL server, and then have to install the SharePoint server 2016 or 2013, what that matter. And that particular time will take at least 5 to 7 days. And then it goes to the security team who checks at any kind of things. And I also have to do hardening of the servers, whether it's a Windows hardening, whether it's a SQL server hardening or SharePoint hardening. I have to do a lot of things inside. So you see that creating a server, installing a Windows server and SQL server, how much time it takes from the on-premises and how much time it takes, how much the backup storage, everything can be done very easily. So I showed you within 5 to 10 minutes, I've created a server. OK, all the networking things have already configured, and the backup, everything is stored handled by Microsoft. So you see that how much time, maybe some 7 to 10 days, which takes for me previously and in an on-premises organizations. Now in the cloud perspective, how much time it takes, just few minutes. I can do better things. I can do some coding. I do some kind of better things. I can do IoT devices and all. So provisioning of the servers is not a very amazing stuff, but having the better scalability, having a coding for the other applications, that makes life easier and better for the Azure developers. OK, I can do better things for my customers and my end users. OK, so that is the thing I want to show you, that how powerful creating the applications and we can provision. Now it's almost done. I think at a few minutes it'll be provisioned. Any questions so far by anyone so far? Okay, I think we just wait for a few minutes. It will be done. OK. OK, so it's already provisioned here. OK, and again, one thing to show you that you can have a capability to integrate your SQL DB with the Power Platform capabilities as well. You can have interaction with the Power BI. You can have interaction with Power Apps, Power Automate, any other application you can integrate. But in our end user, our use cases, we are not using it. This is not as your thing we are doing it. So I'm just going to show you that how we can easily query a database. OK, so I server name is OK, and I put the password, so I'm just logging. Actually able to, I can install SQL Server management tools inside, but it takes some time. So I can do everything query inside. But you can see I have all the tables, all the customers table as a sample database did. I can see all my views here as well. I can see all my storage procedures. right? That is the beauty of this. Okay, and later what I can do here is that I can search and query it. Okay, so I go and search my products. My products is here. I can go and search for that. Okay, so this is a way I can able to provision a simple database, and you can see is within few seconds, within few minutes, I able to provision my server. Okay, so that is a example of the Azure relational database. Okay, let's go and to do something else. Let's go to non-relational database. Okay, and all database is different. Now you see that in last couple of years from the 90s to 2000, we have ton of data. Think about the IoT devices. Think about the social feeds. It's very difficult to maintain that much data. Now, relational databases are very good. Okay, we are using relational database every time, everywhere, every day we're using it. But when you want to use something which is um, really high database, we have a ton of database, petabyte of data, petabyte of data. In that context, we have to go for some other approach. The approach is using something what is NoSQL terminologies. So NoSQL in remember we have in relational database we have relations there. In NoSQL terminology we don't have any relationships, okay, and we don't have any kind of stored positions as well. And examples and all the data is normalized as well. And the example is Cosmos DB, right? So we can use if you want to use big data and all, the only option is using the NoSQL databases. Example is your table storage, right? Example is I want to have some key. Example of my storage, my address. I can have the address. I can have my address blocks. Everything can be done here. So these are the examples of the key value pair, which is unique for each row. All right. Now examples is for Azure file storage. In Azure file storage, what we can do is that, again, examples of my customers that they have on-premises applications, and but they want to have because the servers are always be updated. They want to move those files to an Azure, but safe security. So what they do, we mostly have to having the Azure file storage. So we have the same kind of capabilities which they have in your network pass which they used. So we can have the data till 100 terabyte. We can have data till 100 terabyte, and we also have something called as SMB protocol. We can use it. That is the use of the file storage we can use in Azure file storage. Okay, and that's the beauty of now Cosmos DB. Cosmos DB is a multi-model SQL database system. You can't use in SQL here, right? So what this is, why we use it is because of can be when you use a multi-regions, multi-places. I want to have a database in SQL in Singapore. One is Australia, one in Hong Kong, one is India, one in Europe, one is Paris, one in things. So the scale become a big challenge. And the data is too huge. So in that context, we can use Cosmos DB, one of the example. And the good thing is that you can have a real-time access for this. Okay, and the beauty is that you can have a scale out and have a storage capabilities. Okay, one thing I want to share with you is that where you use it. Now, everyone maybe in this group and all the people, do you know Microsoft Teams? No, right? So where all the messages and the images are stored, they are stored in Cosmos DB, right? Just want to give a relation there. So they can relate in the websites, they can use in the website and Cosmos in the gaming and IoT devices, IoT hubs and all. So you give you a better performance because it's very fast, and you can use in different use cases as well. Okay, now example is that you can Cosmos DB you can use in different APIs. So one of the recommended APIs which Microsoft recommends is using the your Azure your SQL API, which is default one, and we can use the table API also. Table APIs is mostly when you want to retrieve documents, right? When you read documents, and you can use the Cosmos DB with tables API as well. Okay, and also we can use the same thing, Cosmos DB with the MongoDB as well. The MongoDB helps in specifically use case and where you want to have on-premises applications as well. Okay, we can use the same thing in your on-premises as well. It's a Cassandra. Cassandra also use on-premises database also, right? So there are a lot of options we can use. Depends on the different use cases. You can define the creating a Cosmos DB. Okay, so let's provision a new Cosmos DB. One thing I want to share with you is that the cost perspective, cost calculator. One thing which I want to tell you is about the RUs, about relation units, right? This is very important because few of the customers we found that not my customers, few of the webinars they found that the Cosmos DB is very costly. Is it costly? Depends on what you want to achieve it. Okay, now I want to have maybe have multiple regions. I want to have maybe 10 regions. I want to have Singapore, other regions. I want to do it. I want to have multiple regions. I want to have different database transaction I want to do, right? That much database, and I want to have analysis, right? So these are the things which we can do, and I click on the calculate. Okay. And I don't know how you see that much cost will do per month. So it depends on how you cost it. It's very, very important that when you are provisioning the Cosmos DB, I just tell you that creating the click by click is very easy. The main thing which I've seen from many in my consulting knowledge, that most important, have the proper stakeholders who have a proper understanding of what you're provisioning, okay, and how much it may cost. That is a key thing. Clicking is one of the least important. Having the stakeholders differences and all, that is the most important thing which you can do, right? So and just go and create a new database. Okay, so I just click here, and in my example, what I'm doing, I'm provisioning a new Cosmos DB. Okay. Okay, so this is my example I'm doing. This is my second demo. I have a last 2 demo more I have. So let's provision on Cosmos DB. Now, just assume that you already discussed with the Cosmos DB, have the costing with all stakeholders. The management have a green signal. Now, once the management have green signal, then you can do everything. So very important to have a stakeholder discussions first. Whether it's your SQL DB, whether it's any customer, any user, have a proper stakeholders discussion first, and then you implement. Okay, so I click on the resources, and I search for my Azure Cosmos DB. Okay, and click here. So I mentioned to you that we have 5 different APIs, right? We have 5 different APIs. 1, 2, 3, 4, 5. So here, same 5 you can do. But what Microsoft recommends that we use, they use this use the core SQL DB. They recommend. So let's go for recommended one. Okay, and I go for SQL Server. So the same process we do, like what we did in the SQL Server. So I have a resource group which is called as a Singapore resource group, and I create a new resource group. I define called as a, and I called as a Azure SGP. If I too small. Okay, so this is already provision, and I can go for the which region. I can go to any region. I can go for, and So it's recommended. Where is my? Okay. Okay, and you have a different capacity. You can go for different capacities. So you can go for serverless. Again, I'm not going to interact. When you go for serverless, you don't need to provision a VM and all. You have everything is provisioned behind the scenes, right? But I'm going for the default option, which is Microsoft provided, and the RUs, I mean the default tier, right? So RUs is the resource units, right? And when you provision, you have to be very, very aware that if you're testing, go for the free tier, okay? It doesn't apply because I already used it. So I'm going for this, right? I already used it. So free tier is doesn't apply. And I just go to the next application, okay? And yeah, so that is the thing. So that's what I'm doing. And I just click on the create button for the Cosmos DB, yeah? Okay, and you see that it has giving a preview of all my options, that how much it creates and all, in less than 1 or 2 minutes it will provisioned. Okay, when I click on the template here. Okay, so it will take some time, right? So this is something about the Cosmos DB, and if you want to learn more about Cosmos DB, there are a lot of resources I can refer to you, which are so always go for this learning path, because this thing will give you how you can go started with the Cosmos DB, and they have lot of resources. I mean, I'm very appraised that Microsoft providing a lot of free resources where they can actually check with all the users how it works. And also, if you want to learn about how the Cosmos DB works, this will give you a better option. Although it's a very 6 hours around that thing, it gives you very in depth about the why is used, what is the request units, what is the DT use, everything. It gives you very in depth, right? So what I'm sharing with you is a very overview, okay? And when is the appropriate APIs to use, right? Something which we can use it in. So let's see, and I hope I will still take some time. Right, so something which I have want to share with you on this. So something which I use this learning path for most of my exams as well. But if you want to learn, if you want to have any other things for this learning for this certifications and all, you can go start with the DP900. For example, if you want to go for DP900 exams, you can go start with this, and then go to learning path, right? This one. So the Azure data fundamentals, what I'm sharing with you is give you the details about how you can start with this, right? So this Azure data fundamentals will give you the data concepts about all the storage files, how about the different role and services, right? So you can have and learn in this, right? It's very useful for the people who are just starting with the data or with the AI specifically. Okay, so my is done. My Cosmos DB instance is already created, and I click on here. Okay, so this is the I am done so far, and I will go and I create a sample table, a sample data, right? So I have no data. Last time also we created a simple adventure works table, right? So we have a sample data. I click on here, and I think in few minutes a sample data will be created here. Okay, so what it's doing is creating a sample data. It's also showing a container which called as a persons. So it's our database will be actually called as a person database. Okay, and soon after a few seconds it'll be provisioned to us. Okay, so it's a provisioning, and soon we will have a database there. Yeah, provisioned successfully. Now you can see what I can do. I can just click on the persons. I can go to items, and I can see that I have a lot of data. I have a sample data. I have 4 rows, but I can create one more row I want to create. So what I can do, I can create a new item. Okay, I create a new item, and that item I create as something called as a JSON entry. This is a JSON entry. I put a new entry called as 123 Bob and 54. I click on save. And soon after this, I can go to the scale and I can query the data. I can query the data, and my query data will be like this. SQL Server, my Cosmos DB. Okay, it's not SQL Server, it's a Cosmos DB, right? We are not using relational database, right? You can see when you do it, it just shows as a JSON content. Okay, and also I can also manipulate. I can show some additional data. I can show you here. Okay, then I have all my query inside. I can do same thing, but just want to let you know, in previous example, we're using relationships, we use views, but in the Cosmos DB, it is stored relationships, no stored procedures, everything actually using API. So we're using the SQL API in this example. Okay, now I go to still have some time. Let me show the other aspects of third module is called as a modern data lakes warehouse analytics. So there are a lot of ways we can have different data sources. So we can have something called as Azure Data Factory, and we can go for the Azure Data Factory, Azure Data Lake, and Azure Databricks, HD Insight, and Analytics. So again, it's a very overview, but let's go step by step. What is that? So what Azure Data Factory does, I think they have a lot of demos so later on in this, but what it does actually is an integration service. So I want to have one data source, I want to convert it, right? That is the use of your Azure Data Factory, is stored, have one data source and convert it. That is the main use of Azure Data Factory. And then we have Azure Data Lake. Azure Data Lake is we want to store a large data sets, right? Large data sets. So we can use the large data sets, maybe terabyte of data or petabyte of data. So Azure Data Lakes will be a nice, very good option, which we can use it. We can use Azure Databricks. It's very, very useful. We want to have a large data sets. You can use in your in Python and R, and you can use Jupyter notebooks. And we can use something called as Azure data analysis as well, right? So we can have an analysis service. So you have your data sources from different sources, from SQL, from other sources, for other data sources. We can ingest the data. We have a data, and we can have visualized data. The only problem with this is it doesn't have visual data. So visualization we can use in our Power BI. So Power BI is a visualization tool, and we can easily use it. So we can use a Power BI desktop first, and we can have a desktop service which can easily create dashboards, and we can create uses in mobile applications. So if you want to show something to the end users, a management number of forecast, you can show using this way. Okay, and let me show my last demo, at least get an idea. The first demo was about the relational database, which is SQL DB. Second demo, what I showed you as Cosmos DB, which is us NoSQL. Now it's analytics. So I'm showing you the third way to show the analytics way. So let me show the last demo, which is about to provisioning the data from the Power BI. Okay, so I create a data. I have a data which I create here. Okay, and my data is again from sample, right? Because I can't create sample default by default, so I create some samples. And my database is from one of the websites. the first site I'm looking for is one of the sample data, which is called as I go to web. Okay, and from the web I search for some data, GitHub data, and this is the product, but it's called as customer data. Data from SQL I'm getting, right? So I'm getting data from the web. So I have data which is from the names, customer ID, postal code, regions. I load the data. Okay, so I have two more queries to fetch. So I go and I created web, and I also go to second query, second source, which is called the products. So I have customers, I have now have products. So products, I have the product ID, product name, and categories. Click on load. And the last one I will do is something called as for my orders, all my orders. I click on my orders. Okay. And this. So this is again, I'm not doing any very basic thing I'm doing. I'm just fetching the data. Just fetching data from the one of the source, which is from the internet. Okay, you can get the data from many data sources, right? You can get from a SQL Server, from many sources. Okay. Yeah, you can get data from databases, from Oracle, from IBM, many data sources, from Azure, obviously from Azure, right? A lot of things, HG Insight. So a lot of things we can do. So in my example, what I want to do is that I want to just see is everything's working fine. This is my products. So I have a product, I have a customer ID, I have product ID, but what I want to do is in my revenue, I have to change the formatting, right? I do formatting to currency. It's the first thing I do. I save it locally. I put a save in my Power BI desktop, and I save it to my Singapore. Okay. Now, second thing, what is the use case? The use case I want to show to my customers all the reports in different cities, all the orders in different all different orders with different products, and the products as well. I have to show. So in that I want to show as a drill example of in India, right? We have different states. We have Madhya Pradesh. We have Uttar Pradesh. And in US we have different states and all. So you want to go to drill and state. So example, in Madhya Pradesh, we have go to city called as Gwalior. I want to see how much bills have done, how much costs have done in the Gwalior state. So this drill down approach we have to do. But drilling options we can do only with one option called hierarchy. So hierarchy we can do very easily in our data model using something called as here. So here what I can do, create in hierarchy, right? Why would do hierarchy? So I can drill down from one location to another location. That is the use of hierarchy. So I click on the hierarchy. So already done, right? This is the hierarchy I've done. But I need a product also. I have to show to my end users which city have sold the maximum or the or minimum. So I click on my hierarchy. I add to my hierarchy, and I do it like this. Okay. So this is my hierarchy, and what I do, I just rename it. This hierarchy is called as categorized product. Okay, so I've done this thing. So I have done the hierarchy part. So let's go back to my report now. Okay, so I'm going to the report now. So first thing I click on the, it's called a sales report. This is sales report. I can just increase the bump the font size and increase to 40. Okay, and okay, and here what I will do, I just I want to just check in the security options in the maps if my maps are shown up there. Go to security. Yeah, maps are shown up. Yeah, so maps are showing up. No issue with this. So in my report, what I want to show the report to my end users. What I will do, I just click on the table matrix. Click on the table matrix and just click on my matrix. So I got the product. So this is a hierarchy, right? I have a category. A hierarchy will be shown later on. So I click on the products. I maybe increase the font size. Okay, I put to maybe this is good enough. Okay, and what I do, I just here. Okay, I also increase. I also show the revenue to my end users. Right, so to my revenue. Okay, so I remember I changed the formatting. I show the formatting here, so I can do the formatting. Now what I can do next is that I can just change and I convert this visual to a stack column chart. You see, stack column chart. Now you can easily see that the tour biking is always had the highest cost. Okay, and the road bikes is the lowest, is a second, right? And then we can able to go and drill down. You see, I can drill down. You can see the each option I can go for. That is the use of the each region which I can go for that. So this is the use of the drilling options which we can do. I just do copy and paste. Copy visual. Okay. And what I will do next, I will just go and I change the pie chart. You see, now you can see the product name and category, right? So user can see in both options. They can see either in the bar chart or in the pie chart. Doesn't matter. I can actually remove any options and all, but you get the idea how it can work. Okay. The next, the map as well, right? So I click on the map visual here. Let's go back here. Map visual. And in the map visual, what I want to show to you is about the city. Okay, and in this I click on the city. So in the customer, what I do, I click on the location as city. I can just drag here. Automatically shown the city to me. Okay, you see, automatically become city, right? Okay, and also I want to show to my end user that which city is doing the highest revenue. Okay, so I click on the revenue, and you immediately see the idea that which region I go to a specific say regions, and be able to find that in this city, this particular city is having the highest, one of the highest revenue. Okay, and this way we can easily show to our end users using analytics. Now I'm not integrated because I want to show one more demo for how you can use Azure Synapse with Power BI, but very short time I have, right? So that's why I just cut down and show the Power BI, which is mostly the very visual to show to you. And so what I've just shown my all three demos, one for the relational database, which is SQL DB. Second was the non-relational database using Cosmos DB, and third one is an analytics tool, which is called Power BI. Okay, so I still have 3 minutes. If any questions you have, you can just ask me.
Yeah, Aroha, there is a question in the chat window by Hifaz.
Yeah, Hifaz, yeah. Hi, Aro, for the field, the flowchart benchmark.
Should I read it out?
No, I actually able to read. It's not the issue. The green field. First, can you just unmute yourself? I am not able to relate what you are actually able to. Your question is.
Yeah, Haro.
Yes.
Say for like a customer is embarked on a new project.
Yeah. and we have this, for like a transaction databases, we have few choices here. So how, like, is there any guide or benchmarking or flow chart by which we could choose between one of these, either Azure SQL or MariaDB, MySQL, Postgres, SQL? Yeah. Okay, so a main thing I want to ask you, if the customer is already using MySQL, go for that. Because why I'm telling this thing, because many organizations are already using MySQL or PostgreSQL. If the customer is completely new to this, then I will recommend to use the SQL API, which one is much easier for them to, and you can work on that. So that is a again based on the user requirements you use. Now there you asking about another thing, Azure SQL. Azure SQL is a relational database, right? So if you want to use Azure SQL, you have to ask your customer or your end user where are they moving from on premises to the cloud, or they are just they doesn't want to move to the cloud, or doesn't want to move to on premises. They just want to use the latest features of the Azure, and they want to use Azure DB with the hyperscale things. Then you use the Azure SQL DB. So those are the different use cases. There's no guide which can provide you this thing, which is it's about you ask the question, ask the stakeholder what they're looking for. I mean, from the very high level standpoint. So this gives you an idea. Sanjeev sir, you have anything you want to highlight, or Ritvik, you have any other things? I'm talking about my customers base. If you have anything you want to talk about, sir, Sanjeev sir, from your experience you have. So I'm telling about my experience, which I've seen with not about our Cosmos DB specifically, but for the what kind of database you want to implement. So it can be cloud database, or could be a on-premise database and all. Okay, so Hafiz, maybe I answer your question here. So let's see. Okay, so I'm overshoot by 1 minute. Okay, so thanks everyone for your time, and then and I'm going to next topic. Yeah, thanks everyone, and a great weekend.
Hey Aroh, thank you so much, and we wish you a great weekend too. Thank you for doing back-to-back sessions.
Yeah.
Appreciate it.
Thanks a lot. Thank you. Bye bye. Take care.
And we already have our next speaker here with us. Hey Alpa.
Hi.
Hey, hi. How are you?
Yeah, good. Thank you. Yeah. I have just shared my screen. So is it okay?
Yeah. Yes. We can see your screen, and we also were seeing you earlier. Have you stopped your camera?
No, it's turned on.
Okay. Yeah. Can see you.
Yeah. Okay. Yeah.
Right. So, hey Alpa, how are you doing?
I'm good. Thank you. And you?
Yeah, good too. So, guys, Alpa is joining us here from UK. Am I right, Alpa?
Yeah.
So, quick intro about Alpa. So, Alpa is a passionate, data and Microsoft data and technology stack person. She is working in a cluster reply at UK on, Azure data stack. So, she's a certified data. She is a certified Azure data scientist, Azure data stack professional, and also Microsoft certified trainer. Right, Alpa? So the stage
Yeah.
is all set, and we are eager to listen to your presentation about data movement and transformation using ADF.
Yeah. Thank you. Thank you all, and welcome to my session. A case study: data movements and data transformation using Azure Data Factory here at Global Azure Bootcamp Singapore 2022. The purpose of this session is to provide you a very quick overview of Azure Data Factory with a mini case study so you can apply a similar idea on your data. So now let's start with myself. Now you know me, so I'm just going to skip this, but I just would like to say that I have uploaded demo and presentation in this GitHub in a case you would like to see a repo as well. And you can find me from LinkedIn. So now let's start with today's agenda. So in today's agenda, we divided into two main parts. So in first part, I'm going to give you a very quick overview of Azure Data Factory. And in second part, we're going to see a demo. We're going to see a quick tour of Azure Data Factory, and then we're going to see a case study for data movements and data transformation. So let's start with first one, which is what is Azure Data Factory? So Azure Data Factory is a cloud-based data integration service that orchestrates and automates the data movement and transformation at a scale. It also supports a petabyte of data, and you can build your pipeline here by just drag and drop components. It is also Azure Platform as a Service, and it's a serverless. So because of this duration, you don't need to worry about compute infrastructure, software installation, hardware configuration, or web server configuration, or any monitoring or like those kind of extra things like maintaining systems or like that. Azure will do it for you. So you can fully focus on your implementation and you can do it very quickly and very efficiently. Also, because of ABO 2 reason, you only pay for what you have used. If you are not consuming, or like for example, if you're not running Azure Data Factory, then you won't get any charge for execution. However, you get a small amount of charge, which is a storage, and that can be negligible. And last but not least, it allow you to do a low code or no code solution. So you can drag and drop few components, you set few properties, and by that you can build your pipeline, you can do data movements, data transformation, you can apply orchestration and automation all in one by just a drag and drop and setting few properties. So now, so this is Azure Data Factory. Now let's move into next topic, which is what are the key components of Azure Data Factory. So in order to create Azure Data Factory pipeline or workflow, you need to have a few components. So first one is a linked services. So link service is like a connection holder. It's hold the connection string of your data source and is authorize your data source. So you can use your data source in your Azure Data Factory pipeline for activity or data flow or something else. So once you have a link service ready, you can create a data sets. So data set is a metadata of your data or your reference data. So it's hold the data in a particular format. So for example, if your link service is pointing to a Azure SQL server, then your data set hold the data in a form of the table. But if your link service is pointing to a blob storage or a REST API, so if it's blob storage, then your data set in form of the file, and if it's REST API, then your data set in form of the JSON. So data sets is a metadata about of your data or a data structure. It's hold the structure in a such a way, so you based on your link service which you use. So that is a data set. In short, data set has like hold data in form of the file, table, folders like that. Next one is activities. So activity is a steps in your pipeline or workflow, and activity do a specific task. So in Azure Data Factory, you have a list, a lot of activities available. They do a specific task. So for example, copy activity perform a copy data. Machine learning activity help you to perform a machine learning task in Azure Data Factory. You have a Azure function activity and you have a many more activities. I'm going to show you during a demo. So that are activities. And then you have a pipelines. The pipeline is a logical group of your activities. So your activities can have here sequential or a parallel. It's a steps, so you can say it's your business outcomes like workflow based on your business outcomes. So you build your workflow here, which is a sequential or parallel steps. And once you have ready your pipeline, you need to run your pipelines. And for that, you can use a triggers. So you can trigger your pipeline manually, or you can trigger it various different way, which I'm going to show you later on this presentation. So these are the 5 main components in your Azure Data Factory. And apart from this, there is a one more which I'm going to again show you during the demo. So these are the key components of Azure Data Factory. Now let's move into what can you do in Azure Data Factory. So you get idea why you need Azure Data Factory or in which scenario you use Azure Data Factory. So for that, let's see a copy data. So if you want to copy a data from different data source to different data source, then you can use Azure Data Factory. You can do a data movements in Azure Data Factory. So for that, you can use a various data sources. So I'm just going to show you here few example as a source data source. So let's see that you like to move a data from other cloud services. For example, AWS, Google Cloud, or any other cloud. You would like to move a data from on-premise system such as a SQL Server, Oracle database, or SFTP. Or you like to move your data from a system like Salesforce, CRM 365, or you like to move your data from Azure Function, HTTP Web Call, or REST API. So these are a sample data source here. There are many data sources is available, but I have just showed you sample one. So you select your data source and then you apply few basic things like you can select not all data, you select particular columns, you can rename it, and then you can set data types as well during the copy activity, and then you will load into a different data source. So this way you move your data from one data source to another data source, and you can do it by just setting few properties. So in Azure Data Factory, you have more than 100 data sources available, which you can use as a source or as a sink or both of them. And this is the link will help you to find out which data source you use as a source or as a sink or both of them. And this is called a data movements. So we can do a data movements in Azure Data Factory. Data movements is very important part in your modern data warehouse, or you can use it for a ELT or ETL. So now let's move into next one. What else you can do next? So you can do a data transformation. And for that, Azure Data Factory has a mapping data flow. And behind the scene, it's used the Spark cluster. However, you don't need to worry about it at all, and you don't need to worry about any programming language like Scala, Python, and Java, because you still can do same thing by using a drag and drop components or module in Azure Data Factory mapping data flow. So let's see, these are the simple data source I have, and then I'm applying a transformation here in my pipeline using mapping data flow. And this transformation you can do like how you, if you are familiar with a SQL language or a link queue in C Sharp, then you know that you need to do a like select particular columns, apply a computational column or new column, calculative column. You can do join, you can do union, you do so many things what you're doing in your SQL query. You can do same thing here by just drag and drop components and set few properties. So after applying transformation, you can store your result into sink or destination data source. So these are the ones, sample one. So you can use this one, or if your list is not coming, like you have a limited data source, your data source is not in list, then you can use a blob storage as well. So in Azure Data Factory for mapping data flow, there are around 18 data sources available, which you can use as a source data source or sink data source. And this is the links which help you to find out more about your data source. And this is called a data transformation. So you can do a data transformation in Azure Data Factory, and you can do it very quickly and very efficiently by just setting few properties. So this is again is a very important part in a modern data warehouse, and it is as a part of the transformation. So it do a transformation like extract, load, and transformation. So that transformation you can do it via um, ADF transformation, mapping data flow. So now let's see what else you can do. So as you know that there are 5 different components at the moment I showed you earlier in Azure Data Factory, and one more as well, so total 6. So when you create those components in Azure Data Factory UI by just a few button clicks away, behind the scene is generate a source code, and that source code is ready as a form of the JSON. However, you don't need to worry about it at all if you don't know the JSON, because it's automatically generated for you. And this source code you can use for your CI/CD pipeline. You can set up a repository and then you can create a CI/CD pipeline in your DevOps or GitHubs. That also you can do in automatically, and it help you to set up your repository using the UI. So it has a built Git integration built in, and you can use Azure DevOps Kit or you can use a GitHubs. And this one also again you can very quickly set up by few buttons click away using the UI. You can monitor your components in Azure Data Factory. You can manage your component in Azure Data Factory using UI. And last but not least, you can trigger your pipelines. You can trigger your pipelines based on like manually you can trigger. You can trigger with a schedule. So you can schedule your pipeline based on a specific time. You can trigger your pipeline when something happened in your storage, like file created or file deleted. You can trigger your pipeline based on a custom activity. For example, you can create a Azure function, you can create a logic apps, you can use a PowerShell, or you write down a code in C# language. So you can trigger your pipeline customized way, and for that you use Azure Data Factory SDK. So these are the things which you can do in Azure Data Factory. So now let's move into next one, which is a quick tour of Azure Data Factory. So I just would like to let you know that this is the link in GitHub where I'm going to upload a file which have a step-by-step instruction and which showed you how you can create your first data factory, how you can set up your first data factory repo, how you can create your pipeline, how you create data set, data link service, and how you can create your first copy activity in your copy activity with the pipelines. And there are so many small things I have mentioned step by step in this link. So in case you would like to go through again, then by reading, then you can browse that link later on. So now let's move into browser. So this is my data factory. So I created a first data factory. So when you create your first data factory, then it's look like this. So then you need to go to your resource group and then you need to browse your data factory. So by clicking there, you are launching your Azure Data Factory Studio, and it look like this. So here you can see that you can create ingest, orchestrate, transform, and configure even SSIS package as well. Here you will see that browse history if you have browsed anything recently. And here you will see more information, like you get some documents, you get some materials to study, or you can get ready-made templates as well. So these are the very important resources. You can browse at your own time. And these are the things. So it's look like this when you create your first data factory. So because you created first a data factory and you haven't set up your repository, because you have checkbox there, you have ticked it and you said you will set up later on. So it's look like this. So now let's move into modules, these three components, and then I will show you how you can set up your repository as well. So first one is manage tab. So this module help you to create your link services, for example, and you can create it very quickly. As I said you earlier, it's few button clicks away. So you click new, use these are the old source you can use, so many sources to create your link service. You just pick your source type and you just rename it. I'm just keeping as default one, but you should rename it and provide a good description here. You select your integration runtime. So this is the sixth component of your Azure Data Factory. So as you know that Azure Data Factory is a platform as a service and serverless. So you don't need to worry about compute infrastructure. But this is provided by cloud, Azure Cloud. So it is called a integration runtime. It's a compute infrastructure. And in Azure Data Factory, you have three different kind of a compute infrastructure. One is auto resolve integration runtime, which you don't need to worry, and it's a by default. When your source and sink both are in a public cloud, at that time you can use auto resolve integration runtime. But if you have on-premise data source, then you can use a self-hosted integration runtime, and you can use SSIS integration runtime if you have SSIS package and you're doing lift to shift Azure SSIS package to Azure Data Factory. So these are the three integration runtime. But as long as your source and sink both are in public cloud, public network, you don't need to worry about other integration runtime. So you can select default one, or you can click new as well, create new as well. So this is integration runtime as a default. Everything is keeping as a default. And now you can have a two choice if you select account key. So let's select a subscription, and let's select any. I'm just randomly selecting any data source and I'm test here. So this is my link service. So you can see that link service has a connection in like storage information, name and information, and authentication information. And this way you will connect your data source. Different, you can use a different data source, but I have used a blob storage, and you can create your blob storage here. But I already have it, so I'm just going to cancel this. So this way you create your link service, and this is integration runtime. Here also you can just click here, and you few buttons away you will create your link services. Integration runtime as well. I have don't need to create at the moment. This is Azure Purview, which give you a lineage view of your data. And this is a Git configuration. So you can set up your repository here by configuring here, or I will show you, you can do it in here as well. So we'll do later on. And this is the ARM template which you can use manually if you want to deploy your Azure Data Factory manually to Azure another environment. Then you can export your ARM templates from here, and then you go to your other environments and you import their ARM templates. So you will create your Azure Data Factory from one environment to another environment manually. But you can use a CI/CD as well. For that, when you publish your code here, it generates ARM templates, and that ARM templates you can use for your CI/CD, continuous integration and continuous delivery. And this is a triggers. As I showed you that there are triggers which you can create triggers for your various different way. And for that you create your triggers here same way as we did link service, few button clicks away, and then you need to publish it before using it. So that way you create trigger as well, and based on a particular time your pipeline will trigger. And this is a global parameters. If you have a common across the your Azure Data Factory, then you can create that common configuration in here, and then you can use them in your other Azure Data Factory pipelines. And these are the data flow libraries. If you want to have a customized code and you would like to upload the libraries as well here and use that open source resources. And this is a credential information. If you have your own customer key, then this is that. And this is a managed private endpoints. In a case you have a VNet, then you need to create a managed private endpoint here. So this is a managed tab which help you to manage these resources. Now next one is a monitor tab. So once you run your pipeline, it appears into this area. I don't think I have anything at the moment, but you can apply here filters as well, and you can monitor your pipelines, activities, data flow, triggers, and everything. Like you will see here status as well. You can see error as well if there is a failure, and you can redirect by just clicking here as well. You can debug monitor, and this is trigger monitor, and this is alert. So if you like to see that notification when something is happen, then you can select alert. You can create a business rule, and then you will get an alert based on your criterias. So that is monitor tip, and this is main tips. So here you're going to create your objects like pipeline, activity, data sets, sorry, pipeline, data set, data flow, and few more things. And that's you can do it by just a few button clicks away. So let's click here quickly. So this is new pipeline I created. And these all are activities. As I said you earlier, they have a lot of activities available. So these are all activities, and you can see that you have copy activity, and you can just do drag and drop, and you just need to set these two properties which is marked as here one, because you need to set it, it's mandatory. So that is your copy data activity. Let's move into that, and then here you can see that Azure function activity, you have Databricks activity, you have a general activities. Here you can see this, these all are general activities, and you have iteration activities. Like we have a for loop in a programming language, while loop in programming language. So same thing you can use here, these activities like if activity, switch, until, for each loop, and you just need to do like that. So that way you create your uh, pipelines or your logics here. And let's add one activity, because it's compulsory to have one activity at least in your pipeline. And here you can set your I'm just a setting that I would like to wait it for 15 seconds. That's it. You can rename your pipeline here, uh, like that, and you can see who has used your pipeline using this, and that's it. And then you can run right this way. So here I'm going to debug my pipelines. So you can see that this is a debugging. Let's refresh. It seems a bit slow today. But while he's doing that, I will show you that you can validate your AI is done. So here you will see monitor as well as you monitor in monitor area as well. And this kind of arrows you will get input arrows, output arrows, and there is error icon as well. Or you can have a Google icon as well. So you can click here and you will see input and output parameters as well. You can validate them. And as we haven't set up repository, it will ask you to publish again and again, like that way. So you can do that as well. Let me refresh. So this way you will create your first pipeline, and you can validate it, you can debug it on the spot, and you can let's set up now repository. So this way you set up your repository. You will select your repository repository type. You will select your tenant, um, and then you will there is a continuous button. And then you will get here list of projects. So this project you need to create. You need to go to dev.azure.com, and there you need to set up your organization, set up your accounts, organization, project, and repository. Once you have set up that and you initialize them, it appears into here. So you choose them, and then you will get a project name, and then you will get a repository drop down which you have created there. And here you will create your collaboration branch. You can choose default one or you create new one. And this is the one. Here your code goes when you publish your ADF pipeline. Your code goes to ADF underscore publish branch. So it generates ARM templates automatically, and it places your ARM template in this branch, and then you can just apply. So this way you create your Azure Data Factory pipelines very quickly, and you set up your repository as well. So this way it has a set up a repository as well. And so yeah, so you can see now you have now a repository set up here. And so you will it's appear like this now. So you can create new branch here. You can create a pull request, and when your pull request approve, your code goes into main branch or collaboration branch. And this is a live mode. So once your pull request is completed and it's deployed, then your code goes to your live ADF. So that is setup repository. Uh, and if you want to add like folders, you can add it here. You can rename your pipeline using here, and you can set up a data set as well, like how we created blob storage, like link service. Same way you can create a data set as well. You select data, so data blob storage, you select a file types, you give a suitable name, and here you need a link service. So if you don't have, then you need to create it, or you can select here from available link service. You select your container name because it's a source file. Let's quickly do that. So we selecting our source file as well. That's it. If you have know that your first row in your file has a header, then you select this one, and you can see that your schema should come from here. So that's it. So this way you create your first data set as well, and you will select lot of other properties based on your requirements. Okay, so let's go here, and I don't want to save it, so let's refresh it. So that way you can create your data set as well. And I just want to show you how you can create your data flow. That one also you can create by just here clicking buttons. This way you can see your data set, and here you can add your source, drag and drop. Everything is drag and drop, and you can select your data set. So we have I think this one, don't remember. Yeah, so you will see that here you will see how what data you have in your file. You can preview them here. For that you have to turn on debug data flow, so I don't want to do that because it take few minutes. And then you can see here that you add your other condition like join different data source. You can apply a union lookup, and you can do this kind of transformation as well. And you finally you can store your result into sink. So source and sink are compulsory. You can have more than one source, and you can have more than one sinks in Azure Data Factory. And between them you just add your different transformation like derived column. And here you are setting, because you adding derived column means you adding compute column or new column, so you give a suitable name and you select expression here, then you save it. So this way you create your data flow as well. So this is a quick, okay, let me tell you. So once you publish your this one, let's see. So once you publish this, uh, it will generate ARM templates for you. It validate it first, and if it's not validate, then it will fail. So actually I haven't set few mandatory properties. Let's delete this one. So you have to set mandatory properties. Once it's validated successfully, then you can refresh it and then you can publish it again. And when you publish it, it generates templates for you, and it deploys its publish completed, and it deploy into your live mode. So this is a quick overview of Azure Data Factory. So now let's close this one. And now let's go back to our presentation. So here we have seen many things in a quick overview of Azure Data Factory. And you can see those old things in this document as well. So now let's move into the second demo, which is a case study, data movements and data transformation using Azure Data Factory. So this is a small or very mini case study. And here I'm going to see about data movements and data transformation. So before that, I just would like to give you a small problem statements. So we had a client, and client have a third party system as well, and that third party system placing the file into a blob storage, and it's storing the file for not only one business outcome, but they have more than one business outcomes, and they're placing the file into that particular container which is related to that business outcome, and they place file there, and they do same for another business outcome as well, but they all have a different containers. And client would like to move a data from a number of business outcome to a staging data lake gen 2. They would like to just dump into data lake gen 2, and they would like to have a common pipelines to do that things. And they would like to do data transformation, but they want to do it not now, later on, and they don't want to do for a all business outcome. They select particular business outcome, they select business rules, and then they would like to apply transformations, and they would like to do it with no code or low code solution, because they don't want to hire a specialist in a particular language to do a maintenance, and they would like to do as soon as possible and as quick as possible. So this is a basic problem statement. And for that, we have created Azure resources. We have decided to use Azure Data Factory, and for moving a data from Azure Blob Storage to Azure Data Lake Gen 2, we use the data movement pipelines. So here, few business outcome would like to move a data from Azure Blob Storage to Azure SQL Server or Azure Blob Storage to somewhere else. But here I have just to use Azure Blob Storage to Azure Data Lake Gen 2. So that is one pipeline which move all file from your blob storage from a different container to your data lake gen 2 into different container based on a specific business outcome. And then later on, we have another pipeline which apply a transformation on your data, which stored in your data lake gen 2, and then it's stored into another data lake gen 2 container or Azure SQL Server. So these are the 6 resources I have used, and you need to use that for environments as well. So for that, we have now one pipelines, which is the data movements pipeline. So in data movements pipelines, we have a container in a blob storage. And here I have given example of movie days in container. So in this container, you will see the file which is related to this particular business outcomes. Then we use the destination or sync as data lake gen 2 or Azure at the moment is data lake gen 2 or blob storage, and it has a movie day staging container. So if you have a business outcome another like business outcome 1, then you have here business outcome 1 days in container, and file has to move into business outcome 1 day staging container. So that way we have given naming convention as well. And then we have a pipelines, and these pipelines move your data from your movie days in particular business outcome to a particular business outcome staging container. So this is a first pipeline, and I think let's go and see in here. So let's see in here. So this is my resource group, and you can see that I have a database. I have Azure Data Factory key vaults. This is blob storage. This is the Data Lake Gen 2, and this is the Azure Data Factory, which I created for you to like as a first data factory, how it looks. So this is the main data factory. So now let's see one by one. So first one is, let's see key vaults. So in this key vault, you can see that I have a secrets, and these secrets hold the connection strings of your data source. If he's a blob storage, then it's a access key. If he has a data like Gen 2 or Azure SQL Server or maybe REST API or anything, Azure function. So those all secrets you can store it here. It's this one is hold the function key of your Azure function. These connection string, these secrets hold the connection string for your Azure SQL database. You can see these connection strings, secrets hold the secrets for your Azure Data Lake Gen 2 connection string. These secrets hold the secrets for your blob storage. So same way, if you have any SFTP or SFTP or FTP or any different data source, you can store your secrets here. So then you can use them directly in your Azure Data Factory. So no one knows which secrets is there. It's a secure. Only the person who uploading this key vault, they know about that. And another thing is like if same database used for another 3 different systems, then you don't need to go to each different systems and upload change your new data connection string, data source connection string. If you just need to change in one place, which is a central place, which is Azure Key Vaults. So if you change just here by just generating new version of your connection string, that's it. It will use for other 3 systems or whatever systems you have a same database connection string. So that is another benefit of using the key vaults. So, and one more thing, that you need to give a access policy here. So this is my Azure Data Factory, and I have given them a select a secret, because then and then you can access your secrets from your Azure Data Factory. So now let's go to next one, which is a blob storage. So here you can see that this is my Azure blob storage demo name and container name, and here storage name, and here you can see that I have a containers. So you can see that I have a containers naming standard is like movie dash in, file dash in, business outcome 1 dot dash in, business outcome 2 dash in. So same way you can have hundreds or more than hundreds business outcomes as well, and you have particular files specific to your business outcome into that particular folders, and you will see that like this way. And then when I run my Azure Data Factory pipeline, for example, I will set up a trigger, but first of all, when I run manually, then I pass a spec code. So I'm not passing full name, but I just pass only the movie, and it will calculate this in as well. So my file will come into here, pipeline will run, it move a file it from a blob storage, this container, to a Azure Data Lake Gen 2, this container with a staging instead of in, and it will automatically create container as well. So let's see in here, you can see that. So at the moment in my Azure Data Lake Gen 2, I don't have any container related to staging for any business outcome. I have only one container, which is movie container. So when I run pipelines, then you will see that, for example, movie one, then this all 3 file has to move into here with a new container. It will create a container which is movie dash staging container, and it's move all file here. Same way for business outcome 1, business outcome 2, and many. Okay, and at the moment I don't have anything in here in my Azure SQL database. Let's refresh as well. But when I run my transformation pipeline, you will see results here. There is nothing here. Okay, so now let's go to Azure Data Factory. Is here, and so this is my link service now, as I said, and you will see that this is a keyword link service, and this is my keywords who hold the secrets So I created that first. Then I have created another link service, which is Azure SQL database. You see, I'm now connecting with Azure Key Vaults. So you cannot find out here which database or which username or password I have used to connect that database. You only see here secrets, which is a key vault name, but you're not seeing any other information, even not a server name or database name as well. So that's a very good secure things. And so I have that. Um, then I have a data lake gen 2. I have a blob storage as well, and that also accessing with key vaults. And here you can see that it's a secrets name, but here I'm not specifying which blob storage or which blob storage accounts or anything. And you can taste here. So it's authorized now. So now my link service is authorized. So when I use this link service using another data flow or data sets, I don't need to apply anything. I just need to select this link service name, and it will automatically connect with this data source. So that is the one. And this, you can see that here is stored data in JSON. So each and every objects have a data in a JSON format, but you don't need to worry about it at all because it's automatically generated. You can delete them here, and you can see who is using your link service as well. So these three data set have used this link service. So before you delete anything, you make sure that you will check here. It will give you a dependency. So you shouldn't delete it without checking that is needed or not. So that is the thing. So these are my link services I use for my demo. And this is my, let's go to here, pipelines. And we're going to see a data movements pipelines. So this is a data movements pipelines. So you can see that I have a metadata activity, which find out all file in that particular container or for a particular business outcome, and then it pass into for each loop files, and for each loop run for one by one for each files, and it copy a data from one data source to another data source. I think before that, let me turn on my debugger data flow. Okay, because it's take few minutes. So yeah, so okay, so that is the one. So let's quickly show you setup. So this is a metadata activity, and this is a spec code is a parameter. So I'm passing as a parameter. So here it can have a movie, it have a file, it's have a business outcome 1, business outcome 2, or business outcome 3. So when I run it, I will pass it. But in real time, you can trigger your same pipeline for 5 or all different business outcomes. I can trigger same pipeline for 5 different business spec code, and it will run for that different business outcomes, and it's move particular file from particular container to particular container in a staging in a data lake gen 2. So that is the one, and here you can see settings. At the moment I don't have much settings for that, and now this is the one. So you can see that I'm passing the spec code or business outcomes, and I'm getting all childs from that business outcome. So how many files you have in that business outcome container, it will pick, and it give to a for each loop. For each loop have here a result of your metadata activity and a child item, so each file or folders, and then for each loop run for that, and then it will do a specific task. So here we're doing a copy task. So here you can see that my source, which is a blob storage, which is in container, and here I'm passing the files, current files, because 8items.name, which is a current file in my for each loop, and I need to pick it from this specific containers. And this is my destination or sync, and here I'm loading into data lake gen 2, and I'm giving same file name, and I'm moving into same container. So it's copy activity, create new containers in your data lake gen 2 with concatenation of this staging that you can see it here. So this, it create this one, create this container if it's not available, and then it place a file there. And this function, you can see that there are a lot of good functions is here. You simply just click here and it will appears in here in upper this area, and then you can do a passive task. You can apply array, you can do and or if or whatever you like to do, and whatever is available here, and then you can click OK. And this is a parameter for my data sets, and file name and spec code coming from uh, data set activities in pipeline. So that's it. So it move. Okay. So now let's run this one, then you will get more ideas. So I'm running for particular business outcome. I'm not running for all business outcomes. I'm running for movie outcomes. So let me run now. And you will see that it will pick from movie days in container from here, 3 files. And it will move into data lake gen 2. It will create here new containers after finish execution, and you have all files which you have in here. So let's see here. So it's got output from here, and you will see it has a 3 files, because my blob storage movie days in has a 3 files, and you will see here file names as well. And these files I'm passing in for each loop as a list for each loop. So it will run for 3 times. Pick one files, give to copy actively pick from blob storage and paste into a data lake gen 2. And this see for each loop work for 3 times. And here you can see that this icon, it's finished as well. It showed you what is your source, what is your sink, which region they are, how many data read, writes, what time it took for transformation, what time it took for actual queuing, and those all information you will see it here. And you will see if there is any errors as well. And these are the things, arrows, which help you to give your input, output, and few other parameters as well. So as it finishes copy, let me go and see here. You will see that it has created new container, which desk staging, movie desk staging container, and it has a 3 files when I refresh this. So this is a new container, it's created in this time, and here you see that it has 3 files. It's just placed here. So that is a one thing. Let's go to run for one more time. This is a blob storage and this is a data lake gen 2. So here we have only 2 containers, and now let's run one more time. So now this time we're doing business outcome 001. So this running it, and it will pick files from this container, business outcome 001 days in container. It has 2 files. So it pick these 2 files. It goes to your data lake gen 2. It create here business. If it's not available, then it's create BO001 container, day staging container, and it plays those files as well. So let's go to see here. It's doing that. So this time it pick here 2, because it has 2 files, business outcome 001.1 CSV and business outcome 001.CSV. It's done quickly as well. For each loop run for 2 times, and it copy individual files, and you will see that where to where, blob storage to a data lake gen 2. And let's move this one. And if I come to here, you will see that now it create a new container here, because my container is not ready and I ran first time, and it has a file related to that container only. So let me refresh and see, it created this one now, and here you can see that it has placed a file. So let's go to here. So this pipeline, this one pipeline, this you can build it in 30 minutes, and it help you to move your n number of files from n number of business containers or for a business outcomes. This is very simple and very quick. You can do it. and we have parameterized it, so it's work for any business outcomes. And you can do more parameterize your link service, so you can do for different data sources as well. So that is a data movements. Now let's quickly move into here, and let's see a transformation demo. So here I have only applied transformation from movie data business outcome, but as a transformation is specific to your source file, so you have to decide your business rule, and based on that you need to create a separate transformation from your each business outcomes. So this is a second step. So here we are picking the file from moving desk staging container, and then we applying transformation and we storing them into a table. So it will goes into Azure SQL database table, and this is here we applying a transformation. So this is the one which we going to see here very quickly here. So this is loading. Now we going to see a transformation. So let's see, this is a transformation. So here you can see that I have mapping data flow, and this is my mapping data flow. Before that, let me quickly show you here. So this is my data lake gen 2, or you can say it's loading John, or you can see it's like a dumping. You're dumping everything into data lake gen. And this is a movie one. So I have 3 files, or you can have 100 files as well. And in my these files are simple and same type of files, have a same structure. So I will collect data from all these files, and then I will apply few transformation. So you will see that here I'm applying transformation. So this is my sample data. I have a list data. It has a 7 columns, and you can see that I would like to split my last column with the 3 different columns, because you can see here data are in a concatenation. So it can be in a new line, or it can be in a comma separated. So I need to convert into 3 different lines. So I have house number, house name, postcode and city, and whatever else like country as well if it has. So that is one transformation I have applied, and another transformation is filter one. So I only and only interested movie which release in a particular year, and I only interested movie which is a comedy. And after this I apply aggregation on a ratings, because I would like to know the which movie has the best rating for particular years, and that result I'm storing into database. So those transformation I'm applying. So now let's move into here. This is data lake gen 2, and here movie. So in movie we already have a file, so I just don't want to delete them. So after transformation you will see results in here in a data lake gen 2 as well, and a database as well. So now let's quickly run our pipeline. So this is a transformation. So here you can preview your data as well. For that you need to set up your parameters. So let's set up very quickly here. I'm just setting few parameters, because then we can view on the fly here results. So while it's doing previewing, so you can see that this is reading a data from a data lake gen 2 staging area for a movie business outcome. And here you can see that I'm looking into all files, whatever how many files available which is CSV in that area. And then here I'm applying the filters, and that's very simple and easy you can do it. So this is a expression. So this sorry, control chat. So these are the expression which is very very good and very powerful, and behind the scene it's use a Scala language. You can select here this inbuilt function, and they are very powerful and rich functions here. You can use them, and you just add a few information. So I'm just filtering, I'm adding just a filter condition, and you can view that result in by refreshing here as well in this area, as long as you have a debug data flow enabled. So that is a one thing. Let's close it, it maybe take few seconds. So that way you can do it like I have added derived columns, because I want to split my data address into different address. And here you can see that now I'm splitting into 4 different address. And here I'm applying the window functions, and I'm doing aggregation and group by average rating of movie. And here I'm storing that final result into database. So here I can have a millions records in my data lake gen 2, but after applying this one, here I can have only 100 rows in my SQL database. And if you like to see extra columns as well, then you can load them again into your data lake gen 2. So that's why I have two different things. So now let's go to here quickly and run this pipeline. So I'm passing the file name in movie, and now let's run. So while it's running, let's go back, and what it will do, it will read a data from data lake gen 2 staging, which we have 3 files. It's read a data from here, combine these old files, read from here, and it add here one more files, and then it has all information with less data, and it also create a new tables here with limited data. And have it's finished, still doing it, but I think I have to go back because we don't have much time. So these are the things we have seen, and then these are the naming convention we have used for in staging and final, like it's a table name or a container blob name for 3 business outcomes. And with that, I would like to conclude that Azure Data Factory help you to do a data movements, data transformation, orchestration, automation. It is a platform as a service, it's a serverless, and you can easily build a data integration projects here. And next one, we have seen 6 key components of Azure Data Factory, which is a data set, link service, pipelines, activities, and triggers, and integration runtimes, which is a compute infrastructure. Then we have seen a quick tour of Azure Data Factory, and here we have created a Data Factory pipelines, link service, data sets, debugger, flow. We have debugged it, we have triggered it, we have set up repository, and we monitor it as well. And then we have seen a demo. So here we have moved data from blob storage to Azure Data Lake Gen 2, and then we have picked data from Data Lake Gen 2, and we are inserting into Azure SQL Server in a transformation. And with that, I would like to thank you. But before that, I just want to show you if this process has finished. Yeah, it's done. So my data flow has finished. You can see, visualize it here. And you can see now, let's refresh it. You will see here new table as well. Is it refreshed? Yeah, this is a table is hand. It has only limited row and value, only 2 columns and 3 rows. And you will see here in my, let's refresh. This is the one, it's recently generated file as well. And it has 3 rows, but it has extra columns as well, all columns. So I think this is old file. But anyway, let's go to here back because we are out of time. And with that I would like to thank you for attending this session, and I would like to thank you for organizer teams and volunteer teams and other speakers and listeners. So yeah, I'm open with question.
Hey, Alpa, thank you so much.
Yeah, thank you.
Hey, guys, if you have any question, please feel free to type it out into the chat window. And so, Alpa, keep a watch out for people tagging you or reaching out to you. So, as of now, I don't see any questions on the chat group. Okay.
Yeah.
So, our next speaker is here already. And Alpa, thank you so much for making time for today. And I wish you a happy weekend.
Yeah, thank you. Bye. Sorry for I took you a few minutes.
No, it's okay. It's perfectly all right. So thank you so much. And we have our next speaker here with us. Welcome, Leon.
Hi, Priyanka.
So I hope I got your name correctly. It's right, Leon, right?
That's correct, yes.
All right. So, guys, Lian also is joining us from UK. And so, Lian, it's good morning there.
It is indeed. So good morning, good evening, good afternoon to everybody that's here as well.
Right. Okay. So, guys, Lian is a Microsoft MVP for data platform and a champion for Power BI. He heads the Power BI community in UK and also the data DNA visualization data challenge on LinkedIn as well. Right.
Yeah, that's correct.
Lian, without much further ado, I leave the floor to you and you can take it up from here. All the best.
Excellent. Thank you very much, Priyanka, for that wonderful introduction. I'm just going to share my screen. So hopefully you can all see my screen coming through now. So please just confirm if you can.
Yeah, we can see your screen, right?
Excellent. So thank you. Absolute pleasure to be here with you at the Global Azure Bootcamp 2022. In today's session, we're going to take a look at an introduction to machine learning in Power BI. Now, Priyanka's already given me a wonderful introduction, so thank you very much for that. You can reach out to me on LinkedIn. I'm also the founder of a company called Onyx Data, so please do feel free to take a look at our website. And as Priyanka already mentioned, I'm the founder of the Power BI UK user group and the Data DNA dataset visualization group, whereby we have a monthly challenge where you can actually, at the moment, win $300 worth of Amazon vouchers in this current challenge. So please do feel free to join us there. With that being said, what will we cover today? So in today's session, we're going to take a look at what is machine learning, often referred to as ML, how we can benefit from ML within Power BI, how to create a machine learning model in Power BI Premium or Premium per user, often referred to as PPU, how to create a machine learning model in Power BI for free, and I'll also give you some resources to continue your learning as well. Now, it's worthwhile noting that we're going to cover a lot of topics within this hour session, so we are going to gloss over some of the more technical aspects in an effort to get through and deliver this at pace. So first and foremost, what is machine learning? So machine learning is a branch of artificial intelligence, often referred to as AI, that teaches computers to do what comes naturally to humans and animals, which is to learn from experience. Machine learning algorithms use computational methods to learn information directly from data without relying on a predetermined equation as a model. So our key takeaways here in what we're looking to achieve is we're looking to enable the computer to learn from experience and to do this by learning information directly from data. So how can we benefit from machine learning within Power BI? Well, we can look at doing some real-time predictions, some customer churn analysis, customer leads and conversions, and predict fraud. Now, in today's session, we're going to look at a specific business use case, which is looking at customer leads. So we have a fictional company that has a problem. Now, this company has approximately a £3 million lead spend. So they're actively purchasing leads to then look to convert through their sales pipeline into sales. Now, at the moment, as we can see here, they have a very low conversion rate. So a 4.3% conversion rate. So it's not an ideal scenario. This fictional company is spending a lot of money every year on purchasing leads, but are only converting 4.3% of those leads into actual sales. Now, wouldn't it be great if we could take a look through these leads and pre-qualify them based on using a machine learning prediction to see the likelihood of this lead actually converting into a buyer? This would enable us to be able to spend less on leads because we can actively predict which leads are more likely to convert. And also, this would have a higher conversion rate because we'd be actively able to target those leads which are more likely to convert. So with that being said, let's look at how we can do this using machine learning within Power BI using Premium and Premium per user. So first and foremost, let's head over to our GitHub repository, and I'll just pop this into the chat as well. So if you do want to follow along with the links, you can. Let me just go to... Within our GitHub repo, we have two CSV files, one being our sales training data, which I'll just open in a new tab, and we also have our prospective buyer data. Okay, so first and foremost, let's take a look at our sales training data. So this is actually historic customer data. So we can see that we have some key attributes. So we have age, marital status, gender, yearly income, the total amount of children that this individual has, the number of children that are still at home, their education, their occupation, whether or not they're a house owner, the number of cars they own, state province code, their postal code, and most importantly, we have a column here which is a Boolean value representing true or false to indicate whether this customer actually was a buyer or not. So it's worthwhile bearing in mind this is historic customer information whereby we've already either had this lead be a buyer or not. Okay, so we're going to use this data to train our machine learning model further down the line. We also have our prospective buyer CSV. So this is the lead data that we actively spend £3 million a year on purchasing. Now, we can tell this has come from a transactional system because we have our prospective buyer keys and an alternative key. We also have a first name and a last name for these leads. And then we have common information from our historic data, whereby we have our age, marital status, gender, yearly income, total children, the number of those children that are still at home, education, occupation, whether they're a house owner or not, the number of cars owned, the city that they reside in, state province, and their postal code. Now, again, most importantly, as this is new lead data, we do not have a buyer flag in this example because we haven't actually contacted these leads as of yet. So what we're going to take a look at is how can we use machine learning to predict whether these leads will become a buyer or not. So with that being said, let's head over to our Power BI workspace. So I already have a workspace called Sandbox here. So we'll just open this up. Okay, and to begin with, what we want to do is let's go to New, and we want to create a new data flow. Okay. On my machine, I have to press this a couple of times. It may not be the same for yourselves. Okay, so once we've created our new data flow, we want to go ahead and define a new table. So we're going to choose a data source to define the tables for our data flow. So let's go to Add New Tables. Okay, and then we'll be presented with a familiar screen, which is Power Query Online. Now, in this example, we're looking to choose our data source. So we know that we're looking for a text CSV. So let's go ahead and use that data source connector, and we'll be asked for a file path or URL. So let's go back to our GitHub repo. For our sales training data, we're going to select the raw version of the file, and we're just going to copy the link. Go back to Power BI and just paste that link into our file path or URL. Let's go ahead and select Next. And what Power Query Online is doing at the moment is just parsing that data, and it will provide us with a preview of the data based on the first 200 rows. So in this example, we can see that within our CSV, the first row has been correctly defined as being headers, and we can see here that some of our data types, so for example, the whole number, the text, etc., have been quite correctly defined. So let's go ahead and select Transform Data. And in this scenario, we don't need to do any further transformations, so we can go ahead and save and close. Fantastic. And then we'll be asked to name our data flow. So let's just call this ML_global. And again, best practice if you were doing this in a production environment would be to give a description. This will enable other users and developers to have a bit more of an understanding of what we're looking to achieve with this data flow. So let's go ahead and save. We'll then be presented with a further screen that asks if we want to refresh our data flow. For the purposes of today's demo, we don't want to refresh, so I'm going to go ahead and close that. And we can see that we now have our sales training data within our data flow. So that's great. Now we want to add our lead data. So let's go ahead and select Add Tables. And again, we'll be presented with the now familiar Power Query Online screen, whereby we can go ahead and once again select Text CSV. Let's head back over to our GitHub repo, to our prospective buyer data, so our lead data. Let's go ahead and get the raw version of that file. And once again, copy the URL, head back across to Power BI. And once again, just paste that URL in and select next. Once again, in the background, Power Query Online will go ahead and parse that data and present us back with a preview of the top 200 rows. And again, in this scenario, we can see that our first row has been correctly defined as headers, and also our data types have been correctly presented back to us. So let's select Transform Data. Once again, we have no further transformations to make. So let's go ahead and save and close. Once again, Power BI will ask us if we want to refresh. In this scenario, we don't want to do that. So excellent. We now have our sales training data, and we also have our lead data, our prospective buyer data within our data flow, which is a fantastic starting point. Now, as we can see here, we have the option to look at machine learning models. So let's go ahead and select machine learning models, whereby we'll be presented with a nice wizard that's going to guide us through what we'll be doing. So first and foremost, we're going to look to create and train our model. So this is going to be done by selecting training data. We're then going to choose a model type. Then we're going to look at training our model before we move on to the second stage, which will be looking to improve our model if necessary. And we're going to do this by iterating and retraining before finally applying our model to our lead data and actually getting our prediction. So let's go ahead and get started. Okay, so first and foremost, we're going to walk through the wizard, and it's going to ask us, what do we want to predict? Now, in this scenario, we know that we want to understand whether a lead is likely to become a buyer or not. So let's go ahead and choose our table. We want to be able to go to sales training data. We want to use our buyer column. Okay, and let's go ahead and select next. Now, again, in the background, very quickly, Power BI has passed the information that we've sent across to it, and it's actually recommended us a prediction model to use. Now, in this scenario, as we can see here on the left-hand side, it's recommended that we use the binary prediction model. Now, this is to predict whether or not an outcome will be achieved. So in this example, Power BI has correctly recommended the right prediction model for us because we want to understand whether this individual would become a buyer or not. If this wasn't the case, we can go ahead and select here to select a different model. By doing this, we'll be presented with some different model types, some within classification and others within regression. So as we can see here, the binary prediction, so to predict whether an outcome will be achieved or not, is usually used in determining the likelihood of a sales lead converting or the probability of a customer responding to a marketing campaign. Now, again, in this scenario, this is the correct model for us, but if it wasn't, we could also choose between general classification, which is distinguishing between 3 or more outcomes. So examples of this are classifying credit card applicants into groups of those who have good credit or bad credit. And again, we could also use a regression model which estimates a numeric value. Now, regression is generally used for estimating house prices in a market based on regional factors. So let's go ahead and go with the correct model, which is binary prediction. And then we're going to be asked to choose a target outcome. So enter or select the buyer outcome that you're most interested in. Now, in this scenario, we want to understand whether the buyer value is true, whether they were a buyer with us. So we're then asked how we want to label the predictions in our training model report. So if we get a match and the prediction model correctly predicts that it will be a buyer, we want to call this value a buyer. And if we don't get a match and it's predicted not to be a buyer, then we want to label this not a buyer. So let's go ahead and select next. And once again, in the background, Power BI would just pass this information, and it's going to recommend back to us which attributes to use to get a high correlation in terms of buyer. Now, it's worthwhile pointing out at this point that generally these attributes within machine learning are referred to as features. Okay. Now, as I mentioned, some of those attributes or features have only been recommended by Power BI here. So there's others where it tells us that have a low correlation with buyer. So generally, it's best practice to either define this yourself or go with the recommendation. For the purpose of this demonstration, I'm actually going to select the majority of these values, even though Power BI has recommended not to. And I'll go on to show the reason behind this when we get into our machine learning report. So let's go ahead and select next. And then now we can name and train our model. So let's go ahead and select ML_global. For our model. Again, generally, if this wasn't a demonstration and you were doing this in a production or demo environment, then go ahead and put your description in. And then we're going to look at the training time. So the longer that we train the model, the more accurate the results. Now, this is also very true to me. The longer I train or practice anything, I'm sure it's the same for the majority of our participants here as well, the easier it becomes and the better, hopefully, that I get at it. And it's the same for our machine learning model. So we can select between 5 minutes and 360 minutes that our model will go away and train. So to train, it goes through and iterates over the data by taking what's called a significant sample of the data to train the model. So in this scenario, it uses 80% of the data to train the model, and then it actually tests those predictions on the remaining 20% of data within the model to define the prediction accuracy. Now, as I mentioned, we're going to bring this all the way down to 5 minutes. Obviously, we're doing a demonstration here, and we don't want this to be training for 360 minutes. So once we've done that, we can go ahead and save and train. And then for those of you that are familiar with Power BI, you'll notice that we have our data flow now refreshing. So that's going to go ahead and do that in the background for the next 5 minutes. At this point, I'll just stop to ask Priyanka if there's any questions. I'm going to take that as a no for any questions at the moment. So with that being said, what I'm just going to do is go on to one of our previously deployed data flows so that I can pick up from where this will finish off once it's finished refreshing. So let's go ahead and select this. So in that scenario, once you have your machine learning model trained, you'll be presented with an option here, which is our training report. So let's go ahead and view our training report. Okay, now as we can see at the top here, this report will summarize the model performance and training details that will enable us to find an optimal threshold for defining our business outcome. So we've gone away, we've trained our machine learning model. Let's just go back to our first tab here in the report. We've gone away, we've trained our machine learning model, and it's now gone on to predict whether or not there will be bias or not. So we get a bit further information here that tells us how the model was evaluated. So we can see here that the model predicted buyer probabilities for a test set of 1,563 records, and then compared the predicted outcomes based on the current selected threshold. Again, in today's session, because it's very much introductory, we'll gloss over some of the more technical terms like the AUC, and let's go and dive into our top predictors. Now, you may remember that we said that different features would have a varying influence on the predicted outcome. So this is where Power BI showed us a high or a low correlation in terms of the features that we were selecting. Now, in that scenario, I selected some of the features which had a low correlation, and we can see that quite clearly here. So we've got our top predictors by influence, whereby age, marital status are the highest predictors. And then we can see that some of those with a low correlation are appearing further down here. So Power BI was actually correct in terms of recommending which features had a low correlation. Now, by selecting the likes of age, we can start to see the likelihood of different categories of ages being buyers. So for example, for our sales company, we generally have buyers that are either 46 years old or less, or they fall into the 46 to 59 years old category. Similarly, for marital status, we can start to see that the majority of our buyers, based on historical data, are single. We also can see that the total of children for our buyers is generally 1. Okay, so we're starting to get some key information back about our leads that we can go on to use when purchasing new leads. So again, we're just going to take a look at this information here. Again, we're going to not go into too much detail in terms of the technical attributes because we've got a lot to cover. So the way to read this confusion matrix, I'm just going to go over to this screen here. So what we're looking at is greens. Okay, so we want to have a true positive prediction, and we also want to have a true negative prediction. Okay, we want these to be high values, and we would like our false negative and false positive, so these are incorrect predictions, to be lower values. Okay, so with that being said, we can see here that we have a high value for whether the buyer is actually correct, but we have a very low value for when predicting a non-buyer is correct. Now, what we have is increase the recall or increase precision. Again, we would go into a bit more detail in a more intermediate session, but we can see that by adjusting or increasing the precision and decreasing recall has an effect on our predictions. Okay, and again, if we go all the way to further down to our precision, we can see that we now have more true negatives that are being correct. So generally a good starting point here is around 0.5. Okay, so let's just, okay, and then we can go ahead and move on. Now, again, we have a bit of information around the cost benefit analysis, which again probably is overkill for what we're looking to do today. We can go into our next tab, which is our accuracy report. Now, within this, it just goes in to show how accurate our machine learning model has performed. Now, the best bits taken into account here probably is the ideal, which is our teal or turquoise dotted line. What would be a random guess as a prediction, which is our black dotted line. And our yellow line here is how the model actually performed. So we can see that at the moment it's right in the middle of being the ideal or a random guess. So again, for the purposes of today, it's not a bad prediction. Let's go ahead and go on to our training details tab. And again, if I just scroll to the top, it gives us a bit more information on how the model was trained, the amount of iterations that were run, the final classifier model that was used, and how it performed over those iterations. Again, I do go into this in a bit more detail in a more intermediate session, but for the purposes of today, with it being an introduction, it's just good to be aware of. We then go into a bit more information around the features that we used and how many models were used for the final predictions. So once we're happy, we can go ahead and apply our model. Again, as this is already run on this side, I'll just show you what you would do in your scenario before going ahead and rejoining our demo. So what we want to do is we want to have our prospective buyer, so our lead information, and we want to have a new column, which is going to be called, let's leave it as buyer outcome. And what will happen is we're now going to apply this prediction model to our lead data. So we're going to look to predict whether those leads will actually become buyers or not. So again, we want to apply that to our prospective buyer table. And in your scenario, if you're following this along, go ahead and save and apply, and that model will be applied to the lead data. In this scenario, I'm just going to go ahead and cancel and pick this back up because it's already been applied in this version. Okay. So once you have applied that, go back to tables, and we now have an additional 4 tables available to us. Okay, so we have our buyer prediction training data, which is that 80% snapshot of data that we use to train our model. We then have our testing data, which is the 20% that we use to test and iterate over. And then we have what we're most interested in here, which is our prospective buyer enriched buyer prediction. So this table is our lead data, which now has our prediction on it as well. So we're now done in the Power BI service. We've trained our model, we've applied it. Let's go ahead and open up a Power BI desktop file. And let's actually start to see if we can report on that machine learning model now. Okay, so once this opens, we're going to be presented with our familiar wizard that will ask us if we want to get data. So we do. So let's go ahead and select get data in the top left here. Okay, and then we'll just be guided through the UI wizard in terms of where we want to get our data from as our data source. Now, as you remember, we created this machine learning model within a data flow. Okay, so what we want to do when this splash screen loads is we want to just search for data flow, and we want to go ahead and get Power BI data flows and connect. Okay, now Power BI Desktop will establish a connection to the Power BI service, and it'll present us back with all of the data flows that we have available and our workspace. So the workspace that we used was a sandbox, and again we want to go to the one that was previously deployed, as this one is still currently training. So let's open up the ML webinar deployed. And as I mentioned before, we want to use the table, which is our enriched buyer prediction. Okay, so let's go ahead and select that. We'll be presented with a preview of our data. So again, we can see that this was the transactional data. We have our first name, last name, all of our features. And most importantly, we now have some new columns. So we can start to see buyer prediction outcome, buyer prediction score. So let's go ahead and transform our data. And we can probably see this in a bit more detail. So we'll be presented with Power Query within the desktop, and I'm just going to go ahead and scroll across as we were just doing previously to see our new columns. So we have our outcome. Now, our outcome is our prediction based on that model. So whether this lead will actually be a buyer or not, based on a Boolean value, so true or false. We have the prediction score presented to us, which is the actual scoring on how accurate that prediction is. And we have a couple more columns, which again, from a reporting or machine learning model perspective, are not of too much interest to us at the moment, but we have an explanation of why the prediction was predicted that way, and then we also have an explanation index. Now, generally, as I mentioned, you wouldn't need to use these columns, but they're just available to you. So let's go ahead and close and apply. Okay, now again, Power BI Desktop will just go away, evaluate that data, and load that data into our model. Okay, which would just take a couple of moments. It's not a large data set. Okay, and then we now have our lead data, which we can go ahead and let's get our first name, last name. Let's also go for our outcome. So this is our prediction. Just close those panes. Let's go for our prediction score and our outcome. And let's just change those around. Let's make this slightly bigger. Okay, and I'm just going to put a rudimentary filter here as well for our outcome that will allow us to just slice between whether this is due to be a buyer or not. So here we can see that we're presenting our lead's first name, our last name, the buyer prediction outcome, so whether with our machine learning model predicts they will be a buyer or not, and the accuracy of this score. So let's go ahead and select true. So this will just show us all of the leads that have a true value in terms of being predicted as being a buyer. And let's sort this by the prediction score. Now, this is fantastic. We now have lead data, which is being predicted of having a positive outcome of being a buyer and the accuracy behind that outcome. Okay, so we can present this to our sales team and give them a bit more of a head start, shall we say, on leads that are more likely to convert. Also, we can also filter those to be false, and we can also get rid of those leads which we feel aren't going to convert with us at all, and not pay for those leads and present them back. So a huge cost saving from a lead perspective there, and hopefully an increase in conversion as well based on our prediction model. So with that being said, that was the end of our first demo. So we've now understood how we can make the machine learn, okay, using Power BI Premium or Premium per user and the benefits that can have to a business, okay? So as we mentioned here, although this robot looks very unhappy, no machines were harmed in the making of this webinar, okay? So with that being said, that's great. We can use Power BI Premium or Premium per user to build out our binary prediction machine learning models to predict whether or not our leads will be a buyer. But unfortunately, not everybody has the budget for Power BI Premium or Premium per user. So how can we do this using Power BI Desktop free or using Pro? So we do have another approach, okay? Now, there are some limitations to be aware of with this approach. So by going down this route, we don't have access to any machine learning ops, so commonly referred to as ML ops. We can only use the Power BI Personal Gateway. It's going to be very difficult to manage dependencies. And also, by going down this route, it's not very scalable. Okay, so with that being said, as I mentioned, there are some limitations to this approach, and we do look at the use of Azure AutoML again in our intermediate session. But with that being said, we need to be aware of some alternative tools that we can use within Power BI Desktop to enable us to be able to do machine learning within Power BI. Now, these tools are Anaconda. So Anaconda is an open source individual edition distribution that is basically the easiest way for us to enable Python, R, and data science environments on a single machine. And we're also going to look at a Python library called PyCaret. Now, PyCaret is an open source, low-code machine learning library in Python that allows us to go from preparing our data to deploying our data or model within minutes. Okay, so with that being said, let's just dive straight into our next demo. Okay, now, as I mentioned, you can go ahead and download the Anaconda distribution, and I'll just put this in the chat window as well for you to be able to go and get the Anaconda distribution. So just download and install Anaconda on your system. Now, it's worthwhile noting that you may need to get the Microsoft C++ build tools to install some additional libraries that may not be on your system. So again, I'll just put that within the chat for you as well. Now, once you've installed Anaconda and those tools, sorry, let me just minimize, you can go ahead and just search on your system for Anaconda. And what we want here is the Anaconda prompt. Okay, so go ahead and open up the Anaconda prompt, and you'll be presented with the Anaconda base environment. So what we want to do is create a Python environment that we're going to use to install our packages, which we're then going to make Power BI aware of. So let's go ahead and use the activate command to activate, in this scenario, an environment called data science _UG. Now, this environment already exists on my system, and so it's very quick. But you'll notice here that we've now switched from our base environment to our data science _UG environment, which is great. Now, what we want to do is use the conda command to install pip. Now, those of you who are not familiar with Python, pip is basically a package manager that will enable us to be able to install other libraries that we're going to need for this scenario. So let's go ahead and install pip. Now, once again, as I mentioned, this is already installed on this system, so the installer should go through relatively quickly. It may take slightly longer in your environment if it's installing for the first time. As I mentioned, in this demonstration, we do have a couple of updates. In this demonstration, we are going to try and run through a pace because there's a lot of obviously technicalities to cover and a limited amount of time left. So once we've installed pip, we can then use pip by calling the pip command to install the package that I mentioned earlier, which is PyCaret. So go ahead and type pip install PyCaret. Again, this library is already installed within this system, so it will go ahead and tell us that most of those requirements are already satisfied. Now, once you've completed that, we now have a Python environment which has all of the packages and libraries that we need to go ahead and create a machine learning model in Power BI Desktop for free. So what we need to do next is make Power BI aware of where that Python environment is. So let's go ahead, let's create a new Power BI Desktop file. Okay, and again, we'll be presented with the Power BI Desktop getting started wizard, which we don't need for this scenario. So let's go ahead and close that. What we want to do first and foremost is go over to our file, select options and settings. Then we want to go to options, and we'll be presented with our options window. And in our global settings, we want to go ahead and go to Python scripting. Our environment's already defined here. If it's not in your scenario, then you'll go ahead and change this drop down to be other. And then you'll browse to your Anaconda free install, go to your environment, and then select the environment which you created, which in our scenario was data science underscore UG. Now, once you've done that, go ahead and select OK. And Power BI Desktop will now be aware of where your Python library exists, and you'll have access to those scripts, to those Python libraries that we're going to need for this machine learning model. So with that being said, what we now need to do in a very common scenario to where we were previously is go ahead and get our data. Now, doing it in the desktop is slightly different. So we're not going to use a text CSV data source. We're actually going to use a web data source. Now, again, very commonly, let's go back to our raw files. We want to get our sales training data by copying the raw file URL and pasting this in, and then selecting OK. And again, Power BI, Power Query would just go ahead and pass that data. Now, straight away, we can see a difference in terms of Power Query Online and Power Query in the desktop. So it hasn't identified that our first row are actually headers. So let's go ahead and transform our data. And also, it hasn't actually correctly defined our data types either. So what you would generally do here is select use our first row as headers, and then go ahead and define your data types. Okay. In an effort to stay on time, I'm not going to go through and do that with all of the columns. I'm just going to show you how we get the data first and foremost, and then I'll move on to a pre-prepared Power BI desktop file as we move forward. So what we then want to do is go ahead and get our lead data. So let's go ahead and select web again as a data source. Let's go back to our GitHub repo. Go back to our lead data, get the raw URL, copy and paste that in, and go ahead and select OK. Okay. Now, again, very similarly, Power BI will go ahead, pass that data, and preview us back the first 200 rows. Now, again, in this scenario on the desktop, our first row being headers has not been correctly defined, so we do need to go ahead, make some transformations, and very similarly, the data types here are not aligned. So with that being said, that shows you how to get the data into Power BI Desktop. And again, in an effort to stay on time, I'm just going to move over to a pre-prepared file. It looks like we have something in the chat. That's fine. Okay, so in this pre-prepared file, I'm just going to pick it up from where we left off in the last one. Okay, so just going to go back into our Power Query editor, which hopefully shouldn't take too long to load. And what we're going to do when that does load is just, let's actually close that, it seems to have frozen, and try that again. Interesting, the demo gods are not being good to me today. So, okay, for that file, Power Query isn't loading for some reason, so we'll pick this up. Okay, just bear with me a moment. Let's close this file and try to reopen it. And because we're going to go into a bit of Python scripting, it would be ideal to pick this up from a file that already exists, because as we saw before, when we were training the model, it does take a few moments to train the model as well. If there are any questions at this point, then please do feel free to ask just while we get this file up and running. The joys of the demo gods. Okay. Excellent. We'll just jump into Power Query for this file by right-clicking and selecting Edit Query. Okay, fantastic. So apologies for the slowdown there. So we're going to pick this up based on where we were. So we had our files imported. So we have our lead data, which is our prospective buyer data. And we also have our sales training data with our files imported. Okay. We've promoted our first row to being headers. And we've also changed our data type. So you may remember that I mentioned our data types were incorrectly defined. So we've also changed our data types. Now, as we've enabled our Python environments within Power BI, we can start actually running some Python scripts for free against our Power BI data. So let's go back over to our repo and start to take a look at some of the other files that we have within our repo. So we have these Python scripts, which are defined as 1, 2, 3, and 4, and we want to follow these through. So first and foremost, we want to open up our impute dataset for ML Python script. Okay. And again, as I mentioned, we are quite low on time. We're going to gloss over most of the technicalities behind what we're doing here and just give a high-level view of what we're doing. So go ahead and select the raw version of this Python script. We want to copy all of this and then head back over to Power BI, which I was hoping would be yes. So we're up and running now. So for those following us at home, we want to go ahead on the ribbon and look at transform. And we have our run Python script. Okay, so go ahead and select run Python script and you'll be presented with our little window that will pop up here, which will allow us to input our Python script. So what you want to do is just paste in that script that we had presented to us, that I just presented to you from the GitHub repo. And what this script is doing is it's actually going to change all of our data types and map those values to being encoded. Okay, so for example, we have for sex, we have male and female. We need to encode those values for it to be able to be run through our machine learning PyCaret package. Once you've run that package, you'll be presented with the data frames that have been created within that script. The one that we're interested in is the df underscore imputed table. So go ahead and select the table there, which will present you with our new encoded values. Now, you can see this very clearly on the likes of gender and marital status. So these two, the values either have male and female in the case of gender, which have been encoded to 1.0 or 0.0. And similarly for marital status, we have either married or single, which again have been encoded to 0.0 or 1.0. So we've now prepared our training data to be able to have our machine learning model run its predictions on. So we want to go ahead and run another Python script, which will present you again with the now familiar scripting window. And you want to go back over to our GitHub repo, select our second script, which is going to train the machine learning or the data model for machine learning. Now, again, if you open that in a new window and go to the raw version of that script, you can copy and paste out that script, paste it into Power BI, into here, and then go ahead and select OK. Now, what we're doing here is exactly the same as what we did in Power BI Premium or Premium per user in the workspace in terms of defining our model and how we want to run that model. We're just doing it using Python scripting, okay? So once you go ahead and select OK on that, that will go ahead and run in the background. Now, if you are following this along, it will take some time because as you saw previously, we can define the time period from 5 to 360 minutes in Power BI Premium of how long we want to train this model. Once you've done that, we'll be presented back in Power Query with all of the data frames from that script. Now, the one that we're interested in is our predictions data frame. So you can go ahead and select table here, and we'll be presented back with our final sales training data set, which now looks very familiar in terms of all of the columns that we have. But once we've run it through this way, we now have two additional columns, okay? So we have our label column, which is the prediction from our model, and we also have our score. So at this point, we now have our machine learning model, which has been trained. Now, what we want to do is apply this to our lead data. So let's go ahead and select our lead table, and we'll pick this up from where we would have been from getting the data. So we've now promoted our first row to be headers, and we want to go ahead and run a Python script. Now, very similarly, within this Python script, we need to encode the data. So to do this, let's head back over to our GitHub repo. Select our third Python script, which is impute the new data set for predictions. So let's open that in a new tab. Okay, again, we're going to look at the raw version of that script. Copy this out. I've written all the scripts, so you don't need to. And we're going to paste that into our run Python script. Now, again, we're doing exactly the same as what we did to our sales training data in terms of we're encoding our column, our attributes or features to be ready to be able to be used within PyCaret. Okay, so once you've done that, go ahead and select OK. I'm going to cancel as it already exists here. And you'll be presented again with the now familiar data frames from that script. We're interested in the df_imputed table, so go ahead and open that. And once again, you can see that we'll be presented back with our encoded values. Okay, so we now have our data prepared to be able to run the prediction model. So go ahead and we're going to run our Python script. Okay, you'll be presented with our shortest script yet, but our most powerful. So let's go ahead in our repo, go to script number 4. Let's open that in a new tab. And what we're going to do here, as I mentioned, our shortest but most powerful script is apply that machine learning model to our lead data. Okay, so let's go back over to BI, paste this script in, and you'll go ahead and select OK. I'm going to cancel this as it already exists. It may take some time on your side. We'll be presented back with our now familiar as well predictions table. Go ahead and select that table. And we will now see that our lead information has additional columns. Okay, so the additional columns we have here now are the label and the score. So very familiar to where we were in Power BI Premium or Premium per user. We now have our lead data, which has now had a machine learning model prediction applied to this, and the scoring on the accuracy of that prediction now available to us. Now, within this demo, you may notice that we've encoded actually our first and last name as well, to be able to be used for the machine learning prediction. So what I've done just to circumnavigate this and present back to you the same type of reporting that we were able to achieve in Power BI Premium is just gone ahead and changed the type of our prospective buyer key, duplicated that table. So you may remember that we have our prospective buyer table available to us with first and last name. I've created a relationship between these two tables based on those values, which will allow us to then be able to pull in the first and last name from the duplicated table. So let's go ahead and close this. If you are following along, please do just close and apply on your end so that the changes are saved. In an effort to not rebuild the data, I'm not going to close and apply. And then let's go back to our visualization window. Now, as I mentioned before, we now have our prospective buyer table and our prospective buyer 2. So we want to get our first and last name from the non-encoded table. And then we also want to get our label and our score from our lead data that has been passed through our machine learning model. Let's just make that slightly bigger. Let's go ahead and get our rudimentary slicer back based on our label. Okay, and then what we can do, again, let's select true. Now, these are all of the values which our machine learning model within PyCaret has predicted to be buyers for us. Alternatively, we can also select false, okay, and be presented back with those leads that are predicted not to be buyers with us. Now, once again, extremely powerful for this business use case in the fact that we can either ask our sales team to start calling those leads which have a high likelihood of being buyers with us, and we can not purchase those leads that have a high likelihood of not being buyers with us as well. And we can do this in Power BI Desktop for free. So with that being said, that's the end of that demo, and we just pick back up our presentation and have some time for some questions. We now have a vision, but how can we take this to a new level? So we can use Python and PyCaret to do outlier detection, topic distribution, association, rule mining as well, and the list goes on. And like I say, we can do this now for free within Power BI Desktop. As I mentioned, there are some more resources that you can use to continue learning. So a good friend of mine and fellow MVP, Luca Zavarella, has a book called Extending Power BI Using Python and R. You can also look at some websites like KD Nuggets and Towards Data Science, which go into more detail on how you can use PyCaret or use AutoML within Power BI. As I mentioned, the Anaconda distribution as well as a fantastic website. And Microsoft also have some documentation on how you can use Power BI to build out machine learning models in Premium and Premium per user. So with that being said, I'll just finish here now for any questions.
Thank you, Leon, for a wonderful session. You guys, if you have any questions, so you can ask or you can put in the chat box.
Hey, Leon, this is Sanjeev here. Can you guys hear me?
Yeah.
Yes, Sanjeev.
Wonderful, sir. Thank you very much for gracing us and making time. Fantastic presentation. The question I have is not so much on the ML model, but on visualization, So there is a Python visual as well in the canvas, if you will, if I may call that we could use, right? So you run your great model in Power Query, and then you bring the results over to the canvas. Could we take those results and visualize it in the Python visual?
Yes, of course. So once you have your results, you're open to use all of the visualization tools available to you that are generally available in Power BI. So again, you can do this either using the Python that we went through with Power Query for free, or alternatively, you could still use this using Power BI Premium or Premium per user by connecting to the data flow.
Gotcha. I mean, to kind of ask a follow-up. So my specific question is, it may not be machine learning in my case. It may be some kind of an engineering model, Fourier series as an example, right? So I run that Fourier series using the Python engine. So, or like, Bessel functions, whatever, So I get that output to my Power BI canvas, right? Yes. The beautiful thing about like the Python visual is that it gives me a 3D visual, of the surface plot, right? Like MATLAB.
Okay.
But the thing is, I want to take that output from the data that is on the right-hand side in the fields, right? And then shove it into the visual, the Python visual. So you're saying that is possible?
It is, yes. So once you have your data loaded, you can interact with it in exactly the same way as any other data that you've loaded from any source. So yes.
Beautiful, sir. Thank you very much. That's wonderful to know. Thank you very much.
Oh, thank you very much.
And very nice seeing Gasif there with a big smile and Nilesh after a long, long time. Thank you.
Cheers, good to hear your voice, sir.
Thank you.
I hope we can meet in person very soon.
Yeah.
Please invite me as well.
Yeah, sure.
Yeah.
You are.
Thanks, Leon. Thanks for the wonderful session. Apart from Sanjeev, anybody else has any other question for Leon? We still have got 5 minutes, so maybe a couple more questions before we close the session and close the day as well.
Yeah, I think it's the last session, so people are a bit shy and
no problem. I think that we have
tick tick 1, tick tick 2, tick tick 3. Okay.
Exactly. No, I know we did go through quite a lot of information in a short period of time there, so it's a lot to absorb, and we did it quite fast as well. But really wanted to cover off the fact that you can do this not just with the paid version, but also for free as well. So.
Okay.
Yeah. Please share the slides either in the PPT format or the presentation itself, whatever format you like, Leon. Would be good to share it with our audience.
Yeah, definitely. What I can do whilst we're still on the call, actually, is I can just put that directly into the chat if that's the easiest option.
Yeah. we can take it from there and share it with the meetup page and the other audience over YouTube.
Excellent.
Yeah, so while you're doing that, I think we had a great event. So thank you to all the speakers, all the attendees who attended, and I hope you got to learn something new during the day. I personally got to learn few things on the sessions that I attended. And I'm sure next time when we conduct this event or any other community event like the AI Bootcamp, hopefully we can meet in person. Personally, I am a bit tired of doing virtual events, and I'm looking forward to meeting people in person now that we have the opportunity to start the in-person event. I'm looking forward to them. So thanks once again, and have a nice evening. Have a good weekend ahead.
Thank you, everyone. Thank you, Nilesh. Hope everyone have a good weekend. Thank you.
Thank you. Bye-bye.